I want to start this series from a question. Why? Why everyone wants to learn DSA? And why are those big tech giant companies like Google, Amazon, Facebook, and you name it, only hire those engineers who are good at DSA or who knows DSA? If you are someone who don't know what a DSA is, well, I'm sorry to say this, but you are not even allowed to apply for those jobs like in Google or Amazon or those big companies. So we are going to be diving into this question in a more great detail. Now, first of all, we have to ask ourselves, is there what in the world is this technology which we are currently learning and why? Then we are going to be jumping into the why part. Okay, so like why are we learning it? So first of all, what is a data structure? A data structure is a specific way of organizing, storing, and accessing the data. If you don't get this definition, you don't have to worry about it, because I promise by the end of this course, you're going to be calling yourself as a data structure and also the algorithm monster. Okay, that's going to be my promise, I guarantee. Okay, so that was just a Wikipedia or a ChatGPT definition of what a data structure is. But now the question is, what in the world is algorithm? We hear these two terms like a lot. Like, what is a data structure? A data structure is a way of organizing, storing, and accessing the data. And we're going to be diving into this definition in a more great detail. So a set of instruction that tells a computer how to do something, or you can also say a step-by-step solution of a problem, is called algorithm. So I want you to just focus on this area. A step-by-step solution of the problem is called algorithm. Now, I know a lot of you will say that, Hussein, these are just definitions that you copied from, like, I don't know, ChatGPT or Wikipedia or something like that. We want examples. So now let me just give you example. But before I give you example, I want you to just write some code. I don't care whichever kind of programming language that you want to use, but throughout the course I'm going to be using a JavaScript. So I want you to just go ahead and perform this challenge, and this is the most simple challenge that I can ever give you. So what I want you to do is that I want you to create an array. If you are solving this problem in the Python, you gotta go ahead and create some sort of a list. Okay, so arrays and lists, both of them are like exactly the same thing. I mean, like, not exactly, but you get the idea. So create an array with 5 student names. That's it. After that, create a function which takes 2 parameters, like all students and also the student specific name. So then I want you to iterate over through all of that students which we are going to be passing into that function, and then I want you to iterate over through all of that student, and I want you to only find that specific student name which you are going to be passing right here. So basically what I want you to do is that I want you to create some sort of a function in which we are going to be passing a list of students, spread over through all of that students, and then only search for this specific student. Okay, so give it your best shot. If you can do it, that's completely okay. And then watch a solution. Then I'm going to give you my solution, but first of all we have to do a bit of work. So I want you to pause the video and do it by yourself, but first of all I want to show you something. Now, I know a lot of you will ask me, Hussein, like, what are the prerequisites for this course? So the only thing which you have to do is that you have to watch this course. Not from the top to bottom, but yeah, you have to be good at JavaScript. And by the way, you are not just limited to work with JavaScript programming language. You can use, like, here are top languages. So you can either use JavaScript for this course, you can use Python, you can use Golang, you can use TypeScript, you can use Java, C++, or any kind of programming language that you like. You can totally do that. But throughout the course I'm going to be using a JavaScript because my entire channel is about a JavaScript. Okay, so that's the only reason I'm going to be using JavaScript, but there are no hard rules about JavaScript anyways. Okay, so that's the requirements. And also throughout the course I'm going to be using a VS Code, and you are more than welcome to choose whichever kind of code editor that you like. So I want you to just come to this link, which is code.vscode or visualstudiocode.com, and it's going to bring you to this landing page right here. I happen to be using a Windows, so it automatically detect my operating system right here. But if you want to download that for like Mac OS or Linux or Windows, so you can totally do that. And after that I'm going to be creating a folder, and I'll just give it the name of like DSA. And once again, you are more than welcome to give it like any name that you like. Now I'm going to right click on this folder, and now let me open that in my VS Code. Now I successfully opened this folder in my VS Code, but chances are your code editor will not look exactly like mine because I've changed a lot of things inside there. And if you want to make your VS Code exactly the same like mine, so I have a complete course on there, and I also have a complete videos on there. If you want to check it out, so feel free to do that. Next, go to the extension area and search for a code runner, and once you do, then click on that and install that in your machine. I already installed that. So the next thing that you have to do is that you have to hit F1 on your keyboard and then search for shortcuts. Okay, so shortcuts. Okay, so here we have a few options. So we have the first one like toggle the keyboard shortcuts, but the one I'm interested in is the open keyboard shortcuts. So I'm gonna just click on that, and it's gonna give me the entire list of keyboard shortcuts that I have in my VS Code. So I'm going to just search for a code runner, and once I do, then I'm gonna choose this second one, which you can see right here. Okay, so I'm gonna just double click on that, and chances are in your case it may not look exactly the same like mine, but you have to double click on that and then hold Control and then hit enter. Okay, so once you do that, then hit enter one more time. Okay, so this is how you're going to be creating a shortcut for yourself. Okay, so now that's successfully done. I'm gonna go ahead and just create a new file. You are more than welcome to give it like any name that you like. So I'm gonna just give it the name of like index.javascript or JS, because I'm gonna be using a JavaScript. So now it's my turn to show you the solution for that problem. So I'm gonna just create like students database, and inside there I'm gonna just store a few students like Jordan and also Eric and also John and Michael or something like that. I'm gonna be creating a function, so I'll just give it the name of like find student, and it's gonna take two parameters like all students and also student name. Okay, so now inside there we are going to be iterating over through all of their students, like for let I equals to 0 and I is less than all student dot length and then I plus plus. Now inside this loop we have to find out that specific user or student. Okay, so I'm going to be using like all student, and we are going to be taking the index, which simply means that we want to iterate over through every single item inside this list. Okay, so this will gives us like first of all Jordan, then it's going to give us Eric, then it's going to give us John, then it's going to give us Michael right here. Okay, so we wanted to iterate over through all of these items inside this loop, and then we want to search for this specific one, which you can see right here. So we are going to be searching for this specific student name. So like let's suppose instead of providing like student name, I'm gonna just provide like Eric, so which means like we are now searching for the Erics. So what this code will do is that it's gonna first of all ask this one like, are you the Eric? No, I'm not. Then it's gonna jump to this one, are you the Eric? Yeah, I am. So it's gonna put it right here, but we are not done yet. Then it's gonna still ask this one like, are you Eric? No. Are you Eric? So no, I'm not Eric. So it's gonna give us the result of this one right here. Okay, so now let me just get this back like student name. And now what I want to do is that I want to just log that to the console, and I'm going to just say found, and here we are going to be passing the student name. Okay, so now let me just save this file, and now underneath there, let me just go back. I'm going to just call this function by find student, and I'm going to be first of all passing for this parameter all the student database. So now let me just pass there, and now for this another parameter, I'm going to just only search for this Eric right here. So I'm going to copy there, and now let me just place that right here. Okay, so now if I run this code, so what are we getting? We are now getting like found Eric right here. And why is that? Because we are now iterating over through all of these lists, and we are only searching for Eric, and we already have Eric inside our list. So that's why we are now getting this found Eric right here. Now that we successfully solved this problem, but now the question is, what was that specific data structure that we used for this problem, and what was the algorithm? So the answer is, this array is a data structure, and throughout the course I'm gonna make you a monster in the data structures, but this is just like a one data structure that we currently use. Okay, so this is a data structure that we use, and this is the algorithm that we use for finding that specific user. So data structure allows us organize, store and access the data, which we are doing right here. And on the other hand, algorithm is just a step-by-step solution for our problems. Okay, so these are just a step-by-step solution for our problem. So this is a data structure, and this is the algorithm for solving that problem right here. There was a lot of explanation about data structures and algorithm, but now still we have another question like why? Why should I even care about learning a data structure and algorithm? Well, if you want to go at these stuff, so you have to learn data structures and algorithms. So if you want to be efficient problem solver or strong coder or interview successor or coding confidence, if you want to get all of these stuff, so you have to learn data structures and algorithms. And these are just a few bullet points. But the real thing about data structure and algorithm is it's gonna make you become a great problem solver. So that was the last slide, and throughout the course we are going to be only focusing on these two words: become a great problem solver. Okay, so that was the first video of my data structure and algorithm, and I'm gonna see you in the next video. Bye bye. Welcome to the bigO notation masterclass. So in this course I'm gonna be teaching every single thing that I know about the bigO notation. And if you haven't checked out the previous video where I introduced the data structure and algorithms, so you can go ahead and watch that video. Otherwise, what I want you to do is that I want you to just solve this problem by yourself, and it doesn't matter like whichever kind of programming language that you want to use for this problem. You can use JavaScript, you can use Java, Python, Rust, or any programming language that you like. So I want you to just go ahead and perform this challenge by yourself. And if you can do it, you gotta watch my previous video about that. Okay, so now let's get into the main topic, which is called the bigO notation. Now that we successfully solved our problem, but now the question is, how can we tell whether our code was a good code or a bad code? I know a lot of you will say like, yeah, you give us some sort of a challenge, we solved that challenge, so why should I even care about the code quality? Like, why should I even care about whether my code was a good code or a bad code? Well, you don't have to, and you never will care about whether your code is a good code or a bad code. But if you are applying for some sort of a job, the interviewer will ask you this question like, how can you tell whether your code was a good code or a bad code? Or they will ask you like, what is the space complexity of your code? What is the time complexity of your code? Or what is the bigO of your code? So for all of those questions which I just mentioned, here is the answer, and the answer is the bigO notation. So now I know a lot of you will say like, finally we are now talking about the bigO notation. So what is a bigO notation? Now let me just introduce that. So a bigO notation helps us understand how long an algorithm will take, and this area is something called the time complexity, like how long an algorithm will take to run. This area is known as the time complexity, or how much memory it will need as the amount of the data it handles grows. So this area is known as the space complexity. Let me just say that once again. So bigO notation helps us understand how long an algorithm will take to run. This is known as a time complexity, or how much memory it will need as the amount of the data it handles grows. So this is known as the space complexity, and to combine both of those terms, it becomes something called the bigO notation. So you can think about the bigO notation is like the language that we speak to communicate with others, like whether our code is a good code or your code is a good code or a bad code. That's it. Now I know that was a lot of gibberish which I just said, so now let me just break this down for you. So imagine you have a giant mess to clean. bigO notation is like saying how the cleaning time grows as the mess gets bigger. Okay, so that was just an analogy which I want you to know. Okay, so the first bigO notation which we are going to be discussing is something called the O of n. And by the way, this is not a mathematical term. You don't have to know mathematics for the bigO notation. I mean, like for one, which you know, you don't have to worry about that. So O of n signifies that the execution time of an algorithm grows linearly in proportion to the size of the input data n. I know you will say that, Hussein, I don't get it. Like, what's the point of all of these gibberish word which you just said? So now let me just break this down for you. Okay, so you can think about the O of n as the number of item in the input data increases, the time it takes for the algorithm to run increases correspondingly. I know, still you don't get it. So now let me just break this down a bit more. So imagine you have a list of groceries. To find a specific item, like for example the milk, you might need to scan through the entire list. So if the list has 5 items, it will take like a relatively short time. But if the list has 500 or 5,000 or 5 million items, it will take considerably longer. This is the essence of a linear time complexity. So that was a lot of gibberish which I just said. So now let me just break this down for you in the diagram. Here you can see I have array of groceries. So I have eggs, bread, strawberry, milk, bananas. So if I want to search for, like, let's suppose milk, in this case I have only 5 items right here, so it will not take that much long. So if I want to search for a specific item inside this list, so we already know that we have to iterate over through our entire list. So first of all, we are going to be iterating over through this item, and we will say like, are you the milk? No, I am not. Then we are going to be jumping into this one. Are you the milk? No, I'm not. Then we are going to be jumping into this one, and are you the milk? No, I'm not. Then we will finally jump to this one, and we will ask this question like, are you the milk? And it will say, yeah, I am the milk. Okay, so now we successfully found our milk, and in this case we have very short list right here, and now we are iterating over through this list. Still, it is taking a little bit of time, but it is taking some sort of a time. So what is the big O of our code? The big O of our code is O of n. And why is that? Because as the size of my input grows, the time it take will also grow. So like, let's suppose if I add 1 million items, and if I want to search for a milk, so it will take a lot of time. But if I only have like 2 items like eggs and milk, it will not take that much time. So this is what we call the O of n. So now let me just write some code, and then you will get to know what I'm talking about. Time to write some code. So I'm going to first of all create my groceries list. Underneath that, we have to write our algorithm. Okay, so search for item, and it's going to take only 1 item, and based on that input we are going to be iterating over through all of that array, and we are going to be searching for that specific item. So now let me just iterate over through, like, let I equals to 0 and I is less than groceries dot length, and then finally I plus plus. And now inside there we are going to be searching for that specific item, but first of all we have to write groceries and I, and which simply means that we have to iterate over through all of these lists, and we have to ask this question. And what's the question? The question is triple equals to item. Okay, so like, let's suppose if we pass, I don't know, maybe eggs. So we are now taking these eggs and we are now passing there right here, and we are now asking every single item that, are you the egg? Are you the egg? Are you the egg? And it's gonna say, yeah, I am the egg. So finally we will just pass it right here, and then it's gonna come to here, and then finally we have to just log it out. And I'm gonna just say like found, and here let me just pass that specific item which we were searching for. So now let me just save my file, and finally we have to execute our function. And now let me just pass the eggs right here. So if I save this file and run my code, so what are we getting? We are now getting like found egg right here. So I'm gonna right click on this area, and then I'm gonna choose set that to the right, and now I think that's looking better. So this is what we call the O of n, because we are now iterating over through this entire list, and that totally depends on the list items. So like, let's suppose if we have 1000 items, so the time it will take for our algorithm will also be increased. Okay, but if let's suppose if we have only 1 item or maybe 2 items, so it will not take that much time. So this process is known as the O of n. So that was the O of n, but now let's talk about how we are going to be dropping the constants. So how we are going to be doing that? Let's suppose we have 2 for loops inside our function. So I'm going to just write like for let j equals to 0, and then I'm going to just say like j is less than groceries dot length, and then finally j plus plus. And now inside this j we're going to be searching for like that same thing, like j, and it's going to be equals to the item. And if that's true, so we have to just log to the console like found that item, and we have to just write 2 in this case. So now in this case we have 2 for loops. So we have this O of n, and we also have this O of n right here, and both of them are dependent on these groceries list right here. So what do we have right now? So we have this n, and we also have this n right here. Okay, so what I'm going to do is that I'm going to just write like n plus n, which means like this for loop plus this for loop. So what it will give us, to combine both of them, is going to give us something called the 2n, or you can say the O of 2n. But whenever we have a situation like this, we don't count this 2. We always drop the constants, like we remove that from here. You will never say like O of 2n. A big no. You have to keep that in mind. So what we have to do in that case, we have to drop the constant, so it becomes the O of just n, not the O of 2n, just like that. Okay, so whenever you have situation like this, you're going to be still saying that this function is the O of n, not the O of 2n. So this is what we call dropping the constants, and this is what we call the O of n. Now that we learn about the O of n, and now let's talk about the O of 1, also known as the constant time, and everyone's favorite one. Okay, so O of 1 signifies that the execution time of the algorithm remains constant regardless of the input size. So if I ask you a question like, what is a const result keyword in JavaScript? So your answer will probably be like, when we declare a variable by using a const result keyword, we cannot change the value of that. So that is known as a constant, and that is exactly the same constant right here. So the O of 1, also known as the constant time, signifies that the execution time of the algorithm remain constant, which means like not going to be changing regardless of the input size. So let me just break this down for you. Imagine you have a box filled with item and you know exactly where each item is located. To get a specific item, you go directly to its location, taking the same amount of time irrespective of how many items are in the box. Back to our array example. So we have that same array right here. We have that grocery items inside there. But now let's suppose in this case I know exactly where my item is. Let's suppose I'm searching for the eggs. No matter if the input grows or shrinks, I don't give a F. Okay, so I know the item. So I'm going to be just running some sort of algorithm which will find out that specific item. Let's suppose I know the strawberry, so I know the location of my strawberry. So I'm going to just take my marker or my pointer and I'm going to point it right here. So this is known as the constant time. No matter if my input grows or shrinks, we don't care about that. We only care about that specific item which we are searching for. So it will give us a constant time. So the time it takes to find that specific item for our algorithm will remain constant. I want you to just keep that in mind. Or you can also say the O of 1. Both of them are totally exactly the same thing. So now let me just write some code and then you will get to know what I'm talking about. So what I'm going to do is that I'm going to just create a numbers array and it's going to hold like 1 2 3 4, come on, 3 4 and 5. Let's just save them, and now we have to create our function, or in this case you can say our algorithm, because this is a step-by-step solution for our problem. Okay, so we are now passing the array and also the index. So array will be this entire array and the index will be that specific location where our item is located, like let's suppose 3 4 or 5. Okay, so I'm going to just write like array, and now we are going to be passing that index. And now if I log that to the console, so get element, and now let me just paste the numbers array, and I want to get the first element. So now let me just save my file. Let's just go back, and now if I run my code, so what are we getting? We are now getting the 1 right here. And why is that? That's because we are now passing the index of 0. It's going to give us 1 right here. So this process is known as the O of 1, which means like we don't care if our input size increases or decreases. We are only interested in that first item or that specific index item, like let's suppose maybe 3 or 4 or something like that. We are only interested in that specific item, and we create our algorithm the way like if you want to get a specific item, it's going to give us that specific item based on the index. So this is known as the O of 1. Okay, so now let's talk about the expensive one, which is called O n to the power 2, or you can say O n times 2. You can call it whatever you want to call it. So this indicates that the algorithm execution time grows quadratically. I can't pronounce this word, but quadratically with the size of the input data represented by n. Okay, so I know that's a lot of gibberish words, but now let me just give you some sort of analogy. Imagine you have a box of items and you want to compare each item with every other item to find a specific pairs. So as the number of the item increases, the number of the comparisons n times 2 grows much faster. So that's why we call this one as the expensive one. So you know what, let me just write some code and then you'll get to know what I'm talking about. Alrighty, so what I'm going to do is that I'm going to just create some sort of a function, and I'm going to give it the name of like find pairs, and it's going to take the array. Okay, so now inside this function, let me just zoom in a bit. Inside this function, first of all, we are going to be iterating over through like let I equals to 0, and then I is less than array.length, Come on. LENGTH, and then finally I plus plus. And now inside there we're going to be using like for let j equals to I plus 1, and then j is less than array dot length, and then finally j plus plus. So what in the world are we doing? We have a function, and now inside this function we have two for loops, or you can say quadratic time. Okay, so it's gonna take like a double time. So that's why we call this notation as the on times 2. Okay, so it's gonna give us a quadratic time. So now if I log that to the console like a pairs, so pair or pair, come on, pair like that, PAIR, there we go. So I'm gonna just say like array I, and then I'm gonna provide a comma, and then array, and then finally let me just put a j in there. So let's just go back, and I'm gonna save this file. Let's just create some sort of a data so that we can iterate over through their data. So I'll just write in numbers, and now inside there I'm gonna just provide like 1 2 3 4 and 5 once again, and finally let me just provide like find pairs, and we are going to be passing their numbers. Okay, so now if I save my file and run there, so what are we getting? We are now getting our pair 1 5 times, and this is coming from the outer loop. Okay, and this one is coming from that inner loop right here. Okay, so we are now printing there like 5 times, and then we have there 2, and we are still printing there like 3 times, and then we have there 3, we are now printing there like 2 times, and then finally we have a 4, and we are now printing there 1 time. Okay, so it's going to give us a pair, but what we are doing is that we are now creating a nested loop. We have a loop inside another loop, so this process is known as the O n, and then this caret symbol 2, or you can say O of n to the power of 2. Okay, so that was the O n times 2, but there is a bit of catch. Let's suppose if I just remove that from here, if I hide this area underneath this for loop, if I create another for loop like let maybe q equals to 0, and then q is less than 5, and then q plus plus, and now inside there I'm gonna just write like console.log, and first of all let me just provide some sort of a separator, and now inside there let me just print out the loop. So what do we have? First of all we have O n times 2, which we already know because this one has a nested loop right here. Next we only have O of n right here. Oh, it's not O of n. Let me just write like q is less than array dot length. Let's suppose if I save this file, now this is the O of n. So if I go ahead, go back and run this code, so what are we getting? We are now getting that from 0 through 4 right here, and this is coming from this O of n, and this area and these pairs are coming from these nested loops right here. So what do we have right now? We have this situation. So now let me just go back, and now let me just paste my comments right here, and we have this situation. So if we combine all the O operation, it becomes O n to the power of 2 plus n, which you can see right here. So first of all we have a O n to the power of 2, and if we combine this n, so it's gonna just gives us this O n to the power of 2 plus n. But O n to the power of 2 is something called the dominant term, and then n, which you can see right here, is a non-dominant term. So we remove the non-dominant terms, and we are only left with O n to the power of 2. So we always remove the non-dominant term, because in this case this one has a high precedence and this one doesn't. Okay, so like this one is taking much more time and this one isn't, so we have to remove, I mean like just for explanation purposes we are going to be just removing this n. We are not going to be removing this entire code like that, we are not going to be doing that, but just for the explanation purposes we can say like this is technically correct, but we don't write the dominant term, so we have to remove this dominant term. So we are only left with the O n to the power of 2, which you can see right in here. So this way we can simplify our big O. If you don't get what I'm saying right here, you don't have to worry about that. You only have to keep in mind that whenever we have a nested for loops or any kind of a nested loop, so we say that this is known as the O n to the power of 2, and whenever we have some sort of a loop which will be iterating over through some sort of a data, okay, so that process is known as the O of n. So yeah, that was the O n to the power of 2. Welcome to the O log n, and trust me, this is one of my personal favorite. But now let's talk about it. So what is a O log? And by the way, we are not going to be writing any code for that because it involves something called a sorting and searching and all of that, and we are not there yet, so we're not going to be discussing that. Okay, so in the upcoming videos we will master the O log n. I'm going to be explaining that again and again, but for now let me just give you a quick idea about that. So what is the O log of n? And by the way, this is going to be the final one. Okay, so the O log of n time complexity refer to the algorithm runtime that grows logarithmically. I can't even pronounce this, but I'm really sorry about that. With the size of the input represented by n. In simple term, as the input size increases, the time it takes for algorithm to run increases slowly. Not faster, but slowly. I know that's a lot of gibberish, but now let me just show you that in the diagrams. Imagine that we have this sorted list right here, and I want to search for this first item inside this list. So how can I go about doing that? Well, we are going to be using something called the divide and conquer, which we are going to be mastering a bit later in this course, but not right now. Okay, so we are going to be doing a divide and conquer. So how we are going to be breaking this down to get this first element inside this list. So to search for this specific item, the first thing that we are going to be doing is that we are going to be dividing and then conquering. So we have to divide this array by 2. Okay, so now once we do that, we are going to be performing a if statement right here. Is that item which we are searching for is located in this half or in this half? So it is now located in this half, so we have to say bye-bye to these items right here. Then once again, we are going to be doing that divide and conquer once again. So we are going to be taking these two elements and we are going to be dividing them. We are going to be searching whether the element which you are searching for is in this list or in this list. So it is now available in this list, so say bye-bye to this one right here. Then we have only 2 items, so we are going to be dividing there finally once again. And then finally, this is not the element which we are looking for, so say bye-bye to this one, and we only have this element right here. Okay, so let me just go back and let me show you that entire flow. So what we did is that first of all we have these items. So the first step that we did is that we break this entire list into 2. So that was the first thing. Now next we break this down once again, and then finally we break it down yet another time. So we only did 3 operations right here. So how that's gonna look like in the O log of n, this is how it's gonna look like right here. So now let me just place that. This is how it's gonna look like. So we have a log of 2, and then we have a add, and it is now equals to the question mark. Is what is all of their gibberish even means? I want you to just forget about the log. Just consider that like log is nothing. Just like forget about that. Okay, and then what do we have? We have a 2. So we will say this like 2 to the what power equals to add. 2 to the what power equals to add. Okay, so just imagine for a second like 2 to the what power gives us add, and that's the solution. Let me just place it right here. 2 to the 3 power gives us add. Add was the elements that we had in our list, and now we are just searching for 2 to the what power, 3 operations, so it gives us add right here, and that 3 operations which you can see right in here. So we have operation 1, then we have operation 2, and then we have operation 3. So this process is known as the O log n. Okay, so I hope it makes sense, but if it didn't, don't you worry about that, because in the upcoming videos where we are going to be learning about the binary search and trees and all of that, we are going to be discussing this O log of n in a more great details. Alrighty, so that was it about the O of n's and the O of 1's, and that was the entire story. And I'm gonna see you in the next course, and for now, love you all, stay healthy, stay happy, and bye bye. Welcome to the data structure and algorithm masterclass. So in this video I'm going to be making you arrays monsters. So what are we going to be learning in this single video? So first of all, we will start our conversation by a quick introduction of what an array is. Then we are going to be creating our own custom array with a lot of challenges. After that, we are going to be performing these challenges like reward string, palindrome, integer reversal, sentence capitalization, FizzBuzz, max, profit, array chunks, and the final one, two sums. So now let's get into it. If you are watching this course, I already assume that you guys already know what an array is, but still, I'm going to just give you a quick introduction of what an array is, and then we're going to be jumping into how we are going to be creating our own custom array and how we are going to be performing a lot of algorithms on there. So let's talk about what an array is. So data structure array is an ordered collection of elements that can be accessed using a numerical index. And you guys already know all of these stuff. So now let me just write some code and then you will get to know what I'm talking about. So what I'm going to do is that I'm going to just give you a quick introduction of what an array is. So we're going to be just writing like a string array, and we are going to be storing like string A, B's, come on, C, D, E, and so on. Then we can also create an array for the numbers. So I'm going to just write like num array. It's going to be equals to like 1, 2, 3, 4, 5 or something like that. We can also create an array for the boolean. So we can store like true or false value inside there. And we can also create a mixed array. So I'm going to just write like mixed, and I'm going to just store like string undefined, null, and also object, like some sort of an object. And we can also store a nested array inside there. So I can log like all of them like mixed, save my file and run there. So here you can see we're now getting this mixed array right here, which is totally fine. And so that was just a quick preview of what an array is. But now the question is how we are going to be creating our own custom array. Like how we are going to be creating some sort of a place where we can store any kind of data, and we can push our data, we can remove our data, and we can do all of that algorithm by creating our own array. Like how in the world we are going to be doing that. So now let me just show you how we are going to be doing that. Time to create our own custom array. So how we are going to be doing that? To do that, we are going to be using, you guessed it, classes. Okay, so first of all we have to write a class result keyword, and then you are more than welcome to give it like any name that you like. But in my case, I'm not going to give it the name of like array because it will override my existing array. So what I'm going to do is that I'm going to just name it my array, and you are more than welcome to give it like any name that you like. And now inside there we have to define our constructor. Inside this constructor we have to define the initial values for our array. So I'm going to write like this dot length, and it's going to be initially set to 0 because in this case we don't have any items inside our array, so that's why it's going to be set to 0. Now the next thing that we have to do is that we are going to be creating some place where we are going to be storing our data. Okay, just like if you create some sort of an array, inside this array we are going to be either storing string or number or boolean or something like that. So now we are storing this data inside this object right here. So we are going to be doing that. Okay, so now let me just cut that from here, and now this is how we are going to be creating our own version of an array. So what I'm going to do is I'm going to just create a new instance of that by writing like my array, and now here I'm not going to pass anything inside there. Okay, so now let me just write like const my new array. It's going to be equals to that array. So now let me just log that to the console like my new array. Let me just go back, save my file and run there. So what are we getting? We are now getting that my array, the length is now initially set to 0 and the data is totally empty. Okay, so this is how we are going to be defining our own array. And now it's time to define our own algorithms inside this array. Time to define our algorithm on our custom array, and that algorithm will be the dot push method. Okay, so this push method will allows us to add a new item at the end of our array. Okay, so like let's suppose if I want to add like, I don't know, maybe apple, or maybe, I don't know, just some sort of a number, or maybe a boolean or something like that. So this push method will allows us to add a new item at the end of our array. Okay, so I want you to just go ahead and pause the video and do that by yourself. So what you have to do is that you have to just define a push method inside this array, and I want you to make it so that anything I pass inside this push method will go right here inside this data right here. Okay, so I want you to pause the video and do that by yourself. As you were asking me in the previous video, in the comment section, you were asking me that, HuXn, you are not giving us a challenges. I want you to give me some sort of a challenge. Just wait and see how much challenges I'm about to give you. Okay, so that's going to be your first challenge that I want you to do by yourself. So pause the video, give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. And here is my solution. So what we have to do is that we have to write our push method, and it's going to take some sort of an item because we're going to be pushing that item, which we're going to be passing right here. Like let's suppose if I want to pass apple, so we're going to be taking that item and we're going to be pushing that to our data right here. So how we're going to be doing that? To do that, we are going to be accessing first of all our data, which we already defined right here, and now inside there we are going to be providing like this dot length. Okay, and now it's going to be equals to the item itself. So you can also log that to the console if you wanted to. So now let me just log that to the console. So what I'm going to do is that I'm going to just write like console.log of this.data, and I'm going to also provide a separator right here so you guys can see everything a bit better. And now if I save my file, and now let me just run there. So what are we getting? We are now getting the index of 0, which is now initially set to 0 right here as a string, and we are now passing the value of this apple right here. So this is coming from this line right here. Okay, so that's I mean, like, yeah, from this line. Okay, so now let me just provide something like this dot length in this case, and let me just go back, and this is how we are going to be writing our code. And now let me just save that and rerun that. So what are we getting? We are now getting that specific apple right here, that specific thing which we are now providing right here as for this push method. Okay, so now let me just clear this out, and now let me just close that from here. And now the next thing that we have to do is that we have to increment this length by 1, because now we are adding some sort of item. So now we want to change this length from 0 to 1. So how we are going to be doing that? Well, we have to first of all access there, and then we have to just write a plus plus, and this is how we are going to be doing that. And finally we have to just return there so that we can see something. So we have to just write like this dot length, and that's it. Let me just go back, and that was the entire algorithm for our push method. You know what, let me just remove these console logs from here. I'm gonna also remove it from here as well, and let me just add a few more items like orange, and I'm gonna also add the mango. And finally let me log my array, my new array, to the console. So now if I save my file and run there, so what are we getting? We are now getting the length of 3 right here, because anytime I add a new item, we are going to be incrementing this length. And also we are now getting this data. So for the index of 0 we are now adding apple, for the index of 1 we are adding orange, and so on and so forth. Okay, so that was our push method. Time to perform another challenge. So let me just give you another challenge. So what I want you to do is that I want you to add another method, so which will be my new array, and then the dot get method, not length, get method. And now for this get method is going to take some sort of an index. So like, let's suppose if I specify the index of 0, so it's going to give us apple. But if I specify like 1, so it's going to give us orange, and if I specify 2, it's going to give us mango. So I want you to give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. So I'm going to specify 0 right here for the index. Pause the video and do that by yourself. And here is my solution. So what I'm going to do is that I'm going to just create my get method, and let me just pass some sort of an index inside there. And now we are going to be just returning the this.data, and now here we have to just specify that specific index right here. So we are now accessing this.data and here we are going to be accessing some items. Like, let's suppose if I specify that 0 right here, so that 0 will come from here, and we will put that 0 right here inside this index area. Then that 0 index will come from there, and we will put that right here instead of that index. We're going to be getting our items like this. Okay, so that was the entire challenge. Let me just go back. Okay, so let me just save my file and run there. So what are we getting? I'll log that to the console, and let me just show you there. Now we are logging that to the console, and now let me just run there. So what are we getting? We are now getting that apple right here. But if I specify 1 and rerun there, we are now getting the orange. If I specify 2 and rerun this, we are now getting that mango right here. And that was the challenge number 2, or you can say the algorithm number 2. Time for another exciting challenge, which will be the pop algorithm. So if I just write like my new array, and if I write like pop, and now if I execute that, so what this method will do, that it will pop out, or you can say it will remove the last element from our array. Okay, so if I have like, I don't know, maybe a lot of items, and if you want to remove the last element or the last item inside our array, so for that we are going to be using this pop method, and inside there we are not going to be passing any item and also any index, because we already know the index. Like, we are going to be removing the last element from our array. So like, let's suppose if I have this array, let me just show you that. If I have 1 2 3 4 5, if I want to remove this 5th element, so for that we are going to be using this dot pop method. Okay, so I want you to go ahead and pause the video and do that by yourself, but if you can do it, that's completely okay. And here is my solution. But before I show you the solution, please pause the video and do the pop by yourself. So what I'm going to do is that first of all, I'm going to have to access the last element from our array. Okay, I can't even say that word, from our array. from our array. God damn it, English is a hard language. So I'm going to write like last item, and it's going to be equals to the this dot data, which we've already specified right here. So we are going to be accessing the this dot data. This is going to be our entire database, and now from this database we wanted to get that this dot length and then -1. So it's going to give us the last element from our array. Yeah, this time I said that from our array. So if I log that to the console like last item, and now if I save my file, and now let me just run there. So we are now getting that mango right here. You know what, let me just provide a separator if I am not wrong. Okay, so now if I save there, and what are we getting? We are now getting that mango right here, which is totally correct. Okay, so now we are successfully getting the last element from our array so then we have to delete that item. So we are going to be writing like delete, and this dot data, we are still going to be accessing our entire database, or you can say our entire store, whatever you want to call that. Then we're going to be getting that same like last element from our array, and now we successfully remove that element. The next thing that we have to do is that we have to decrement this length by 1. Okay, so we're going to be just writing like this dot length minus minus, because in this case we are now removing one item, so we have to write the so we have to write this dot length minus minus, or we have to write the decrement. So now I'm gonna just write like last item, and now let me just save my file. And finally, if I run my code, so we are still getting undefined. That's because we are using that get method. But if I remove that from here, and here you can see we have 3 items right here. So we have apple, we have orange, and we have mango. But now we will get to see these 2, not the last one, because we are now popping out this last item. So if I run my code, so what are we getting? We are now getting the length of 2. Even though we have 3 items, we are still getting the length of 2 because we remove, or we pop out that last item right here. So we have the data of apple, and we have the one item which will be set to orange, but we don't have this mango right here. So this is how we are going to be removing the last item from our array. There we go. God damn it. Time to solve another challenge, and in this case we're going to be creating something called the shift method, and trust me, this one is going to be a challenging one. So what this shift method will do, first of all, let me just give you a demonstration. So I'm going to write like item is going to be equals to like 1 2 3 4 5, and now we are going to be using like item dot shift method. And as soon as we use the shift method, a few things will happen. The first of all is going to remove the first element from this array. The next thing is going to be happening is that we are going to be re-indexing our entire array. So like, you know what, let me just go back, and I'm going to just write a few spaces right here. And now at this point, the index of 1 is 0, and then we have for the 2 of 1, then we have 3, then we have 4 and 5, just like that. But let's suppose if we remove this first element from this array, so we also have to re-index every single thing. Okay, so what we have to do is that we have to remove this one, and the rest of them is now totally cool. Okay, so we have to remove that last element. So this is what I want you to do. So I want you to give it your best shot, and if you can do it, that's completely okay. Come back and watch the solution, and please don't say in the comment section that I'm not providing a lot of challenges, because in this video you and I are going to be solving a lot of challenges. Okay, so I want you to pause the video, give it your best shot. If you can't do it, it is my solution. So I'll just write like shift. The first thing that we have to do is that we have to access the first element. So I'll just write like first element, and it's going to be equals to, or you know, instead of a first element, I'm going to rename that to this dot data. We are now accessing our database right here, which means like we are now accessing this entire store in which we are going to be storing our data, in which we already store our data. Okay, so now in this case we're going to be accessing only the first element, because we want to get the first element from this array. Okay, so that's going to be the first thing. Now the next thing that we have to do is that we have to do the re-indexing. Okay, like if this was our array, so we have like 0 1 2 3 4 5. If we have this kind of array right here, so the index of this one will be equals to 0, this one will be set to 1, and this one will be set to 2. And if I remove this element, the index of the 2 will be now set to 0, and the index of the 3 will be now set to 1. Okay, so now if you want to do that, so for that we are going to be iterating over through this entire array. So we will just say like for let I is equal to 0, and then I is less than this dot length, and then we will just say like I plus plus. Now we are iterating over through this entire list, and now inside there we are going to be accessing like this dot data, and we want to access each element inside that data. We are now iterating over through that entire database, and then we have to set that to this dot data, and then we have to get our I, and we have to increment there by 1. Okay, so we are now going to be re-indexing there. Now the next thing that we have to do is that we have to delete the last element. Now you might be asking, HuXn, like, why do I have to delete the last element? Well, you have to because if you want to re-index everything, so you have to. So if you have this array like 1 2 3 4, and we want to remove this first element, so now we have to do the re-indexing. So first of all, we have to just set that to 0, then this is going to be for the 1, and this is going to be set to 2 right here. Okay, and we remove 1 which was set to 3, so we also have to remove that third one. Okay, so now let me just remove that from here, and we have to just write the delete result keyword, and we are going to be using this dot data and then this dot length -1. So it's going to give us like the last element which we just saw a few seconds ago. So then this dot length will be decremented by 1. We also saw that a few seconds ago, and then we have to return the first item so that we can see which item was deleted. So what I'm going to do is that I'm going to just write like shift method right here. Or before I write this shift method, I'm going to duplicate this line of code, and I'm going to just say shift right here for this second one. So if I save my file, and yeah, I'm gonna also duplicate then put that right here once again. So basically I have 2 copies, so it's gonna show us the original array, the previous version of an array, then we are now removing one item from that array, and finally it's gonna give us the new updated version of our array. So I'm gonna have to just run there. Now let me just save my file and rerun there. So what are we getting? We are now getting craziness. Okay, so first of all, we have this older version right here. The length was 3, and we have apple, orange and mango. Now the length is 2, and we only have orange and mango, and we now successfully removed this apple from this array. Okay, so this is how we are going to be working with the shift method. Okay, so time for another challenge. So what I want you to do is that I want you to create a DeleteByIndex method. So how that's gonna look like, if I have items, and I'm gonna write like 1 2 3 4 5, and now if I use like items, so you can give it the name of like delete, or you can say DeleteByIndex if you wanted to. And here we're going to be specifying some sort of an index. Like if I specify 0, so it's going to remove this first element. But if I specify like, I don't know, maybe 1, so it's going to remove the 1. If I specify 2, it's going to remove the 2. And once again, you have to re-index everything. So like you have to iterate over through there by using some sort of a loop, and you have to do all of them which I just mentioned a few seconds ago. So I want you to give it your best shot. If you can do it, that's completely okay. And here is my solution. So pause the video, pause it, pause the video and give it your best shot. So what I'm going to do is that I'm going to just create a delete method. You can give it the name of like DeleteByIndex if you wanted to. So I'll give it the name of like delete, and now let me paste the index inside there because we are going to be removing our item based on their index. So now let me just get there. So what I'm going to do is that I'm going to write like this dot data, and we're going to be passing that index, and here is our entire database, and we're now taking that index. So like for instance, if I specify like delete, and if I specify 0, so we are now passing that 0 right here, and we are now storing there. I mean, like we are now accessing our item based on their index. Okay, so now let me just store that in the items or item variable right here inside there. Now the next thing that we have to do is that we have to do the re-indexing. So I'll just write like index, and then I is less than this dot length, and then finally I, come on, we have to get the last element in this case, and then we are going to be using like I++ inside there. Okay, so I'm going to just write like this dot data, and we are going to be iterating over through our entire array, and we are going to be getting each item, and we have to just set there to this dot data, and we have to just provide 1 to there, which means like if you have 0, so that 0 now becomes 1, and if you have like 1, so that 1 now becomes 2, and so on and so forth. Okay, so now if I save this file, and now underneath there we have to use the delete, and now we are going to be using like this dot data, and we have to specify that this dot length -1, which means like we are now getting the last element from our array, and then we have to decrement the length. Okay, so I'll just write like this dot length and just decrement there, and finally we have to get what we just removed. Okay, so we have to get this specific item. So now let me just go back, and now I specified the index of 0, so which means like we are now removing this apple. And now if I run my code, so what are we getting? We are now getting our apple right here. And now if I log that to the console like my new array, and now if I save my file and rerun there, so which means like that apple is now successfully, and we are now left with this orange and also the mango. And not only that, the indexing are also totally changed. So now orange is now set to 0 and mango is set to 1. Okay, so yeah, this was a lot of code, and this is how we are going to be creating our own custom array, and this is how we are going to be defining our own custom algorithms on that array. So yeah, that was amazing. Time to perform a lot of challenges. So the first challenge that we have is a string reversal, or a reverse string, whatever you want to call that. And if you are watching this course, the data structure and algorithm course, and especially on YouTube, so which means like you've already solved this question like maybe 100 or maybe 200 times, I know that. So anyways, but if you didn't, that's completely okay. So if you guys already solved this challenge and you get every single point of this challenge, so you can skip this challenge and you can jump to the next challenge. But if you feel like, yeah, I'm gonna just give it a try, so stick around and I'm gonna show you a few instructions. But if you feel like you are not able to do this challenge, so I have a hints for you. Just wait for a few seconds. First of all, you have to create a function which will take a string. So like if you specify hello, it will reverse it out to this ole. Okay, so I want you to just do that. Then if you specify like apple, so it's gonna just reverse it to this alpha or ilpa, whatever you want to call that. So once again, if you can do it, so go ahead and do that. But if you feel like, no, HuXn, like I don't feel that much comfortable, so here are the hints. So let me just place that right here. These are the hints. So the first thing which I want you to do, and by the way, there are a million ways, like a trillion, quadrillion ways of doing this same challenge. I mean, like not that much, but still there are a lot of ways to perform this challenge. But the most simplest one in JavaScript especially is this one. The first thing that you have to do is that you have to figure out the way to convert your string to some sort of array. So just do that, figure out the way, like I don't care which kind of programming language that you want to use, so convert your string to array. That's going to be the first thing that you have to do. And in JavaScript we have a method for that, like how we are going to be converting the string to array. So I want you to pause the video and figure this out by yourself. And the next thing that you have to do is that you have to just reverse out that array. Like now that you successfully convert your string to array, then the next thing that you have to do is that you have to reverse out that array. And once you reverse this out, the final thing that you have to do is that you have to convert array back to the string. And that was a lot of hints that I can give you. So give it your best shot. If you can do it, that's completely okay. And here is my solution, baby. And the solution will look something like this. First of all, let me just place this instruction right here. So if you want to convert a string to array, so in JavaScript we already have a built-in method which is called the split method. And if you wanted to reverse out the array, so for that we have another method which is called the reverse method. And if you want to like combine it back, so for that we have the join method. Okay, so yeah. And by the way, there are a lot of ways to do this same challenge, like in different ways. So what I'm going to do is that I'm going to just create a function. I'm going to give it the name of like reverse string, and it's going to be taking one string perimeter. And now let me just first of all use the string.split method, and if I didn't specify anything at all, and now let me just write like console.log and reverse string, and I'm going to be passing like hello right here. And if I specify that, so it's going to convert that to array. So if I run my code, so what are we getting? Let me just rerun that. I'm going to rerun my code. So what are we getting? We are now getting that we are now getting our string as our array right here. So which means like we can now perform all of our array operation right here on our string. So now that we successfully convert our string to this array, now the next thing that we have to do is that we have to reverse this array. So we have to use the reverse method right here. So we are going to be using this reverse method, and we don't have to specify nothing for that. So now if I save my file and rerun that, so what are we getting? So here you can see that it used to be hello. Now we successfully convert that to ole right here. So now we are 90% there, but now the funny thing that we have to do is that we have to join it back. So here you can see if I run my code, this is now set to array, but we don't want that. We want to get that as a string. So how can we go about doing that? Well, to do that we have to use the join method, and it's going to convert it back to the string. So if I save my file and rerun that, what are we getting? We are now getting this ole right here. Let me just go back, and we are now getting this ole. I'm saying it as ole, but I don't know if that's a correct pronunciation of it. I'm going to write an apple in this case, so it's going to convert it to il or something like that. Okay, so if I save my file and run there, and we are now getting this ilpa right here. Let me put my own name. You know what, I'm gonna put my own name. So I'll just write like HuXn web dev. Save my file, and we are now getting, yeah, I can't even pronounce this word, but yeah, you get the idea. So that was our first challenge of this course. Time to do another challenge, which will be a palindrome. So what is a palindrome and how we are going to be even solving this challenge? So what is a palindrome? That's going to be the first question. So if the reverse string is equal to the original one, then that word is known as something called the palindrome. So how that's going to look like? This is how it's going to look like. So if I have like CDDC, and if I reverse this out, so it's gonna still gives us that CDDC, which is totally a palindrome, or you can say a valid palindrome. But if I specify like ABBA, still if I reverse this out, it's gonna still gives us that ABBA, which is a palindrome. But if I specify hello, it's gonna gives us a ole, which means like that's not a valid palindrome. So I want you to give it your best shot. If you can do it like a million times, you don't have to sweat about that, because throughout this course you are going to be solving like a lot of challenges. If you feel like you totally can do this challenge by yourself without any hints, then pause the video and do that by yourself. But if you feel like no, I can't do that, so here are instructions for you, or you can say the hints for you. Okay, so the first thing that I want you to do is that I want you to just convert your string to array, then I want you to reverse it out, then I want you to convert your array back to that string. So we already done all of that stuff in the previous challenge. Now the next thing that we have to do, or the new thing that we have to do, is that we have to compare our string with that reverse string which we just saw. So give it your best shot. If you can do it, then watch the solution, and baby, here is my solution. So I'm going to just create my palindrome, and it's going to be equals to that string, and now I'm going to be passing like string.split method, and it's going to convert that to my array. Then we have to reverse this array, and then finally we have to rejoin it back. And now the new thing is that we have to check this reverse string with the original string right here. So we are going to be passing that string right here. And now if I log this out, so you know what, I'm going to just remove that right here. So I'll just write like string palindrome, and I'm going to specify like CDDC, save my file and run that. We're still getting that CDDC, like the reverse string of that. If I specify like HuXn, save my file and run that, we're now getting this Nikzu or something like that, which is not a palindrome, by the way. So I'm going to just write like triple equals to this, not true, but the string. And now if I just specify HuXn, save my file and run that, it's going to give us a false, because that's not a valid palindrome. And now if I duplicate this line of code, and if I change that to like CDDC, save my file and run that, it's going to give us like true for that, because this is true. If I reverse this out, so it's going to still gives us that CDDC. Or if I duplicate that and change that to like ABBA, save my file and run that, and it's going to give us true once again. So that was the palindrome. Third one, which is the integer reversal. So now that we know how we are going to be reversing the string, now it's time to learn about how we are going to be reversing the integer. So let's suppose if I specify like 1 2 3 to my function, so it's going to reverse it out to 4 3 2 1. And if I specify like 5 6 7 8, it's gonna give us like 8 7 6 5. Basically it's gonna just reverse it out. So if you feel like you totally can do this challenge by yourself, go ahead, do that. If you can do it, then here are my hints, and keep in mind, if you can do it, like please pause the video and do that by yourself. But if you can, bang. Alrighty, so what do we have to do? The first thing that we have to do is that we have to convert one number to a string. We already know that. We totally can do that in JavaScript, and spoiler alert, we have a method for that in JavaScript. And if we didn't have that method, we can still do that in JavaScript. Now the next thing that we have to do is that we have to convert a string to array. Next we have to reverse the string, then we have to convert array back to that string, then we have to convert a string to the number, and finally we have to return the number. And you can totally use a Google for this one if you wanted to. And basically these are just a method of JavaScript. And by the way, you can totally do this challenge without even using a method if you wanted to. So you know what, give it your best shot. If you can do it, here's my solution, baby. And the solution is this. Okay, so convert number to a string. So for that we are going to be using the toString method of JavaScript. And if you want to convert a string to array, so for that we already know the split method. If you want to reverse it out, so we have a reverse method. If you want to join it back, so we have a join method. And now if you want to convert a string to a number, so for that we have a parseInt method. And finally we are going to be just returning that number. So now let me just remove that right here, and now let's just create our reverse integer, and it's going to be taking the number. And now let me just create this function. So let's just use our reversed. It's going to be equals to that n, that toString method. So it's going to convert one number to a string. Then we have to split it out. Okay, so we have to make it as an array. Then we have to reverse that array. So if I just use like reverse, and now we're not going to be passing anything to that, and finally we have to join it back. So I'll just use that join method right here. And now the next thing that we have to do is that we have to return our parse integer. So it's going to give us a string, so we have to convert that to integer right here. So we are going to be passing our what do we call it, we are going to be passing our string. It's going to convert it to the integer. So then we have to use our math.sign. And now let me just specify this n right here. Okay, so if I save my file, and now if I specify like, I don't know, maybe a reverse string, and now if I write like, I don't know, maybe -123, save my file and run there, it's gonna give us that 321. We can also specify a positive value like video. We can pass the positive value, not a video. So let me just rerun there. It's gonna also like still gives us that 321. If I use 321, so if I save there, it's gonna give us 123. We can also use like 456, save our file, so it's gonna give us 654. And this is how we are going to be reversing the integer in JavaScript. Time for another challenge, which is the sentence capitalization. Okay, so basically I want you to just create a function which will take some sort of a string. So let's suppose if we specify the lowercase string, so it will just capitalize the first letter, like H will be capitalized, and then this W will be capitalized. Okay, just like that. So here you can see if we specify like hello world in the lowercase, so it's gonna just capitalize it like this. It's gonna take the first element and it will uppercase the first element. And here is another example. If I specify my own name, it's gonna give us like this. So give it your best shot. If you can do it, that's completely okay. And here are a few hints if you care about that. So here are a hints. If you don't care about that, then go ahead and solve this challenge by yourself. So here are the hints. So make the string lowercase. That's going to be the first thing. Then convert that string to array. We already learned about that. Then capitalize each word. So we are going to be iterating over through that array, and we will take the first element from that array, and we will only capitalize or uppercase that first element. And then finally we have to convert array back to the string. So basically if I just, I'm not going to give you any more hints than that. So give it your best shot. If you can do it, then watch a solution. And here is my solution. So I'm going to just remove that from here, and here is the solution. So how we are going to be making our string as a lowercase. So for that we have a toLowercase method in JavaScript. And how we are going to be converting a string to array. For that we have a split method. How we are going to be capitalizing each word. So for that we are going to be using the map method to iterate over every single item from that array which we just made by using the split method. And finally we have to just convert back our array to that string by using the join method. So yeah, that was that. And I just realized it should be 4, not 3. Okay, so let me just write the code. I'm gonna write like const capitalize, and it's gonna be equals to the string. It's gonna take that string, and now inside this function we are going to be returning that string, and we are going to be using that toLowercase method first of all, and then we are going to be making that lowercase string as a split array. Okay, after that, let me also provide a space right here. After that, we're going to be iterating over through each item inside that array. So for that, we are going to be using that map method, and we're going to be passing that word to it. And now we have to get the first element from that array, and we have to just make it like to upper, come on, UPPER case, and we have to execute that. Let me just go back, and finally we have to join the rest of the word. So we are going to be using like word.splice, not splice but a slice, and we have to join it back. Okay, so now that's done. We have to write the join method, so it's gonna join it back, and that's the entire solution. So what are we doing? First of all, we are now taking the string, we are now making that as a lowercase. You don't have to do that, but we will do that because yeah, in some situation, let's suppose if somebody specify like hello world in uppercase, so first of all we are going to be making that as a lowercase, like a hello world. So that's going to be the first thing. Now the next thing that we have to do is that we have to convert that to a to array. Okay, and then we have to iterate over through that entire array. We have to get the first element from the array, we have to uppercase that, and then join the rest of the array. Okay, just like that. And by the way, this join method will allows us to join back that array to that string. Okay, so now let me just go back and let's just provide a few test cases. So let me just use like console.log of capitalize or capitalize function. We are going to be passing hello world to that. If I do that, save my file and run that, and here you can see we are now getting like hello world right here. And if I specify a space right here, save my file and rerun that, and now we are getting that hello world with a space. And here you can see that the first letter is now capitalized and the rest of them isn't. Okay, so that's that. And let me just provide another test case for my own name, like HuXn web dev. I'm gonna also provide one for the Jordan Peterson, the person I don't like that much, but yeah, I don't know why I'm providing his name in every single course of mine. But yeah, I guess name sounds cool. So here you can see everything is now successfully capitalized. Time to solve another challenge, which is the FizzBuzz, the most popular challenge like ever, and maybe 80% of the interview I've seen this challenge that this challenge is asked. So basically what you have to do is that you have to create some sort of a function which will take like n number of which will take n numbers of numbers, and then what do we have to do? First of all, we have to print numbers from 1 to n. That's going to be the first thing. Now the next thing that we have to do, if the number is divisible by 3, which means like in this case we are going to be using the mod. Okay, so it's going to give us that divisibility. So if the number is divisible by 3, print fizz. Otherwise, gives us that number from 1 to the n. Okay, so we are going to be iterating over through that number starting from the 1 through unlimited amount of numbers which we are going to be providing. And if the number is divisible by 3, so only gives us fizz. And if the number is divisible by 5, gives us buzz. And if the number is divisible by 3 and 5, so then in that case we have to get the FizzBuzz. Otherwise we have to print the number. So give it your best shot, and there are no hints because these are the entire hints. So give it your best shot. If you can do it, that's completely okay. Then watch a solution, and here is my solution. Buzz, and it's going to be taking the number. Now inside this loop we have to first of all iterate over through that unlimited number which we are going to be taking as a perimeter. So we are going to be writing like let I equals to 1, because we are going to be starting our loop from 1, as I just mentioned right here, like starting from 1 to the n numbers. Okay, so let I equals to 1, and then I is less than or equal to n, and then I plus plus. That's the first thing that we have to do. Now the next thing that we have to do is that we have to check if the number, I mean like that I, which is like a number, we are now going to be iterating over through the entire list. If the number marked 3 is equals to 0, and index like that same number marked 5 is equals to 0, so what do we have to do in that case? In that case we have to just write like FizzBuzz. The first step is now successfully completed. And now the next thing that we have to do, let me just write an else statement right here. Else if, we have to provide another statement right here inside there, or not a statement but a condition, which is if I, or you can say the number, is divisible by 3 is equals to 0. So what do we have to do in that case? We have to just write the fizz. Okay, so like fizz. And then if that's not the case, so we just have to run, or you know what, we have to provide another one. Okay, so we have to provide like if I mod 5 is triple equals to 0. So in that case we have to write like buzz in this case, because that was if the number mod 3 is equals to 0 and the number mod 5 is equal to 5. So we are going to be printing like FizzBuzz, like both of the word at once. If the number mod 3 is equals to 0, so we are going to be only printing the fizz. If number mod 5 is equals to 5, I mean like 0, so for that we are going to be only printing the buzz. Otherwise we have to just print console.log and that same number right here. So if I save my file, and if I run this code like FizzBuzz, and now I'm gonna have to specify like 15, save my file, and now if I run there, here you can see it's gonna first of all gives us like 1, then 2, then 3, well it gives us fizz right here, then it's gonna give us 4, and then we have buzz, fizz, and so on and so forth. So this is what we call the FizzBuzz challenge. Time for another challenge. I want you to keep in mind that this challenge is not the easiest challenge, and I'm not going to even assume that you can totally do this challenge by yourself, but at least I want you to give it your best shot. So what do we have to do? Imagine you are buying and selling a stock throughout the year. Your job is to find the biggest profit you could make by buying low and selling high only once. Keep that in mind, this condition, like only once. You can read this through by yourself. So what do we have to do? Here is what you are given: a list of stock prices for each day. Like in day 1 the stock price will be 7, in day 2 we will have 1, we will have 5, and so on and so forth. So here is what we need to do. The difference between the cheapest price you could have bought the stock and the most expensive price you could have sold it later on. And there are no there are no hints for this challenge, and I'm not even gonna assume that you totally can this challenge. So yeah, if you want to give it a try, you totally can. You don't have to give it a try because I'm about to show you the code. So what do we have to do? First of all, we have to write our max profit. Now inside this gonna take the prices as a parameter. So the first thing that we have to do is that we have to get the minimum price. So we will just write like min price, and we will set that to the prices, and we will get only the first day. Okay, so you know what, let me just even pass their prices right here. I'm gonna write like prices, and it's gonna be equals to that same prices. Okay, like we have first of all 7, then we have 1, 5, 3, 6, and 4, and now we have to pass there to our max profit function. We are now going to be passing there. Let me just store that in some sort of a variable like a profit, and then we have to log that to the console. So we will just say like maximum profit was this much. Okay, so we will just pass that function right here, or that function call to be precise. So now we are assuming that the first day is the cheapest day to buy, which is the 7. Now we are just totally assuming that. That's not going to be the case actually, but we are just assuming that. Next we have to get the max profit, which will be initially set to 0 because we didn't sell something. We bought something but we didn't sell it to someone, so that's why the initial value will be set to 0. And now underneath that we have to iterate over through these prices, and then we will find out like what is the current price, what is the min price, and what is the potential price, and all of that. Okay, so I'm going to just write like for let I equals to 1, and then I is less than prices dot length. Come on, length, and then I plus plus. And now inside there, first of all, we have to get the current price. So we will just say like a current price, and it's going to be equals to the prices and then that value, which means like we're going to be getting like all of them. So you know what, let me just show you the even. Okay, so I'll just write like a current price right here, save my file, and now let me just run there, and it's going to give us there 1, 5, 3, 6, 4. So these are the current prices which we are now getting right here inside this loop. So now let me just cut this out. The next thing that we have to do is that we have to update the minimum price if the lowest price is found. So you know, let me just write there right here. So update minimum 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 price if the lower price is found. Okay, so how we are going to be doing that? Well, first of all, we have to use the math.min, and it's going to give us the minimum value from our entire array, and the minimum value which we already have is this min price right here. So we have to copy that, we have to place that right here. Now let me just provide a comma, and then we have to pass our current price which we are now getting right here. So we already saw what this gives us, and now we have to assign that to the minimum price. So what I'm going to do is that I'm going to just write like a minimum price, and it's going to be equals to that minimum value right here. So now that's done. So if I log that to the console like min price, let me just save my file, go back and run that. So we are now getting like only the 1, and here you can see in this entire array the minimum price is only 1 right here. 5 is not lower than 1, 3 is not lower than 1, 6 is not lower than 1, 4 is not lower than 1, 7 is not lower than 1, only 1 is the least, or you can say the minimum price. So that's done, and now let me just clear this out. Now the next thing that we have to do is that we have to get the potential price. And how we are going to be getting there? To get there, we are going to be using current price minus minimum price right here. And we are going to be also storing then some sort of a variable like potential profit. It's going to be equals to this function potential. Let me make sure the spelling is correct. We have potential price right here. And now if I log this to the console like potential price right here, or profit, why am I saying price? And now let me just run there. So it's going to give us the potential price of 0, 4, 2, 5 and 3. It's not going to give us 7. It's also not going to give us 6 right here, but the potential prices are 0, 4, 2, 5 and 3. So that's done. And now underneath there, what do we have to do? We have to get the maximum profit, and that's going to be it. Okay, so how we are going to be getting there? As we learned that math.min will give us the minimum price. Now we can use the math.max. So it's going to give us the maximum price right here. So first of all, we have to provide this max profit. I'm going to copy that, and now let me just place that right here. And we are going to be also passing the potential profit. And now let me just assign that to the max profit, and it's going to be equals to this method right here. Now let me just log that to the console. So we have a max profit. Save my file and run there. And the maximum profit we have 4 and also the 5 right here. And this is undefined because we have to return something from this function. That's why it is undefined. Okay, so now that's totally done. The final thing that we have to do is that we only have to get the maximum profit. So we have to return the max profit, save my file and run there. So we are now getting the maximum profit of 5 right here. That's going to be the maximum profit, and 1, which we just saw right here from the minimum price, is going to be the lowest. So we are going to be buying our stock by 1, and then we are going to be selling that on the 5th day. Oof, that was a lot of talking. So this is how we are going to be solving the max profit challenge. This one is going to be a bit more challenging, so let's get into it. So what do we have to do? The first thing that we have to do is that we have to create a function that takes an array and a chunk size as inputs. So it's going to take array and also the chunk size as inputs. Now next, the function should return a new array where the original array is split into chunks. Okay, chunks of a specified size. So basically what we have to do is that we are going to be passing some sort of array, and we are going to be also passing the size, like in how many pieces we want to split this array into. Okay, so we have this data right here, like add items inside this array, and we want to split this out into 3. So here you can see it's going to give us like 1, 2, 3 in the first array, 4, 5, 6 in another one, and then 7, 8 in another one. Okay, so that's done. Now we can also specify like 1, 2, 3, 4, 5 for the array, and we can split this out into 2. So it's going to give us like 1, 2 and 3, 4. So give it your best shot. If you can do it, then watch a solution. And here are a few hints, but trust me, it will not help you a lot. I totally can guarantee. So now let me just place that right here. If you want to read through there, you totally can. Otherwise, we are going to be writing a code for that, like exactly the same code. So if you don't want to read there, you can go ahead and just fast forward the video if you wanted to. Otherwise, I'm going to read there. Create an empty array to hold the chunks. Set the starting index to keep track of where we are in the original array. Loop through the original array as long as the index hasn't reached at the end. And then extract the chunk from the desired size from the original array. Then add the extracted chunk into their chunked array, which we've already defined at the beginning of this challenge. Then move the index forward by a chunk size, which we are going to be taking as a parameter to get the next chunk. And then finally, we have to return the final array of chunks. So I already told you that it will not help you that much, but yeah, these are a few hints. So give it your best shot. If you can do it, that's completely okay. And now let me just show you my solution. So what we have to do is that we have to create a chunk function. It's going to take the array and also the size. Okay, so now inside there, we have to first of all create a chunked array. Okay, some sort of a place or a database where we're going to be storing our chunked array. Okay, so yeah, that's that. Now the next thing that we have to do is that we have to also set the index, which will be initially set to 0. Okay, and now what do we have to do in that case? We're going to be iterating over through our array. So we're going to be just using like index is less than array.length while index is less than array.length. There we go. Come on, length. So what do we have to do in that case? Well, we have to split our array and we have to make it as a chunk. So we are going to be just writing like chunk, and it's going to be equals to array.slice method. And if you guys don't know what a slice method is, so I want you to just pause the video right now at this point, at this second, and go to either a YouTube or ChatGPT or Google or something like that and search about array and slice method. So we are going to be passing the index, and now let me just pass the index plus that size right here inside there. Okay, so if we log that to the console, this chunk, and I'm going to also return this chunk right here. So let's just return our chunk so chunk, there we go. So I'm going to be passing some sort of a data to there. So I'll just write like console.log of chunk, and now let me just write like 1 comma 2 comma 3 4 5 6 7 8. I'm gonna pass 8, and we want to split this out into 3. So now if I save my file and run there, and here you can, oh my god, it will give us a an infinite loop because we are already inside the while loop. God damn it, I'm gonna have to re-record this video. Shh. Oh, finally. I closed my VS Code and reopened that. Oh, god damn it. So we have to just use the word chunked, and chunked, which we currently have right here. This is going to be our database, and now inside there we have to just push our chunked array right here. Okay, so we are going to be just pushing the chunk into our chunked array, and then finally we have to use our index plus equals to the size right here. So now I can totally uncomment this line out, and now if I save my file, and you know what, I'm gonna also write a separator for myself. So if I save this file and run there and reopen, and now that's totally working. So this method will allow us to split our array into different chunks right here, which you can see right here. So here you can see I have items starting from 1 through 8, and now I'm splitting this array into these size, which you can see I already plus this size right here. So what we are doing, first of all, in the first iteration, we are now taking that array and we are now splitting that into 1 2 3 item. Then in the next iteration, we are now taking this array and we are splitting that into 4 5 6 item, and then finally we have 7 and 8 item right here. And then finally in this case, which you can see right here, like chunk.push, and then we are pushing this chunk is that database which I mentioned right here. We are now pushing that chunk which we are getting right here into that array, and so that's the final result that we are getting right now. Alrighty, so time for the final challenge, which is the 2sum. And before we start this challenge, I want to say that this challenge is not the easiest challenge in the world. Like, this is not the most difficult challenge, but it is some sort of a difficult challenge, you can say that. So we are going to be writing a code for this challenge, but we are not going to be refactoring that code because we didn't discuss something called the maps and hashes and stuff like that. So once we learn all of that stuff, then we are going to be refactoring our code. But for now, the code we are about to write will give us the bigO of O n to the power of 2, which means like we are going to be using a 2 for loops. So what are we even talking about? So imagine you have a list of numbers and a target number. Your job is to find 2 numbers in that list that adds up. Here the keyword is that adds up to the target number. You also need to tell which position or indices those 2 numbers are at in the list. Okay, so let me just give you example of that. So if our list looks something like this, like we have a 2 7 11 and 15 items inside there, and the target is 9. Like we want to find, let me just say that. And the target is 9, and the answer would be 0 and 1, because 2 at the index of 0, which you can see right here, I'm talking about this 2 right here, plus 7. Let me just add that right here. So 2 plus 7 at the index of 1 right here equals to 9. We are now providing this array, and what do you want to get back? You want to get the addition. Like once we add 2 numbers, or you can say the pair, it doesn't matter if you add the first one or the last one or the middle one, and if it gives us that 9, then that's the correct solution right here. So I want you to pause the video and read through all of these stuff by yourself. I feel like I didn't explain it that much well. So I want you to pause the video and you can read through there and then give it your best shot. And if you can do it, that's completely okay, because at this point of the course I don't expect you to solve this challenge by yourself. So now let me just write some code and then you'll get to know what I'm talking about. And by the way, before I start even the code, I want to say this note that this is not a better solution. We will make it better in the upcoming videos. Okay, so first of all, we are going to be creating some sort of a function. I'm going to give it the name of like toSum. It's going to take the parameter of nums. It's going to also take the target as well. And now inside there, the first thing that we have to do is that we have to loop through each number in the list. Come on, what is the spelling of a through? Okay, so first of all, we have to write or let I equals to 0, then I is less than nums dot length, and then finally we have to length, and then we have to just write I plus plus inside there. Let me just go back. Now inside there, for each number, check the rest of the list. Okay, so now we are going to be doing that. We are going to be just writing like let j equals to 1, I plus 1, and then j is less than nums dot length, and then finally we have to just increment over j as well. Okay, so now inside there we have to check if the current number and the one we are checking add up to the target. Then what do we have to do in the checking? Then what do we have to do in that case? We have to just return their indexes or their indexes. Okay, so now let me just save this file and go back. And now we are going to be checking that right here. So if nums.i, which means like we're going to be iterating over through for the first time, and then nums.j the second time is triple equals to the target. So in that case, we are going to be just returning like I comma j. That's not the case, so we are going to be just returning the empty array in that case. And now underneath there, let me just test this out, and I want to store that in some sort of a variable like const res, and I'm providing like 2 7 11 15, and I want to get the pair which will return the 9. Okay, so 7 plus 2 will give us 9. 7 8 9. Okay, so which means like we are going to be getting the result of what do we call it, 0 and also 1. Okay, so we should get that if I set up everything totally correctly. So we are going to be getting like res and save there, and yep, we are totally correct. So we are now getting the index of 0 and also 1, which is totally correct. Let me pass another array which looks something like this. So we have like 1 3 7 9 and 2, and we want to get the 11 right here. So it's gonna give us 9 plus 2 will give us 11. So 0 1 2 3 and 4, so it's going to give us 3 and 4. And now I'm going to have to store that in the res2. And now let me just duplicate this line of code and provide our res2, save our file and run there, and it's going to give us that 3 and 4 right here. And by the way, this is not the better solution, because we're going to be refactoring this code, and I'm going to even explain this code a bit more once we jump into something called the maps. We are not there yet, so we are not going to be discussing that right now. Anyways, that was it about for the arrays. Thank you so much from the bottom of my heart, and I'm going to see you in the next part of this course. And for now, take care, love you all. If you want to subscribe to this channel, feel free to do that, and I'm going to see you in the next video. Bye bye. Again, HuXn, and welcome to the data structures and algorithm masterclass. So in this video, I'm going to be teaching you every single thing that there is to learn about the linked list. So what are we going to be learning in this course? We are going to be first of all starting our conversation by talking about the singly linked list. Then we are going to be jumping into the doubly linked list, and finally we are going to be solving the interview question, the reverse linked list. So now let's get into it. Okay, so now let me give you the academic definition of what a linked list is and why you should even care about that. So a linked list is a linear data structure where elements are called nodes are not stored contiguously in the memory. Instead, each node contains data and a reference. Keep in mind these two words, like each node will contain data and also the reference, or you can also call it like a link to the next node in the sequence. Now I know a lot of you will say like, HuXn, these are a lot of like gibberish words and I don't get it. Well, I know that you don't get it. So now let me just break this down for you. So now let me show you how the linked list looks like in this. Is how it looks like right here. Now a lot of you will say like, HuXn, what in the world are these things? These things are called nodes, which I'm going to be explaining in a few seconds, but I want you to just give me a bit of time. And for now, you can just say like, this is a data which will be pointing to another data, and so on and so forth. But when we don't have any other data, so we are going to be pointing to the null right here. So basically a linked list is just a combination of these nodes right here, which will be pointing to another node and another node, and when we don't have any other nodes, we are going to be pointing to the null. Okay, so now let's talk about these nodes and what are these nodes even made of. So this is something called the node, and basically it is just an object which will have two properties, the data and the reference. Okay, and that data can be anything. So now in this case I only put one right here as a number, but you can put string, you can put undefined, you can put null, you can put like object, you can put arrays, you can put anything that you like, but in my case I only store one right here. Now the next thing that we have is something called the reference, which will be referencing to another node, and when we don't have any other nodes, so we are going to be referencing still to something called the null property. Okay, so let's suppose if we have this other node right here, so we are going to be taking there and we are going to be referencing that first node to that other node right here. Okay, and then if you don't have any other nodes, so we are going to be pointing to the null value right here. Okay, a node is basically going to be just an object which will have two properties like data and the reference, and that data can be anything and that reference can also be anything, but we are going to be referencing to another node. Okay, and when we don't have any other nodes, so we are going to be pointing to the null. So the combination of all of that nodes is something called the linked list. But now the final thing that I want you to keep in mind about the linked list is that the first element is called the head, and then the last element is something called the tail. Okay, so now this entire thing is something called the singly linked list, and we're going to be also learning about the doubly linked list as well. Okay, so time to create our own node, and once we are done with that node, then we're going to be jumping into creating our own linked list. Okay, so first of all, how we are going to be creating this node and what is inside this node. Now let me just show you there. So we already know that our node looks something like this. So basically this is going to be just an object. That object will have a data. You can also call it the value, and in my case throughout the course I'm going to be calling it as a value, but you are more than welcome to call it as a data. So we would have some sort of a data, and then that data will be pointing to like anything. You can provide a number, you can provide a string, you can provide anything that you like. Then we would have a next property which will be initially set to null, because currently we only have one linked list right here. I mean, like currently we only have one node, not a linked list. Okay, so let's just remove that. And to create a node, the first thing that we have to do is that we have to create a class. We have to give it some sort of a name. So in my case I'm going to just give it the name of like node, and now inside there we are going to be creating our constructor, and now this constructor will take some sort of a value, and based on that value, you know what, let me just show you there. This value will be that data right here. You can give it the name of like data if you wanted to. You can give it the name of like value. You can even provide it at the name of like banana if you wanted to, but some people call it the value, some people call it the name of data. So in my case I'm going to be calling it as a value, and now we are going to be creating this dot head, because we already learned that the first element of the linked list is called the head, and we are going to be pointing there to that specific value right here. After that we are going to be also writing this dot next, and we are going to be setting that to the null. So congratulations, that was our first node. Now that we successfully created our node, the next thing that we have to do is that we have to create our own linked list. And how we are going to be doing that? Well, you guessed it, we are going to be using a class once again. You can give it any name that you like, but in my case I'm going to give it the name of like linked list. And now inside there we are going to be passing our own constructor, and we are going to be also providing some sort of a value when we are creating this linked list. Now let's talk about how our linked list looks like right here. Okay, so this is how our linked list looks like. So we would have a nodes, then the first node is called the head, the last node is called the tail. Now initially we only have one node right here, so our head will be pointing to this node right here, and also our tail will be also pointing to this one node right here. So now let's just do that. First of all, we have to create our head. So we are going to be just writing like this dot head, and it's going to be equals to the new node, and we are going to be passing that value right here, which we are taking as a parameter from the constructor, and we have to pass that right here inside this node. And now that we successfully created our node right here. Okay, so that's going to be the first thing, which is now a head. Now the next thing that we have to do is that we also have to provide a tail. So we are going to be using like this dot tail, and it's going to be equals to the this dot head. So here you can see we are now pointing that head to that newly created node right here. We are also pointing this dot tail to this dot head right here, which in this case is still that specific node which we just created right here. Now optionally we are going to be also providing another property called the length, because when we want to keep track of that length, so we are going to be just providing like 1. Now in this case we only have one node right here, so we are now pointing the this dot length property to this one. And once we are creating that push and pop method, so we are going to be incrementing and decrementing this property. Now that we successfully created our node and we also created our linked list right here, so now let me just create instances of that. I'm gonna go back and I'm gonna give it the name of like const my linked list, and it's gonna be equals to the new linked list which we just created right here at the top, and we're going to be passing the value of 1. Okay, so if I log that to a console like my linked list, and now let me just save my file and run that. So what are we getting? We are now getting our linked list which have a head property and which is pointing to that node, and now inside that node we have a head property and the value will be set to 1 because we are passing that 1 right here, and the next property will be set to null because in this case we only have one node right here, so we are not going to be pointing to any other nodes. And then finally we have a tail, and we have the head property of 1 inside there and the next property of null, and the length is now currently set to 1. So this is how we are going to be creating our node, and this is how we are going to be creating our linked list. And now let's talk about the push method inside that linked list. Welcome to our first challenge. First of all, let me give you the directions, and then we are going to be writing our code. Okay, so we are going to be implementing something called the push method, and push will allows us to add a new node at the end of our linked list. Okay, so how that's gonna look like, I want you to keep these steps in mind. So the first thing that we have to do is that we have to create our new node. Like that's going to be the first thing that you have to do, because when we want to push a new node at the end of this list, first of all we have to even create that new node. Okay, so that's going to be the first thing. Now this node is no longer set to null because we have a new node right here, so we are going to be taking that and we will just put that on a side, and now we are going to be grabbing that newly created node and we will put that at the end of our linked list right here. That's the second step. Now the third step is that we have to take this tail, because this one is no longer the tail, now this one is the tail. Okay, so we are going to be taking the reference of this tail and we will point there to this node right here, and now this newly created element is not referencing to anything, so we will just take that now and we will point there right here. So this is how we are going to be pushing a new item to our linked list right here. So the first thing that we have to do is that we have to create a new node. The next thing that we have to do is that we have to take this pointer or marker or anything that you want to call there. We will take that from this node and we will point there to that newly created node, and finally we have to just set that to the null. And this is the entire flow. So I want you to give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. And now let me give you my solution. Okay, so you know what, first of all we are going to be just writing a push method and we are going to be providing a value to that, because based on this new value we are going to be creating our new node. So the first thing that we have to do is that we have to create a new node, which you can see right in here. Okay, so how in the world we are going to be creating a new node? Well, you guessed it, we are going to be using a new and then the node, and then finally we are going to be passing this value which we are taking as a push, and we have to pass that right here inside our node, and then we have to store that in some sort of a new variable like new node or something like that. The next step is that we have to take this tail which you can see right here, which will be initially pointing to this 4. We have to take this tail and we have to point there to our newly created node right here. So how we are going to be doing this one? Well, we have to just write that this dot tail dot next property which we currently have inside our node. So we have this node right here and we have this next property inside there, and it is now pointing to this null value. Okay, so we have to take this dot tail dot next and we have to point there to that newly created node. And now next we also have to write that this dot tail is going to be set to that new node. And finally, now we are adding new items, so we have to just increment our lengths. So this dot length plus plus, and now if we save our file, and now that's totally done. There is still one thing left which we are going to be discussing in a few seconds, but first of all let me just try out that push method. Okay, so I'm going to be using like my linked list right here, and now if I use the push method, and I'm going to be just passing like 10 right here in this case. And now if I save my file and run my code, so what are we getting? Let me just expand there. First of all, we are getting the head which is set to node. Now inside this node, the first head is pointing to this one value. Then we have a next value which will be pointing to that newly created node right here. And now that newly created node has the head, or you can say the value of 10 right here. And then finally we have a next property which will be now set to null, because we no longer have any other nodes, so it's going to be pointing to that null. So here you can see we have a tail, and the head property is now set to the 10 because this is going to be the last element. And then we no longer have any other elements, so it's going to be pointing to that null. And here you can see that length is now set to 2. Okay, so this is how we are going to be implementing the push method, but there is a bit of catch. And what is that catch I'm talking about? Let's suppose if we don't have any elements inside this linked list, head is pointing to nothing, and also tail is pointing to nothing. Like this is totally set to null, like we don't have any elements, so which you can see right here. So what are we going to be doing in that case when we are performing the push method? Well, you guessed it, we are going to be just removing this null. First of all, we have to create one new element, and we have to put there right here. We have to take the head value, and we have to point that to this node right here. Then we have to take that tail value, and we have to point that to this node right here. So now both the head and also the tail will be pointing to this newly created node right here when we are performing the push method. So now let me just do that right here. So once we successfully create our node, the next thing that we have to do is that we have to check if we don't have any heads, which means like our linked list is empty. So we are going to be taking the this dot head, and it's going to be equals to the new node, and we are going to be also taking the this dot tail, and it's going to be also set to the new node right here. And that's it, baby, that's it. Okay, that was it about the push method in the linked list. All right, so now let's talk about the pop method. And I gotta tell you, this is not going to be the easiest one. Okay, so what is the pop method? A pop method will allows us to remove the last item from our entire linked list. So how we are going to be doing that? Well, that's quite simple and easy. We have to just take the tail, and we have to point it right here, and then we have to say bye-bye to this one, and we have to take that null, and we have to put it right here. I wish it was that simple. It's not that simple. So what do we have to do? We cannot take this tail and we can just point it directly to this third element or the previous element. We have to iterate over through this entire list, and then we have to find out the last element, and then we have to find out the previous element, and then we are going to be taking their tail, and then we are going to be pointing this one, and finally we are going to be removing that. Okay, so that's the entire process. So now let me just break this down for you right now. So for now, I'm going to just take up both the head and the tail, and I'm going to just move there right here up above, and I want to show you something. First of all, we are going to be creating two variables. The first one will be a temp. You can like give it any name that you like, but in my case I'm going to give it the name of like temp, and we're going to be also creating another variable which will be a prev. Okay, like a previous. Okay, you can either call it the previous or the next or something, not a next but a previous or a temp. So I'm gonna just call it as a temp and the previous, and we have to point both of those variables to this head right here. Okay, so now we are going to be starting iterating over through this entire list. So you can either use the for loop or you can also use the while loop. So how that's going to look like? So we're going to be taking this temp variable, and we're going to be asking the question like, are you the last element? No, I'm not. Then we are going to be taking this temp variable, and we have to move there to this one, and we will say this one like, you are the previous element, so we want you to stay in here for a while. Then we're going to be asking this one, are you the last element? Then it's gonna say, no, I'm not. I have a reference to another element right here. So well, we will say, okay, no worries. So we're going to be pointing to this next node. Then this temp variable will also call this previous one, and we will move there right here. Like this one is not the last element. This one is also not the last element. Now we are going to be asking this one, are you the last element? It's going to say no, I'm not, because I'm now pointing to another node. Okay, so we will say okay, then we will take our temp and we will point this one right here to this fourth element. We will also take this previous one and we will point there to this third element. Now this temp variable will ask this one, are you the last element? And it's gonna say yeah, because I no longer have any other nodes, so I am the last element. So it's gonna say okay, cool, finally I found you. Okay, so finally I found you. So now this previous will take up this tail. So we will take this tail and we will point there to this third element, and then we can totally say bye-bye to this element right here. So I'm going to just remove that from here. I'm going to also remove this temp from here, and then we will take this null and we will point there right here. Okay, and this is the head value now, and now we successfully remove that last element. So this entire process is known as popping out the node from our linked list. So I want you to give it your best shot. If you can do it, that's completely okay. And now I'm going to just give you my solution. The first thing that I'm going to do is that I'm going to be using a pop method. It's not going to take any parameter because we are now removing the last element from our linked list. So first of all, we have to create both of that variable, like let temp is going to be equals to this dot head, and we're going to be also creating like let prev for the previous one, and it's going to be also pointing to this dot head. Okay, so now underneath that we are going to be using the while loop. You can totally use the for loop if you wanted to, but in my case I'm going to be using a while loop, and now inside there we are going to be providing that temp.next right here, because that temp.next is going to ask this one, are you the last element? No, then it's going to jump into this element right here. Okay, so that's why we are now providing this temp.next right here, and now inside there we can set the prev is equal to the temp variable, which is currently set to that temp, and that temp was a head. Okay, so now we move this one, but we are going to be still leaving this previous to this previous node to be precise. And now we are going to be taking this temp, and it's going to be equals to this prev.next. Okay, so now that's totally done. The next thing that we have to do is that once we successfully found out the last element, now in this case the last element is this one, so we are going to be taking this previous and we have to point it right here to this second one. We have to take up our tail, we have to point it right here, and we finally have to say bye-bye to all of them, and now this one will be set to null. Okay, so now let's just do that. So we're going to be using like this dot tail, and it's going to be equals to their prev, and we are going to be also taking this dot tail dot next, and it's going to be now set to null. So it's going to remove that connection, and it's going to remove that last element from that linked list, and then finally we have to decrement. So we're going to be using like this dot length minus minus right here. Okay, so now that's totally done. So I'm going to save my file, and underneath that we're going to be also returning our temp variable so that we can see like what was removed. And that's not it, like we have to still do a bit of modifications, but currently I'm going to just remove this 10 from my linked list. So I'm going to just run my code. You know what, let me just rerun that so you guys can see everything a bit better. The length is now set to 2, and here you can also see the tail is now pointing to this 10 right here. But now if I use like my linked list dot pop method, and now if I save my file and run that, here you can see the length is now set to 1, and my tail is still the linked list tail is pointing to this head of 1 right here, which means like it is only pointing to this one, and this 10th element is now successfully gone from that list. My tail, what the hell? And there are a few edge cases that I want to point out, which I did in a previous section. You know what, let me just point it out right here. If we don't have any head, which means like if we don't have any items, now in this case we are using a pop method. We are not creating any element, we are not pushing that to our linked list, we are now removing that. Okay, so if we don't have any element, so what we are going to be removing from our list if we don't have anything inside there? So we are going to be just returning undefined, or you can return null if you wanted to. And now let me just show you if we only have one item. So we are going to be using like this dot length triple equals to 0. So for that we are going to be using this dot head, and we are going to be pointing that to the null, and we are going to be also taking this dot tail, and we will still point that to that null right here. And that is known as the pop method. I know that was confusing because data structure and algorithms are not the easiest thing to learn, because it's going to allow you to go into big tech companies like Google, Amazon, Facebook. So you cannot go into that companies just by learning the basic syntax of a programming language and something like that. You have to learn all of that complexity in your code. Time for another challenge. So in this section, we're going to be creating our new method which is called the Unshift. So what this Unshift will do, that is going to allow us to add a new item or a new node at the beginning of our linked list. So how that's going to look like? First of all, we have to create a new node, and then we have to take up this head and we have to point there to that newly created node. As simple as that. But there is also one edge case. Imagine that you have a linked list which is totally empty. So what are we going to be doing in that case? Well, we have to remove this now, and we have to put that newly created element which we are going to be creating by using that Unshift method, and we have to take this head, we have to point it to, come on, we have to point it to that newly created element, and we also have to take that tail and we have to point it to that newly created element right here. Okay, so that's exactly what we are going to be doing. But first of all, this is a challenge, so I want you to give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution, but at least give it some sort of a try. So what I'm going to do is that I'm going to just first of all create the Unshift method, and now inside there we're going to be providing some sort of a value, and based on that value we're going to be creating our new node. So the first thing is that we have to create our new node. Come on, because new node is going to be equals to that new, and then we have to pass our value inside there. Now underneath that we are going to be checking if we don't have any items inside our linked list, like if we don't have any head, so which means like we don't have any items inside our linked list. Our linked list is totally empty, so we are going to be taking the this dot head and we will point that to this new node, and we will also take this dot tail, come on, tail, and we will point that to this new node, which you can see right in here. If we don't have any elements, so we're going to be taking that new node which we just created, and we're going to be taking the head, we will point that to that newly created element, and we will also take their tail and we will point that to that newly created element right here. And now underneath this if statement we have to take our new node.next property, and we are going to be setting that to the this dot head. And why is that? Because once we successfully created our new element right here, we have to point that to the beginning, not to the end, but to the beginning. And to do that, we're going to be taking this node and we're going to be providing the dot next property to the this dot head, and this dot head used to be this first element. So basically what we are doing is that now we successfully created our new element, we are now referencing to the head, to this first element. So now that's totally done. The next thing that we have to do is that we have to take this head and we have to point it to that newly created element. So let's just do that. We're going to be taking this dot head, which you can see right here, and we have to point that to this newly created element. So we are going to be just writing like new node, and now underneath there we are going to be using like this dot length plus plus, and finally we have to just return or this. Okay, so that's everything that you have to do for the Unshift. We are now removing one element, so I'm going to just remove that from here. We only have one and we only have 10 inside our linked list. So now if I save my file and run there, so currently we have only one and we also have 10 right here. For the head, we're now pointing to this one right here. I mean, like, we are now providing this one, but now I'm going to be using like my linked list dot unshift method, and I'm going to be providing 0 right here in this case. And now if I save my file and run there, and here you can see my head is no longer pointing to this one value which used to be this value right here. We are now pointing to this 0 element or this 0 value, because we are now creating a new element and we are now pointing our head to that new element right here, or that new node to be precise. So yeah, that was it about for the Unshift method. Alright, so time for another challenge. So I want you to perform the shift method. So basically the shift method allows us to remove the first element or the node from our linked list. So first of all, we have to take out this marker or head and we have to point it to the next element, and then we have to say bye-bye to this existing one, to this first one to be precise. And this is what we call the shift method. So give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution, but at least give it a try. So now here is my solution. So the first thing that I'm going to do is that I'm going to just write like a shift method, and it's not going to take any parameters because we are going to be removing the first element. Okay, so now we have to check if we don't have the this dot head, which means like if our linked list is empty, so we're going to be only returning undefined. And now underneath that, we have to first of all point, let me just write there right here. So point the first node slash element. So we're going to be using this dot head, and we have to store that in the temp variable right here. Okay, so now it's going to be equals to the head, which means like the first element in our linked list. That's going to be the first thing. Now the next thing that we have to do is that we have to move the head to next node slash element. You can either call it the element or the node. Okay, so that's the next thing that we have to do. Like we have to take out, let me just go back. We have to take out this head, and we have to point there or move there to the next element. So now let's just do that. Okay, so we're going to be using like this dot head. It's going to be equals to this dot head dot next. Okay, so it's going to give us the next element. Okay, and now finally we have to remove first element, which we currently have right now. So now we successfully move our head to the next element, and now we have to remove this first one. So how we are going to be doing that? Well, we just have to use the temp.next, and we have to set that to the null. Okay, and finally we have to just remove, not remove, but we have to decrement our length. And now underneath that, let's suppose if we have like 0 items, what are we going to be doing in that case? So we're going to be using like this dot length is strip equals to 0. So we're going to be using like this dot tail is equal to null. That's it. And finally we have to just return our temp so that we can see what happened. So these are all the steps that you have to take in order to remove the first element. Okay, so now let me just use it right here. So yeah, at the beginning we are now adding 0 right here. Let me just run that right here. You can see head is now holding the value of 0 right here for the first one, and now I'm going to just remove this 0, so it's going to give us 1 for this first one right here. So I'm going to be using like my linked list dot shift method, and I'm not going to be providing anything to that. So now let me just save my file and run there, and here you can see now we successfully removed that 0, and now it is set to this one right here. So yeah, that was it about for the shift method in our linked list. Welcome to the most easiest challenge in this entire course, which is called the get first element. Okay, so here is my linked list, and let's suppose if we call this method on this linked list, so it's gonna give us that 0 anytime we call that. That's as simple as I can go. So give it your best shot. If you can do it, well, here is my solution. So now let me just clear this out, and next we are going to be implementing the get first method. So let's just use get first, and now we are not going to be passing anything to that because we are going to be only getting the first element, and we just have to return that this dot head, and that's it, baby. That's it. Okay, so now let me just comment this line out and comment this line out. So we only have 1 and also 10 value right here, or I'm gonna also change that to 2. And now if I just use like get method right here, get first method right here, save my file and run there, so it's gonna give us only the first element right here inside our linked list. So that's gonna be the first element, and that's gonna be the last element. So that's why we are only getting the first element from our linked list, and that was the get first challenge. All right, time for another challenge, which is the get last element. Okay, so we are going to be just creating some sort of a temp variable like temp. Oh my god, I didn't mean to do that. Let me just create a temp variable, and we are going to be asking a question from each of the nodes, which means like we are going to be using some sort of a loop. Are you the last element? No, because I am pointing to another node. Then it's gonna jump to this one. Are you the last element? No, I'm pointing to another one. Then it's gonna jump to this one. Are you the last element? No, I'm pointing to the next one. Then it's gonna jump to this one, and it's gonna say no, I'm also not the last one because I'm pointing to this one. Then it's gonna jump to this one right here, and it's gonna say yeah, I am the last element because, or the last node, because I am not pointing to another node right here. So then it's gonna give us this value right here. So I want you to give it your best shot, and if you can do it, that's completely okay. Come back and watch the solution, and here is my solution. So we are going to be creating get last method. First of all, we are going to be checking if our linked list is empty. So for that we are going to be only returning null, and if that's not the case, we are going to be first of all creating that temp variable, and we will select this dot head. We will point there to the first element right here from our linked list. Like it's going to be pointing to this one because this is the head. So we are now going to be taking this temp variable, and we are going to be pointing to the first element, which we are doing right here. Okay, so that's done. Now the next thing that we have to do is that we have to use our while loop, and we have to pass our temp variable inside there. And now we are going to be checking. If not, temp.next. So in that case, we are going to be returning that temp. Otherwise, we have to change the temp to temp.next. Like we have to keep searching. This line means like we have to keep searching, and if we found the last element, so we are going to be only getting that specific last element. Okay, so that's it. And now let me just save my file. I'm going to rename that to the get last right here. So now if I save my file and run there, so it's going to give us that node which have that head which is pointing to this 2 value. So if I change that to like, I don't know, maybe 20 and save my file and run there, so it's going to give us 20 right here. So this is how we are going to be getting the last element from our linked list. Time for another challenge, which is the get, or you can say get element by index. You can give it any name that you like, but in my case I'm going to only call it get, and it's going to take only one parameter, which is going to be the index. So we are going to be passing some sort of an index, and based on that index we are going to be getting that element. Like for example, if I specify the index of 3, so it's going to search from 0, 1, 2, 3. So it's going to only give us that 3 right here. Okay, so you know what, first of all, let me just change that to the index. Come on, index. And what we are going to be doing is that we are going to be using some sort of a for loop, and we are going to be still asking that same question, like, are you that element which I'm searching for? Like for instance, if I specify 3, so let me just simplify that for you. Are you 3? No, I'm not. Are you 3? No, I'm not. Are you 3? No, I'm not. Are you 3? Yes, I am. So just return this node right here. So give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. And here is my solution. Okay, so I'm going to just use like get, and I'm going to be passing index right here because we are going to be searching our element based on that index. And first of all, we have to create some sort of a counter because we are going to be incrementing this counter by using our while loop. The next thing that we have to do is that we have to point to that head. So you can either give it the name of like temp, or you can give it the name of like node, and it's going to be pointing to that head because we're going to be starting our iteration from the first element. Okay, so you know, instead of that node, I'm going to just give it the name of like temp. I guess that makes sense. So now we are going to be using our while loop, and we have to pass that temp inside there. And now we are going to be checking if counter is triple equals to that index. So in that case, we are going to be returning that specific thing, or that specific node, okay, which is now currently pointing to this head. And otherwise, if that's not the case, so anytime we iterate over, so we are going to be incrementing our counter by 1. And now the next thing that we have to do is that we have to just change the temp value to the temp.next. Like we're going to be iterating over through again and again as long as we didn't found that specific index item. Okay, and if that's not the case, we have to just return no. And now let me just save my file, and this is the entire code which you can see right here. Okay, so that's done. Now let me just use that right here, and instead of providing a get last, you know what, I'm gonna also push. So this is going to be 0, and I'm gonna just change that to 1, 2, and I'm going to specify 3 right here in this case. And I'm going to be using the get method which I just created right here a few seconds ago, and I'm going to just pass the index of 3. So now if I save my file and run there, and here you can see I'm now getting the node with the head value of 3, and next will be now set to no because we no longer have any other elements. So that's why we are only getting this specific element right here. If I search for like, I don't know, maybe a second, and come on, what the hell did I just do? If I change that to 2, and now if I run there, so we are now getting this second element, or second node to be precise. So that was our get method in linked list. Time for another challenge, which is the set method. So you can think about the set method is just like update method. So it's going to take 2 parameters like the index and also the value, and once you specify a specific index, it's going to give you that specific node based on that index that you've provided, and then you can also change the value of that if you wanted to. So here, let's suppose if I want to change the value of this 2, so I'm going to have to specify the 3 as an index. So let me just write a 3 right here. So I'm going to have to specify 3 as an index. Once you found that element, we can totally change the value of that to anything that we want. Okay, so how that's going to look like, the first thing that we are going to be doing is that we are going to be passing some sort of an index, and we are going to be looping through this entire list, and we are going to be asking this question: are you that item that I'm looking for? No, I'm not. Let's suppose I'm searching for like I don't know, maybe 2. So I'm going to just write a 2 right here. So I'm going to just ask this question like, are you the 2? No, I'm not. Then we're going to be jumping into this one. Are you the 2? No, I'm not. then we are going to be jumping into this one. Are you the 2? Yes, I am. Okay, so we are going to be returning this item, but not only there, we can also change the value of that to anything. Like, let's suppose if I want to write like 10 or maybe 20 or something like that, so I can totally change the value of that. So give it your best shot. If you can do it, that's completely okay. Then come back, watch the solution, and here is my solution. So what I'm going to do is that I'm going to just write like a set method, and it's going to take two parameters like index and also the value. And now inside there, I'm going to do a bit of magic. Not a magic, but I'm going to be reusing the existing method. So instead of iterating over through this entire list, like first of all, we have to ask this one a question, then this one a question, then this one a question, and figuring out all of them by ourselves, we already built a method for that, and that method is this dot get method, and here it is taking some sort of a perimeter, and based on that perimeter it's going to give us that specific node. Okay, so what we have to do is that we have to pass that index inside this get method, and once we are done with that, we are going to be also just storing them in some sort of variable like temp, and by the way, you can like any name that you like. So I'm going to log this to the console so that you guys can see it a bit better. And now if I save my file, and now I'm going to have to use that right here, so I'm going to be using like my linked list, and I'm going to be using this set, not get, but this set method on there, and I'm going to just specify like, I don't know, maybe this second one right here. So I'm going to just paste this second one, save my file, and run there. So what are we getting? We are now getting that node, and the head value is now set to 2. And why is that? That's because we are now getting this item right here. Okay, so let's suppose if I specify this 3, save my file and run there. So we are now getting that 3 right here, and we are now getting this undefined. That's because of this console.log. So if I just remove that, and now let me just rerun there, and here you can see that console log is gone. So I'm going to right click on there, and I'm going to set that to the right, and I think that looks a bit more better. Okay, so now we are totally, not totally, but now we successfully get the item in which we are looking for. And now the next thing that we have to do is that we have to provide our condition if temp, which means like if we found that specific node which we were looking for. So what do we have to do next? We have to get the temp.value, and we have to change the value of that to that new value which we are going to be specifying right here. So now that we successfully get this third element or this third node, we can totally change the value of that to 10 or 20 or even a string value or anything that you like. So I'm going to just specify this 10 right here. And now the next thing that we have to do is that we have to return true. Okay, and now if that's not the case, so we have to just return false in this case. So now let me just go back, save my file, and run there, and we have to log this to the console. So console.log, and we have to run. And now I'm gonna save this file, and now let me just rerun there. So we are now getting true right here, and the value is now changed to something else. So now I'm gonna log to the console like my linked list, save my file, and rerun there. And here you can see, you know, let me just rerun there for the final time. And here you can see for the final element, which is a 3, we are now providing the value of 10 to there, and you can provide anything if you wanted to. Okay, so that was our set method in our linked list. Time for another challenge. So I want you to implement the insert method, and as the name suggests, that this insert method will allows us to add our node into anywhere inside our linked list. It doesn't matter if you want to add that at the beginning, so for that we are going to be using the Unshift method, and if you want to add that at the end, so for that we are going to be using a push method which we have already implemented. But now the question is, let's suppose if I want to add a new element right here inside at the middle, or maybe if I have like a lot of elements and I want to add my element right here, so how in the world we are going to be doing that? Okay, so let me just show you that. Okay, so now let me just show you this. So the first thing that I'm going to do is that I'm going to just make a bit of space, and now the next thing that we have to do is that we have to create our own element which we want to insert. So the first thing that you have to keep in mind is that you have to create that new element. So just keep that in mind. You have to create that new element, and then you have to figure out where you want to render this element or where you want to place this element. So now in this case, let's suppose if I want to place this 20 element or this node inside at the middle of this 2 and 3. The first thing that we have to do is that we have to access that before element where we wanted to insert our new element. So like, let's suppose if I want to insert my element right here, the first thing that we have to do is that we have to access this element, and I'm going to tell you why. Okay, so that's the first thing that you have to do. Let me just say that once again. I feel like I am confusing you. First, you have to create a new element. Second, you have to figure out where you want to render your element. Third, you have to access the before element where you want to insert your new element into. So like in this case, we're going to be taking care, or we are going to be accessing this element right here. Now next, you have to take this pointer, like the newly created node pointer, and you have to point there into this node right here, the next node, which is going to be after this node. Okay, so now that's totally done. Now the next thing that we have to do is that we have to take this pointer, as I said just a few seconds ago, that we are going to be accessing this element. So now we have to take out this pointer and we have to point it to this newly created element, which you can see right in here. Okay, so now let me just make that a bit bigger so you guys can see everything a bit better. Okay, so just like that. So I'm going to say that for the final time, because I know this method will confuse a lot of students. The first thing that you have to do is that you have to create your new node. The second thing that you have to do is that you have to keep in mind like where you are going to be placing that node. And third, you have to access the previous element, or not element, but the previous node or the before node, whatever you want to call that. And then third, you have to take the pointer of that newly created node and you have to point there into the next element or the node. And then finally, you have to take the pointer of the previous node and you have to point there to the newly created node, and that's it. So give it your best shot. If you can do it, that's completely okay. And come back and watch the solution, and now I'm going to give you my solution, but now let me just correct that right here. Okay, so this is how we are going to be adding a new element into our node. So let's go. The first thing that I want to do is that I want to just write like insert, and it's going to take two parameters like index and also the value. And now inside there, first of all, we have to perform a check. We have to check if the index is triple equals to 0, which means like we're going to be adding our element at the beginning of our list. Like we're going to be taking this element and we're going to be adding there right here at the beginning of this list. So we can totally do that manually, but we don't have to. What we can do is that we can just write like return and then this dot unshift, because we already made this element right here. So we are going to be just passing the value to them. After that, we can also check if the index is triple equals to this dot length. So we can then just push our element right in here. So we can just use the push method, which means like, let's suppose if you want to add this element at the end of our list. So for that, can write more custom code, but we already written our code, which is the push method. So we don't have to repeat ourselves again and again. We just have to do what we want to do. Okay, so now let me just save this file, and that was the first step. Now the next step is that we have to, you guessed it, we have to create the new node right here. So how we are going to be creating them? Well, we just have to write like const new node. It's going to be equals to that new node right here, and we have to pass a value inside there. Okay, so that's totally done. Now the next thing is that we have to get access to this before element. Now we are placing this element right here at the middle of this 2 and 3. So we have to get access to this second element or the before node or whatever you want to call that. So I'm going to just place this comment right here, like use the get method to find the node right before the desired position, like index -1. Okay, so we are going to be using like this dot get method, and we're going to be passing the index -1. Like we want to get the before element. Okay, so now let me just store that in the temp variable. You can give it like any name that you like. And now the next thing is we have to take the pointer of this new node. Let me just put that right here at the bottom. We have to take the pointer of this new node and we have to point there to the next element, just like that. So to do that, we're going to be using like new node dot next method, and it's going to be equals to the temp dot next method right here. And now underneath that, the final thing that we have to do is that we have to take care of this pointer right here. So we have to take that pointer and we have to just point there to this newly created node. Okay, so we're going to be just using like temp dot next, and it's going to be equals to that new node right here. And then we have to just increment our length, and finally we have to just return true right here. So now if I save my file, and this is how we are going to be adding or inserting a new item to our list. Okay, so I'm going to just remove that from here, and I'm going to just write like, I don't know, maybe if I want to add a new item right here at the second index, so I'm going to be using like insert method, and for the index, I'm going to specify 2, and for the value, I'm going to specify 20 right here in this case. So now if I save my file and run that, it's going to give us true. Obviously it's going to give us true because we are correct. And now let me just write like my linked list, save my file and run there. And here you can see for the second element, where is my second element? We cannot see that, god damn it. We are not at the dev tool. Get access to the 0 index, and now let me just run there. Now here you can see we are now adding there 20 right here. So this is how we are going to be using the insert method on our linked list. So this one is going to be a bit simple one. So here is the challenge. I want you to create a size method, and it's going to give us the count, like how many items are inside our current linked list. Okay, so in this case we only have 4 items, so it's going to give us the length or the size or the count of 4. So give it your best shot. If you can do it, that's completely correct, and I mean, like, that's completely okay. Then come back and watch the solution. And here is my solution. So I'm going to remove this insert from here, and I'm going to also hide this insert if I can get that. And now underneath this insert, we're going to be creating our size method. So now let's just write our size method, and now inside there, first of all, we have to create our counter, because we are going to be looping through each items, and then we are going to be counting, or we are going to be incrementing this counter, and then we have to create our temp variable. Come on, temp, and it's going to be equals to the this dot head. Like for the first element, we are going to be counting from this first element, so that's why created this temp variable, and it is now pointing to this first element. Okay, so that's already done. Now the next thing that we have to do is that we have to iterate over through all of that temp or all of that items. Okay, so we are going to be using counter plus plus anytime you want to iterate over through there. So counter dot plus plus, or not plus plus, counter plus plus, and then we have to take this temp, and it's going to be equals to that temp dot next value. Okay, so after that we have to just return that counter and save our file, and that's it. Okay, so let's just use that. I'm going to be using that size method right here, and now let me just execute that, save my file and run there. So it's going to give us 4 items, and why is that? Because we are now starting from 0 and we have 3 elements, so that's why we are now getting 4. So 1, 2, 3, 4. All right guys, for the final challenge that I want you to do is that I want you to make a clear method. It's going to allow us to remove every single element from our list and just make it as null. And give it your best shot, and you would be able to do that, because this is going to be the most simplest one. So give it your best shot. If you can do it, well, here is the solution, baby. So let's just create our clear method, and now inside there we're going to be using this dot head, and we just have to point there to the null value. Okay, so if I just use, like, instead of that size, I'm going to be using dot clear method right here, and now if I save my file and run there, it's going to give us undefined, because we no longer have any elements inside our linked list. So yeah, that was it about for the singly linked list. Let me just expand all of these coding right here, and that was a lot of challenges and a lot of code that we have to write. God damn it. I guess it's time to get into the doubly linked list. So now that we are totally done with the singly linked list, and now let's talk about the doubly linked list and how that's gonna look like. This is how it's gonna look like right here. So the main difference between the singly linked list and the doubly linked list is inside the nodes. So in the doubly linked list node, it will have an extra property which is called the previous property. So how that's gonna look like? This is how it's going to look like right here. Okay, so we will still have our value, or you can say the data, whatever you want to call that. We will still have that next property, or you can say the reference, or you can also say the pointer. But the only difference between the singly linked list and the doubly linked list is this previous properties. Now this is known as the singly linked list node, and this, let me just put that right here. This is known as the doubly linked list node. And that's the only difference between there. And how the code is going to look like, the code is going to be looking the same. Like, this is going to be still an object. It will have the value, it will still have the next property, but now in this case we are now using the doubly linked list, so it will also have the previous property as well. Okay, so that was just a quick intro to what a doubly linked list is. I can't even speak that word, doubly linked list is. And now let's get into the coding part. And first of all, we are going to be creating a node for our doubly linked list. So how that's going to look like, first of all, we are going to be creating our constructor. We're going to be passing some sort of a value inside there. we will still have our value which will be set to that value. We will still have our next property which will be set to null, because in this case we're not pointing to anything, so the initial value will be set to null. But now the main thing about the singly list and the doubly list is the previous property. Okay, so now we are going to be attaching this previous property. So this node is known as the doubly linked list node. Okay, so now let me just create a class for the doubly linked list as well. So doubly linked list, and now inside there we are going to be still passing our constructor and their value. All of that stuff will be totally the same. So now we are going to be creating our node. First of all, we are going to be just providing that value. That's totally the same, like const new node. We already know all of that stuff, and we are going to be also setting the head to that new node. We are going to be also setting the tail to that this dot head, that same new node, and also we are going to be using this dot length. Come on, length, and it's going to be equals to 1 right here. So everything is exactly the same, but the only difference in the node is this line of code right here. And the only difference in the constructor, I mean like in the doubly linked list, is this doubly right here. Now we just added this doubly, so this is now known as a doubly linked list class, and this is known as the doubly linked list node. I hope that makes sense. Alright guys, so time to create our own push method in the doubly linked list. So how that's gonna look like? Still, first of all, we are going to be creating our new doubly linked list node. That's going to be the first thing. The next thing that we are going to be doing is that we have to just move there a bit. The next thing that we are going to be doing is that we have to take that pointer and we have to point that to this linked list right here, that newly created linked list. I mean like this newly created node, not a linked list. The third thing that we have to do is that we have to take this pointer of this newly created node and we have to point that to this previous one right here. And finally we have to take our tail and we have to point that to this new node right here. And this is how we are going to be performing the what do we call it, the push method on our doubly linked list. So I want you to give it your best shot. If you can do it, that's completely okay. Then come back, watch the solution, and here is my solution. So what I'm going to do is that I'm going to go to the bottom right here, our push method. So I'm going to just write like push. We're going to be specifying the value to there, and now inside there, first of all, we have to create our new node, and then we are going to be just using our new node and we have to pass our value inside there. So now that's totally done. Time to check if our linked list is empty. So we are going to be using if not this dot head, which means like if our linked list is empty, so we are going to be taking this dot head and we are going to be pointing that to that new node right here, and we are going to be also taking their tail and we are going to be pointing this one to this new node as well. Okay, so that's totally done. Now the next thing that we have to do is that we have to take care of our actual push method. So we are going to be taking this dot tail dot next and we are going to be pointing that to our new node. And then the next thing that we have to do is that we have to take our new node dot previous and we have to just point that to this tail. So now let me just show you that. Okay, so now we point this property to this new node. Now we are going to be taking this previous property and we have to set that to this previous element right here, and this should not be right here, it should be right here at this point. Okay, so now the next thing that we have to do is that we have to take care of this tail. So we have to take this tail and we have to point that to this new element just like that. And now how that's going to look like, this is how it's going to look like. So we're going to be using this dot tail and we have to point that to this new node which we just created right here. So we have to save our file, and now underneath that we're going to be just incrementing our length. Okay, and then finally we have to just return this, and that's it. So we have to save that, but I don't know what's wrong. Let me just go back. What's wrong? Oh, I'm going to cut that from here and we have to put that right underneath that. So now that's totally done, and now let's just create a new doubly linked, come on, doubly linked list, and we are going to be passing 0 right here for the first value, and I'm going to store that in the my doubly linked list, and it's going to be equals to that my doubly linked list. And then we are going to be using my doubly linked list and we have to just push this one right here inside there. So now if I log that to the console like my doubly linked list, now if I save my file and run there, and here you can see we are now getting there right here. So if I right click on there, and let me just go ahead and go to the right, and this is how it looks like right here. So we have a head in reference to the node and we have a value of 0 initially, and then we have the value of 1 right here because we are now pushing that value of 1 to our doubly linked list. So now let me just clear this out, And this is how we are going to be creating our push method on our doubly linked list. Time for another challenge. So I want you to implement the pop method on the doubly linked list. So how you're going to be doing that? There are a few steps that you have to take. The first thing that you have to do is that you have to create a temp variable, and you have to point this temp variable to the last element in your linked list. That's going to be the first thing. The next thing that you have to do is that you have to take this tail and you have to move there to the before element or to the previous element. Next, you have to break the chain of this fourth element and this fifth element. So I'm going to make this a bit smaller, so now that chain is totally gone. And finally, we also have to break the chain of this last one right here. Okay, so now we are going to be successfully removing that from our list, just like that. And then we have to make this fourth element as the last element by providing this null value right here. Let me just explain that once again very quickly. Okay, so I'm going to explain that once again very quickly. So the first thing that you have to do is that you have to create a variable. You can give it like any name that you like, and you're going to be pointing there to the last element in your linked list. Next, you have to take that tail and you have to point there to the before element. Then you have to break the chain of this fourth element with this 5 elements, so you have to break the chain of there. Then finally, you're going to be also breaking the chain of this previous property with this fifth element, which is now currently pointing to this fourth element. So you're going to be also setting that to the null, and then you're going to be just removing that from here. You have to take this null and you have to point there to this fourth element. So now this fourth element is the last element in our linked list. So give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. And here is my solution. So what I'm going to do is that first of all, we are going to be creating our pop method. And now inside this pop method, the first thing that we have to do is that we have to check the length. Okay, so we are going to be checking the length by first of all writing that this dot length is triples equals to the 0 element. So we are going to be just returning undefined. Okay, so if that's the case, so we are going to be just returning the undefined. Next, we have to create that temp variable, which I just said, and we have to point that temp variable to this dot tail. Okay, and after that, we're going to be also checking one more thing. This dot length is triple equals to 1. So in that case, we're going to be pointing this dot head is equal to null, and we are going to be also pointing this dot tail to also null value as well. So if that's not the case, so we are going to be first of all taking that tail, which you can see right here. So first of all, we are going to be taking their tail and we have to point there to this before element. Okay, so we are going to be just writing like this dot tail, and it's going to be equals to this dot tail dot previous right here. Come on, tail dot previous right here. The next thing that we have to do is that we have to break out the chain, which is the this dot tail dot next, and it's going to be equals to null right here, which is that tail which we are now talking about. We have to just set that to null, and we will remove the chain of this element or this pointer with this new node. Okay, so not new node but this previous node. Okay, so we have to take care of that, and then finally we have to write our temp.previous, and we have to set that to null right here. And finally we also have to break out the chain of this one, so we have to make this shorter, which means like we now set that to null, and we have to remove that from the list, and we have to provide this null right here to this third element right here. So we can make that a bit bigger, just like that, and we have to set that to the null value, just like that. Okay, so yeah. And finally, I'm going to also provide the this dot length, and we have to decrement there, and we also have to return their temp variable as well. So I'm going to go back, and this is the entire code for the pop method. Okay, so I'm going to just pop out this last element, or I'm going to also provide a few more elements like 2 and also the 3. So now if I want to remove this third element, so for that I'm going to be using this dot pop method. Okay, so if I execute this semi-file and run there, and it's going to pop out this third element from the list, just like that. Okay, so yeah, that was the pop method in the doubly linked list. Time for another challenge. So I want you to perform the unshift method on the doubly linked list. So what is the unshift method? Unshift method allows us to add a new element or a new node at the beginning of your linked list. So here you can see this is what you have to do. The first thing that you have to do is that you have to create a new node, and then you have to take the pointer of this node and you have to point there to this next node, which is used to be the first element but not anymore. Now this one is the first element. Then you have to take the pointer of this one, which is a before, and then you have to point there to this newly created node right here. And then finally you have to take this head and you have to point there to this one right here, or that newly created node. So this is how you're going to be unshifting a new element or a new node into your linked list. Let me just say that once again very quickly. Okay, so first of all, you have to create a new node. Then you have to take the pointer of this node and you have to point there to the next node. Then you have to take the pointer of this used to be a head and you have to point there to this newly created node. Then you have to take this head and you have to point there to this newly created node. So this is what you have to do. So pause the video, give it your best shot. If you can do it, that's completely okay. Come back and watch the solution. And here is my solution. So what I'm going to do is that I'm going to just write like unshift method, and I'm going to be passing a value inside there. And the first thing that we have to do is that we have to create one new node. So we'll just write like new node, and it's going to be equals to the new node, and we're going to be passing a value inside there. And now underneath there, we are going to be checking if this dot length is length is triple equals to 0. So we are going to be using this dot head and we are going to be pointing there to our new node, and also this dot tail, and if that's the case, we are going to be also pointing there to the new node. And if that's not the case, so we are going to be using like a new node, and we have to use the next property and we have to just set there to this dot head. Okay, so what are we doing? We are now taking, first of all, let me just undo there. We now successfully created this node right here. So we have to take the property of there and we have to point there to which used to be the head. So we are now taking that new node and we are now providing this next property and we are now setting there to which used to be the head but not anymore. Okay, so we are now taking this property and we are now pointing there to this new node right here. Okay, so that's totally done. The next thing that we have to do is that we have to write this dot head dot previous, and it's going to be equals to the new node right here, which used to be the head but not anymore. We are going to be taking the property of there. Let me just get that right here. So we are going to be taking the property of there and we are going to be pointing there to this newly created node. So this is exactly that we are doing right now. And then finally we have to take the head and we have to point there to our new node. Okay, so now we are taking this entire head and we are now pointing there to this node right here. Okay, so this is what we call the unshift method in my in my doubly linked list. There we go. So now if I save my file, but we are not done yet, we also have to write a this dot length plus plus, and we also have to return the this result keyword. Okay, so now we successfully added like 0 1 2 3, and I'm going to also write like my doubly linked list, and I'm going to be unshifting, I don't know, maybe 100. And now if I just remove that from here, and now let me just save my file and run there, and what are we getting? We are now getting the first value, and which is now currently set to 100 right here. Okay, so this is how we are going to be adding a new value at the beginning of our linked list, or you can say this is how we are going to be adding unshift method into our doubly linked list. Time for another challenge. So I want you to implement the shift method, and the shift method will allow us to remove the first element from our linked list. So how you're going to be doing that? Well, to do that, the first thing that you have to keep in mind is that you're going to be taking this head and you're going to be pointing there to the next element. So that's the first step. Now the next step is that you have to take this previous property and you have to break this connection by setting that to the null. Okay, so now that's totally done. And now finally you're going to be also taking this connection and you also have to set that to null. So this connection will be totally break, and then you can remove this element from the linked list and you can set this null property right here. Okay, so give it your best shot. If you can do it, that's completely okay, and then come back and watch the solution. And here is my solution. So what I'm going to do is that I'm going to just write a shift method, and now inside this shift method we're going to be checking if this dot length is length, if this dot length is 0, so we're going to be just returning undefined. I already explained that like 1,000 times. And next we have to point our temp variable to this dot head. Okay, so now that's done. Next we also have to search for the length. If the length is triple equals to 1, like if you only have one node, so if you only have either one node or a 0 node, so for that we are going to be using this dot head, and it's going to be equals to null, and also this dot tail will be also set to null as well. And now underneath that we are going to be using this dot head, and we have to point there to this dot head dot next, which is that we are now taking this head property right here and we are now pointing that to the next element just like that. So now we are totally done with that. The next thing is that we have to take the this.head.previous property and we have to set that to null. So we are going to be taking this property and we are going to be setting that to null, so which means like we are now breaking this connection. So that's done. Now the next thing is we have to take the temp.next value and we have to also set that to the null. Okay, so we are now going to be taking this value and we are going to be setting that to null, so we can totally remove that from our list just like that. Okay, so once we do that, then the final thing that we have to do is that we have to just write like this dot length and decrement them because we remove something from our linked list, and then we have to write our temp so that we can see that we did something. Okay, so now that we successfully push these items right here and we also push 100, so I'm going to remove that from here, and now I'm going to be using like my linked list, and then I'm going to be using the shift method on there, so which means that it's going to remove this 0 from our linked list and we are going to be only getting 1, 2 and 3. So now if I save my file and run there, and here you can see we are now getting the value of 1 and we no longer have this 0 right here in our linked list. And you can also see the length is now currently set to 3. That's because we now successfully removed this one, so we only have these 3 items left. So this is how we are going to be implementing the shift method in the doubly linked list. Alright guys, so welcome to the famous interview question, which is given a linked list, you have to just reverse it out. That's the only thing that you have to do. This is my 4th time of re-recording only this section, this specific challenge. Why? Because I face a lot of issues in this challenge. When I was teaching that in my previous videos, I gave a lot of hints, but now finally I decided to not give you any more hints because I feel like it will confuse you a lot. So that's the only reason I'm not going to give you a lot of hints. So for this challenge, I'm going to give you only 2 hints and that's going to be it. Okay, so the first thing that you have to do is that you have to switch the head and the tail, as you can see right here. So the tail is now pointing to the head and head is now pointing to the tail right here. So that's the first thing that you have to do. And the next thing that you have to do is that you have to reverse those arrows, as you can see right here. So yeah, now I know a lot of you will say, Hussein, these are not that much clear instruction, but now you get the idea like what you have to do. And the reason I'm not giving you any more hints, you will just see there in a few seconds why I'm not giving you any hints. So yeah, give it your best shot. If you can do it, that's completely okay. Come back, watch the solution, but at least give it just 1 try or 2 tries. And here is my solution. So I only have this one singly linked list right here. So I have a head and also the tail pointing to their own places, like nothing is reversed for now. So now let's get into the coding. First of all, let me just show you what I have. I have my own singly linked list node, then we have our own singly linked list right here. Now inside there we have our head and also the tail and also the length, and we also have our push method, so it's going to allow us to push our item to our linked list. So we have 1, 2, 3, 4 items right here inside our linked list, and now we are going to be reversing out those items. So how we are going to be doing that? Well, we have to write our reverse method, and now inside this reverse method, first of all, we are going to be creating 3 pointers. So we are going to be writing like let temp is equals to this dot head. So what in the world is this line even mean? We are now creating our new pointer. We are now giving it the name of temp. You can give it any name that you like, and now we are pointing that to the first node in our linked list. That's the first thing that we are doing right now. Okay, so next we have our this dot head and we are now pointing there to this dot tail, which means like we are now taking the this dot head and we are now pointing there to this tail right here. I hope it makes sense. Okay, so we are now pointing there to this tail, just like that, this tail. All right, so now what else do we have to do? We have to now take this dot tail and we have to point there to the temp. So what is the temp? Temp is that head right here. So we have to take this tail and we have to point there to this head right here. So now we successfully flip out the head and also the tail right here, which you can see. So we have our tail which is now pointing to the head, and we have our head which is now pointing to this tail right here, and we still have our temp pointer as well. So the next thing that we have to do is that we have to create 2 other pointers. We have to create 2 new pointers. So we are going to be creating like next, it's going to be equals to this temp variable, and this temp is now initially pointing to this head right here. So what are we doing? We are now creating yet another pointer. We are now giving it the name of next. You can give it like any name that you like, and we are also pointing this next to this first element inside this node right here, just like that. My drawing. So this is what's happening right now. Next we have to create our final pointer, which will be set to prev, and it's going to be pointing to the null. We are going to be creating yet another pointer, and we will give it the name of like prev, and it's going to be pointing to the null value right here, just like that. Next we have to iterate over through each item. So for that we are going to be using like let I equals to 0, and then I is less than this dot length, and then finally I plus plus, and now inside there we're going to be using like next is equal to temp dot next. Okay, so what is the next? Next is their temporary pointer, which is now pointing to the head. So we are going to be setting that to the temp, like the head, dot next, to the next element. Okay, so what are we doing right now? This is now initially pointing to this first node right here. So we're now going to be taking there, and we have to point there to the next, like temp dot next. Let me just zoom in a bit. Temp dot next. Okay, so here you can see we have our next, which is now pointing to temp dot next. So we have our temp dot next. So this is how we are going to be pointing our next property to this next element inside our linked list. So now that's totally done. Next we have to write temp dot next, and we have to point there to this previous one right here. So we are now taking this temp dot next. We are now taking that pointer, and we are now reversing it back, like we are now setting that to the previous one, and the previous one is now set to null. So this is how we are now going to be flipping the arrow. So now that's totally done. The next thing that we have to do is that we have to take our previous, and we have to set that to our temp. So what is the previous? That previous is initially set to null. We have to remove that null from here, and we also have to point there right here. I know it sounds a bit confusing, but we have to point there right in here to this first element, or this first node right here. Okay, so that's totally done. The next thing that we have to do is that we have to take our temp, and we have to set that to this next right here. So what is a temp? Temp is this pointer which is now pointing to this first element. We have to take there just this first one, and we have to set there right here for this one. Okay, just like that. And that was our first iteration right here. Okay, so in the next iteration we're going to be still taking this next property. We're going to be pointing there to another one. Then we're going to be taking this arrow, and we have to flip there just like that, and we have to set that right here. And then we are going to be taking this temp. Then still we are going to be pointing there to this new element, which you can see right here. Then we are going to be taking this previous one, and we are going to be pointing there to next one. And this iteration will go on and on as long as it reverts out the entire linked list. So this step will be happening again and again. So it's going to be pointing there to the next element, just like that. Come on, to this next element, just like that. And then we are going to be flipping out all of them. So you know what? Instead of wasting your time by showing you those diagrams, now I already show you that in the first element totally clearly. So instead of wasting all of your time on these diagrams, I'm gonna just go ahead and just show you that right here in the code. So I'm going to use like dot reverse method right here. So we have, first of all, you know, let me just show you there. So we have 1, 2, 3, and 4 right here. So if I run there, we have a 1, then we have a 2, and the last element we have a 4, and that 3 is now hidden right here. So now if I use the dot reverse method on there, and now if I save my file and run there, we're now getting undefined. Okay, so we have to remove this console.log from here. God damn it, what the hell am I doing? We have to remove this console.log from here, the console my linked list. And now if I save my file and run there, so we are getting the head of 4, we're also getting the head of 3, and it is now successfully reversed out. So yeah, that was how we are going to be reversing out our linked list. Again, Hussein, and welcome to the Data Structures and Algorithm Masterclass. So in this course, we're going to be learning about the stack and the queues. So I'm going to be sharing every single thing that I know about the stack and the queues. So what are we going to be learning in this course? First of all, we are going to be introducing the stack. Then we are going to be performing some sort of a challenges on the stack. Then we are going to be jumping into the queue. We are going to be solving some challenges on the queue. Finally, we are going to be solving a few interview questions, and that's going to be it. But before you guys jump into this video, First of all, there is only one prerequisite that you have to watch this linked list video. Like, you first of all have to watch this linked list course, then you will be able to follow along with this specific video you guys are currently watching right now. Alrighty, so let's go into the stack. Now the question is, what is a stack? So here is the Wikipedia definition of a stack. So a stack is a linear data structure that follows the LIFO rule. So you can say the last in and the first out principles. So how that's gonna look like? This is how it looks like right here. So I want you to imagine that this is going to be some sort of a bookshelf, and we're going to be stacking our books inside this bookshelf. Now if I want to add my first book, so I'm gonna have to drag there, and we have to put there right here. So the last in and then the first out. So you know what? And then I'm gonna add my next book, which will be the book 2. I'm gonna add there right here, then my third book, then my fourth book right here. So this is how we are going to be adding a last in and the first out. So now if I wanted to get this last book, so we cannot do that. Why is that? That's because they are now stacked on each other. So here you can see, first of all, we are gonna have to grab this book. So we have to grab that and we have to put that right here. Then we have to grab this book. We have to put that on a side. And finally, we are going to be getting this one. So this is what we call the last in and first out, or you can say LIFO or LIFO, whatever you want to call that. So that was example number 1. The next example that I have is, let's suppose you are browsing on the web. So first of all, you go to the YouTube. So we're gonna have to put the YouTube right here. Then we're going to be going into the X, or you can say the Twitter. And then we're going to be going into the Meta, or you can say the Facebook. And finally, we're going to be going into the Instagram right here. So this is how we are going to be going into these social media networks. But now let's suppose if I want to go back. So the first thing that I have to do, if I hit the back or the return button, so it's gonna first of all bring me to this Facebook page right here. Then if I hit that back button one more time, so it's gonna just brings us to this X. And then if I hit that one more time, so it's gonna brings us to this YouTube right here, and that's going to be the final result. So we're going to be storing our data in this kind of a linear data structure, so which will be the last in and the first out. So how exactly our stack looks like, and this is how our stack looks like right here. We will still have our nodes, we will still have our reference, and we will still have our data inside those nodes. But now here we are not going to be pointing our head and tail. Instead, if we want to use the last one, we totally can, but in this case we are not going to be giving it the name of like head and tail. In this case, you can either give it the name of like top, and also for this one the bottom, or you can say the last and the first. Okay, so we're not going to be using the last one, so that's why I'm going to just remove that from here. And you have to keep in mind that their first will be now pointing to the last element. And the next thing that you have to keep in mind is that this node will be exactly the same node, just like the linked list node. So now let me just show you that. And here you can see we have our node right here, which will have the reference and which will also have some sort of a value. And that value can be anything that you want. It can be string, it can be boolean, or anything that you want. And here you can see that's going to be still an object. And inside this object, we would have our value, and we would also have our next property. So yeah, this is how our linked list, I mean like not linked list, but our stack looks like right here. Time to create our own stack. But before we create our own stack, first of all, we have to create our own node. Then we're going to be creating our stack based on that specific node. Okay, so how we are going to be doing that? Well, the first thing that we have to do is that we have to write a class result keyword, and then we have to create our node just like we did in the previous videos. Then we're going to be also providing the initial value of a value as a constructor. We're going to be setting this dot value, is going to be equals to this value, and then also we would set this dot next, and it's going to be set to initially null, as you can see right here. And it should be null. Okay, so what are we doing? We are now creating our node. We are now providing the value which will be initially set to nothing, and then we are also providing this next property which will be now initially set to null right here. So now this part is done. The next thing that we have to do is that we have to create our own stack based on that specific node which we just created right here. Okay, so what do you have to do? Now if you want to create your own stack, so the first thing that you have to do is that you have to write a class result keyword and then the stack. You can give it like any name that you like, but I'm going to give it the name of like stack because we are creating our stack. So now for the initial values, we're going to be only passing a value inside there. And also the first thing that we have to do is that we have to create our own node, just like this one. So how we are going to be doing that? Well, we will just write like new node, and we are going to be passing that value which we are taking inside this constructor. Okay, so now we have to store in some sort of a variable like const node, and it's going to be equals to this new node right here. So I'm going to just change that to like new node, and now underneath there we are going to be using this dot first, and we have to point there to our new node, and also this dot length, okay, and it's going to be equals to 1 right here. So now this is how we are going to be creating our node, and also this is how we are going to be creating our own stack right here. Okay, so now underneath there, let me just create an instance of this. So I'll just write like let the stack, or you can give it like any name that you like, and I'm going to just write like stack, and now initial value I'm going to just set that to 0, and finally let me log that to the console, so the stack. And now if I save my file and run my code, so now here you can see I have a stack, and the first property is now set to node, and the value which we are now providing a 0 right here, so that's why we have a 0. And also we have a next, which is now initially set to null, and we also have our length, which is now set to 1. Okay, so this is how we are going to be creating our node, and this is how we are going to be creating our stack. All right, so welcome to the first challenge. So what I want you to do is that I want you to implement the push method. So what is a push method? Push method now in this case will allows us to add a new item at the beginning at the beginning of our stack. So how that's gonna look like? So what I want you to do is that anytime you want to push a new item, you have to create that. So how you're going to be doing that? This is how you're going to be doing that. So first of all, you have to create your own node, and then you have to take this first marker and you have to point there to this newly created node. That's all the thing that you have to do, and this is how you're going to be performing, or this is how you're going to be creating your push method. So I want you to give it your best shot. If you can do it, that's completely okay. Come back and watch the solution. And now here is my solution. I'll just write like my push method, and it's going to be taking some sort of a value, because now we are going to be creating our node based on that value. So what we will do is that first of all, you have to create a new node. So now let's just do that. So to create a new node, first of all, we have to write a new result keyword, and we have to paste that value inside there. So I'll just give it the name of like const new node, and it's going to be now pointing to this newly created node. And now we have to check for the empty. Okay, so how we are going to be doing that? We're going to be using like this dot length is triple equals to 0. So what do we have to do in that case? We're going to be taking this dot first, and we are going to be pointing there to the new node which we just created. So what in the world are we doing? Let's suppose if we don't have any of these items right here. Okay, so I want you to imagine now we are going to be pushing our new item. So what we have to do is that we have to create that item, and we have to put that right here. We have to remove this null property from there, and we also have to set this first property, or the pointer, or the marker, whatever you want to call that, and we have to put there or point there to this newly created item. That's what you have to do. Okay, so let's just go back. Let's just go back. Okay, just like that. And now the next thing that we have to do, if that's not the case, what do you want to do in that case? We have to take like a new node, and we have to use the next property on there, and we're going to be pointing there to this dot first. Okay, so here you can see this was set to, this first property was set to, once we didn't create this newly created element right here, or node. Now we successfully created this node. We have to take this first dot next property, we have to take there, we have to point there to this newly created node, and we're going to be using this dot first, and we have to point there to this newly created node. And finally we're going to be just incrementing our length, and also we have to just return like what in the world are we doing. Okay, so what I'm going to do is that I'm going to just write like this tag, and I'm going to be using a push method on there, and I will push 1, I'm going to duplicate there, and I'm going to also push 2. So what we will get to see is a 0, and also the 1, and also the 2. So now if I run my code, so what are we getting? We are now getting a stack which will have the first property, which will be set to node, and now inside this node we have the value of, because that's going to be the newly created node, and we also have the value of 1 that's going to be coming from the next node, and we also have another one which will be 3. I mean like which will be set to 0, not 3. And so we have a length which is now set to 3. Okay, so this is how we are going to be using a push method, or this is how we are going to be creating a push method on our stack. Alright guys, so welcome to the next challenge in the stack. So what I want you to do is that I want you to just create the pop method. So as the name suggests, it's going to allow us to pop out the first node, or the first element from our stack. So how that's going to look like? So the first thing that we have to do is that we have to create our temp variable right here, and that temp variable will be pointing to the first node, or you can say the first element in our stack. Okay, so now the next thing that we have to do, like that's gonna be the first thing that you have to do. Okay, then the next thing that we have to do is that we have to take this first marker or the pointer, and we have to point that to the next node, and then finally we have to take this node and we have to set that to null, so it's gonna just remove this item entirely. Okay, so this is what you have to do. So I want you to give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution, and here is my solution. Let me just go back. I'm gonna just set everything to totally normal, just like that. Okay, so let's just create our pop method right here. Okay, so I'll just write like a pop method. It's not gonna take any parameter because we are now removing something. And by the way, I forgot to show you, but if our stack is totally empty, so we are not going to be doing anything. We are going to be just returning undefined. Okay, like if we don't have anything inside our stack, let me just remove that. So what we have to do, we have to just return the undefined, or you can return the null, or you can throw some sort of error if you wanted to. Okay, so that's totally on you. So yeah, let's just do that. The first thing that we have to check for is this dot length is triple equals to 0. So we have to just return, come on, return undefined. Next, we have to create our pointer, which will be let temp, and it's going to be now pointing to this dot first. Okay, as you can see right here. So now we are creating this pointer, or this temp pointer, and it's going to be now pointing to this first element. Okay, so that's going to be the first thing. Now the next thing that we have to do is that we have to take this dot first and we have to point that to the next element. So we are going to be using like this dot first dot next. Okay, so we are going to be taking this first pointer and we are going to be setting that to the next element, just like that. Okay, so now that's totally done. And now the next thing that we have to do is that we have to take this temp dot next and we have to point that to this null. Okay, so we are going to be taking this temp and we have to point there to this null, so which means like we are now totally removing that from our stack. Okay, just like that. And now we have to do that. We already did that right here. And finally we have to just decrement the length, and also we have to return the temp, and this is how we are going to be popping out the element or the node from our stack. So we have a 0 and we also have 1 and we also have 2. If I run my code, so here you can see we have the value of 2, then we have the value of 1, and then we have the value of 0, which you cannot see right now. But if I use the stack, if I use my pop method on there, and now if I save my file and now if I run my code, so what are we getting? We are now getting the value of 1 instead of that 2, and we are also getting another node which is now pointing to the 0, and here you can see the length is now decremented to 2. It used to be 3, now it's 2, so which means like we are now successfully implementing this pop method on our stack. So yeah, that was it about the stack, and now let's get into the queues. Time for yet another data structure which is called the queue. And I know the spelling is a bit weird, like Q-U-E-U-E. So what is a queue? A queue is a linear data structure that functions like a waiting line. And don't worry, I'm going to show you what a waiting line even means. And it follows the FIFO rule or principle. So what is the FIFO rule? The first in and the first out, meaning the first element that enters the queue first will be the first one to be removed. So what do I mean by all of this gibberish? Now let me just show you that. And here is my waiting line right here. Okay, so now imagine this is going to be some sort of a store or a coffee shop or something like that. This guy will be the first one to order a coffee or to buy something from the store. Okay, so this guy is now the first, so he will make the order, then he will come out from the store. Then this guy will be the second one, and this guy will be the next one, and so on and so forth. Okay, so the first in will be the first out. Now this guy is the first one, so this guy is the first in, and he will be the only one to first out, just like that. Then he will be the first one, and he will be the next one to go out, and then he or she might be maybe the next one. Then he or she will buy something, and they will be the last one to go out from the store. Okay, so that was my queue analogy. Keep in mind, now the first element or the first person or the first node that you want to add to our line, or you can say over a queue, so this process is known as the enqueuing. And now if we remove this first one, this process is known as the dequeuing, and I'm going to show you what do I mean by enqueuing and dequeuing. So time for the first challenge, and we did this challenge like a million times. Okay, so if you are watching this course, so I promise you already solved this challenge, but anyways, okay, so what do we have to do? We have to perform the enqueuing. So let me just explain what in the world is enqueuing. Enqueuing just simply means that we are going to be adding a new element at the end of our linked list, or you can say our queue. Okay, so now this is known as a queue, so we are not going to be providing the head and tail. Instead, we have to rename that to the first and the last, just like that. Okay, so what I'm going to do is that I'm going to just remove that from here, because we are now about to add a new element. So we are going to be first of all creating that newly created element, just like that. First of all, we have to create this element, then we have to point that right in here. Okay, so now this one will be no longer pointing to the null. Instead, that newly created element will be pointing to null, because this is going to be the last element. And now the next thing that you have to do is that you have to take this last pointer or marker, and you have to point there to this newly created node, just like that. And this is what we call enqueuing, and we already performed this challenge like a million times. Okay, so if you want to go ahead and do that by yourself, so feel free to go ahead and do that by yourself. And by the way, I forgot to show you how we are going to be even creating our oh my god, how we are going to be even creating our node and also our queue. But now let me just show you that, and then you can pause the video and then perform this enqueuing and dequeuing. Okay, so let's go. I am going to just remove that from here, and the first thing that we have to do is that we have to create our node, as we just saw a few seconds ago, and we're going to be providing our constructor and also our value. And now inside this node, we're going to be setting this start value to this newly added value, and this start next will be now set to this null right here. So this is how we are going to be creating our node. Now it's time to create our own queue. And now inside this queue, the first thing that we have to do is that we have to provide our constructor and also the value. Now inside this constructor, first of all, we have to create our new node, which we just saw a few seconds ago. And now we are going to be passing a value to them, and also we are going to be setting this new node, and we have to point there to this newly created node, just like that. And now inside there, still we are going to be using this start first, and we have to point there to the newly created node, and we also have to use this start last, and we have to set there to this newly created node. And finally this start length, length, and it's going to be now pointing to this one right here. So now let me just go back, and this is how we are going to be creating our node. This is how we are going to be creating our own queue. And now let me just create an instance of that. Okay, so what I'm going to do is that I'm going to just write like my queue, and it's going to be now equals to this new instance of this queue. And now inside there, I'm going to be providing a 0 as the initial value, and then I'm going to be using like const.log my queue. And now if I save my file and run there, so what are we getting? We are now getting our queue, which will have the first and last property. And now the first property is now pointing to this node, and now inside this node we have the value of 0, and we also have the next of null. And same will goes for the last one right here, because we don't have any other elements inside this queue. So this is how we are going to be creating our node, and this is how we are going to be creating our queue. And now I want you to pause the video and perform the enqueuing. Okay, so if you can do it, that's completely okay. Come back and watch the solution. And now it's time for me to give you the solution. So what I'm going to do is that I'm going to just write like enqueue. I know the spelling is a bit weird. And now inside there we're going to be passing a value, and I'm going to be first of all creating my new node. That's going to be the first thing that you have to do, because now we are going to be adding a new node, so we have to create that new node. Okay, just like that. And next we have to check for the length. Okay, so if this start length is triple equals to 0, as we just saw in the previous videos, and also in this video as well, so we are going to be taking this start first, and we have to point there to this newly created node, and we also have to take this last, and we have to point there to this new node, just like that. And now underneath this if statement, we're going to be taking first of all this start last start next, and we have to set there to this newly created node, as you can see right here. So it used to be right here in this third one. Now that we successfully created this newly created node right here, so we are going to be taking this pointer, and we have to point there to this newly created node. Okay, so this is what we are doing right now. Next we also have to take like this start last, and we have to point there to this newly created node, and we have to just increment the length, and we also have to return this. And now if I save my file, and this is how we are going to be performing the enqueuing. So I'm going to be using like my queue, and I'm going to just put like enqueue inside there as the method which I just made a few seconds ago. So I'm going to be providing 1, and then also 2. So we have 3 items inside there. First of all, we would have a 0, then we have a 1, then we have a 2. And now if I run my code, and here you can see we have a queue, and now the first value is now set to 0. That's because I'm now providing the 0 right here, and next value will be set to 1. That's because here you can see we're now providing the 1 value, and the third one is hidden, but you can trust me on this one that the next value will be the 2, or you can say the last value will be set to 2. And you can also see the length is now set to 3. So which means like we are now adding 3 elements or 3 nodes inside this queue. So that was it about for the Enqueue challenge, and now it's time to do the dequeuing. So what do I mean by a dequeuing? Or you can think about the dequeue is like a pop method. You have to remove the last element from your queue. So how that's gonna look like? The first thing that you have to do is that you have to take out this pointer. You have to point that to this previous one and say bye bye to this one just like that, and you have to set that to the null property. So give it your best shot. If you can do it, that's completely okay. Come back and watch the solution, and here is my solution. So what I'm going to do is that underneath this Enqueue, I'm going to be creating a dequeue just like that. The spelling is awful, and we have to once again check for the empty. I'm going to be using like if this dot len is equals to 0. So we are going to be just returning undefined, because we cannot remove anything if we don't have nothing. Okay, so now the next thing that we have to do is that we have to create our temp pointer, which will be now set to this dot first, which you can see right here. So let me just go back, and we are going to be creating our new pointer. Let me just duplicate this one right here, and I'm going to set that at the bottom. I'm going to give it the name of like temp. I know it is reverted. I'm sorry for my bad writing, or yeah, now that's looking better. Okay, so we are now creating our temp variable or a pointer, and we are now pointing there to the last element. Yeah, just like that. Now the next thing that we have to do is that we have to check for one element. So if you have like this dot length is triple equals to 1, so what do you have to do in that case? We are going to be setting this dot first is equal to null, and we are going to be also setting this dot last to null as well. And now underneath that, we are going to be taking this dot first, and we have to point that to this dot first dot next. As you can see right here, it used to be this pointer used to be pointing to this newly added value, and a few seconds ago I just moved that right here. So it used to be right here. So now this line mean, as you can see right here, this line simply means that we are now taking this pointer and we are now pointing there to this new element, or the previous element, not a new element, what the hell. And now underneath that, we're going to be taking this dot temp, and we have to set that to null. So now if we set that to null, so which means like this temp is not pointing to this one, so we are going to be just removing that from here, and now this pointer will be set to null. Okay, so which means like we now successfully removed that last item. So what do we have to do? We are going to be just using like this dot length, and we have to decrement that because now we successfully remove one element, and finally we have to just return, or not this but our temp, like what we just removed. And now I'm gonna be just providing like, first of all, let me just show you there. So if I run my code, and here you can see I have 3 items inside there, or you can say 3 nodes. And now the first one we have is a set to 0, then next one we have set to 1, and then the final one we have is a 2. Okay, so now if I use like my queue, and if I just use like dequeue, and now let me just execute that, save my file and run that, and here you can see the length is now set to 2, and we now successfully remove this 0, 1 from our list. So now we only have these 2 nodes inside our queue. So this is what we call the stack and also the queue, and this is how we are going to be doing the enqueuing and also the dequeuing. Alright guys, so time for the first lead code challenge. So what do we have right now? We have our node. As you can see right here, we created that like 1,000 times and then we have our own stack, and now inside this stack we only have this push method which we just created a few seconds ago, and this push method allows us to add new elements into our stack. Now the question is that I want you to add this min method, and this min method will give us the minimum node inside our stack. Like, what do you think? Is this the minimum value, or is this the minimum value, or is this the minimum value? Let me just zoom in. And you guessed it, the minimum value will be set to this one right here. Like, this is going to be the minimum value in our entire stack. But if I provide 0 right here, so now that 0 will be the minimum value. But if I change this one to like 100, now this one will be the minimum value, and the maximum value is set to this 3 right here. And now if I set this one to like 1000, yeah, just like the 1000. So now this 2 is the minimum value and this 1000 is the maximum value. Okay, just like that. So I want you to only find out the minimum value in your stack. So how you're going to be doing that? Well, pause the video, give it your best shot. If you can do it, then come back and watch the solution. And now let me write my own solution right here. So what I'm going to do is that I'm going to just define my main method inside there. And first of all, we are going to be checking like if this dot length. So we are going to be just providing like return undefined, and that's going to be it. And now underneath that, the next thing that we have to do is that we have to check out for the current, and that current will be now set to this dot first element. And we are going to be also searching for the minimum value. So we're going to be just writing like min value, and as a temporary pointer is going to be pointing to this current dot value. And what is a current? Current is now set to the first element inside our stack. Yeah, inside our stack. And here you can see we have a value inside there. So we are now just taking there and we are now pointing there to the minimum value. So that's the first thing. Now the next thing that we have to do is that we have to iterate over through this entire element inside our stack. So we are going to be using like current.next, iterate over through this entire stack as long as this current did not found the null. As long as this current is set to null, that's what I mean. Okay, so I want you to just iterate over through this entire stack, and once you are iterating over through there, I want you to change the value of the current to current.next. Okay, so let's suppose if we have 0, so we're going to be first of all checking, are you the min? No. Then we're going to be jumping to this one, then we're going to be jumping to this one, and so on and so forth. But we're not going to be just changing the value of the, first of all we have to provide our check or conditional check. So we're going to be using like current.value. If that's less than minimum, or you can say the min value which we have declared right here up above, and that min value is now currently pointing to the current.value, or you can say the first dot value in this case. Okay, so we are now checking if current value, as we are now iterating over through there, is less than the minimum value. So what do we have to do in that case? You know what, first of all let me just log that to the console. So I'm going to just write like current.value, and I'm going to be also logging to the console my minimum value. And now underneath there we are going to be changing our minimum value, and we have to set that to the current.value just like that. Okay, so now let me just save my file, and I'm going to be using this min method on there. So I'm going to just uncomment this line out, save my file and run there. And as you can see right here, the current value is now set to 2, and then the minimum value is now set to 3. So is 2 less than 3? And then we are checking is 1 less than 2. Then we are checking is 0 less than 1. So finally it's going to give us that 0 right here as the result. Okay, so that's there. Now underneath there, what do we have to do? We have to just return our minimum value, like what will be our minimum value which we are now defining right here. Okay, so now if I save my file and run there, and here you can see it's going to give us the minimum value that we have is set to 0. And if I comment this line out, and let me just save my file and rerun there, and here you can see it's going to only gives us that 0 right here, because that 0 was the minimum value inside our stack. But now if I remove this 0 from here, save my file and run there, and you guessed it, it's going to give us 1 right here. Okay, so this is how we are going to be performing the minimum value inside our stack. Okay, time for another challenge, which is find out isValidParenthesis. So now here you can see we have the list of totally valid parentheses right here. So we have like opening parentheses and closing parentheses, like totally exactly the same. So if that's valid, it's gonna give us the return value of true. If that's not valid, as you can see right here for this one, it's gonna give us false. And here you can see we're now providing this valid parentheses once again, so it's gonna give us true. And here you can see we are only providing the opening parentheses, but we are not providing a closing parentheses for there, so it's gonna give us false. So yeah, this is what we have to do right now. So give it your best shot. If you can do it, then come back and watch the solution, and here is my solution. So what I'm going to do is that I'm going to just create my own stack. So how we are going to be doing that? Well, we have to just write a stack, and it's going to be pointing to, or it's going to be equals to this array. So now inside this array we have all of that method like push and pop and unshift and shift and all of that method. So this is how we are going to be creating our own stack, and we are now creating this stack for the opening brackets only. like we are now using this tag to store the opening brackets only. Okay, so that's the first thing that we have to do. Next, we have to create our own brackets. So like const brackets, and it's going to be equals to this object right here. And now inside there we have to provide our own pattern. Like this is going to be the opening and this is going to be the closing for the object. Next, we are going to be also providing yet another pattern, like this is going to be for the array, or you can say the simple bracket or whatever you want to call that. I don't even know all of them. And this is going to be for the closing one. And then finally I'm going to just provide one more, which will be for these parentheses, and then this is going to be the pattern for closing these parentheses. So this is how we are going to be adding our brackets, or you can say the pattern which we have to follow. Okay, so now the next thing that we have to do is that we have to loop through each character in our string. Okay, so how we are going to be doing that? Let me just go back. First of all, we are going to be just writing like let char of string. Now we are going to be iterating over through this string right here, like whatever we provided right here as the argument for this parameter. So we are going to be iterating over through each of the character, like the opening, then the closing, then also the opening, and then the closing. Now inside there we are going to be performing a check. Okay, so I'll just write like brackets dot char. So what do I mean by that? If this is the opening bracket, so what do we have to do in that case? We have to just write like a stack dot push, and we have to only push that opening bracket just like that. And if that's not the case, so what do we have to do in that case? If that's a closing bracket, so we have to check if it matches the top of the stack. Okay, so we will just write like stack.pop, so it's going to give us the top of the stack. And now let me just store that in the top variable. You can store that in any variable that you like. And now underneath that, we are going to be providing yet another nested check right here. If not top, or this bracket which you are now providing right here, or this pattern, whatever you want to call that, we are going to be also providing our top value inside there. If that's not equals to that character which you are now iterating over through, so we have to just return false. Okay, so just like that. And now underneath there, we are going to be just returning our stack.length. If that's equals to 0, so then we have to just return nothing. And so this is how we are going to be creating our stack. This is how we are going to be creating our pattern. This is how we are going to be iterating over through each character in our string. Now we are checking if we have the left value, so we are going to be pushing that to our stack. And if we have the right value, so we are going to be first of all getting the top value. We have to check if we have the top value or we have the right of the bracket is not equals to that character, so we have to just return or false. Otherwise we have to check if stack.length is equal to 0, so we don't have to do nothing. Okay, so now let me just run there. So what are we getting? We are now getting the true for this first one right here as expected. Then we are getting a false for this one, because as you can see right here, now we are not providing any closing bracket for this one, just like, okay, that's the only reason we are now getting this false right here. Then we are getting a true because this is now matching with our pattern, so that's why we are now getting a true. And now this one is not matching with our pattern, so that's why we are now getting false value right here. So yeah, that was it about, let me just rerun that. I guess I messed it up something. Nope, totally correct. So yeah, that was our isValidParenthesis matcher. Alright, time for yet another challenge, which is the reverse string, or you can say the string reversal. So we already performed this challenge like a million times before, but we have to do that by using the stacks in this case. So give it your best shot if you can do it. Let me just explain that right here. So here you can see we're now providing a hello world right here, and it is now giving us the reverse of our string. So yeah, that's the only hint that I can give you. So give it your best shot if you can do it. Come back and watch the solution. And here is my solution. So the first thing that we have to do is that we have to create our empty stack. So I'll just write like const and then stack, and we're going to be setting that to our array, and it's going to give us that push, pop, shift, unshift method totally for free. Now the next thing that we have to do is that we have to iterate over through this string, and we have to push the like each character to this stack right here. So let's suppose if I have hello world, so we're going to be taking this H, we're going to be storing the in this stack right here. Then we're going to be taking this E, we're going to be storing the in the stack, and so on and so forth. So now let's just do that. So I'll just write like for let char, like for let character of that string. So what do you have to do in that case? We have to take that each of the character, and we have to push that to or stack right here, just like that. Now the next thing that we have to do is that we have to initialize the empty string, so to store our reverse string. So I'll just write like reversed string, and it's going to be now set to totally empty string, just like that. And now underneath that, we have to pop each character from our stack to build the reverse string. So we are going to be using like while stack.length is greater than 0. So we have to just pop that out from our stack. So we're going to be using like reverse string, come on, plus equals to this tag.pop, and we're going to be popping there, and it's going to give us the reverse string right here. So if I just return like a reverse string just like this, save my file and go back, and I guess I messed it up something, so I'm going to have to copy this one. Now let me just place it right here, and I'm going to also place it right here as well. So now if I save my file, and here you can see we're now providing a hello world, so it's going to give us the reverse of there, like dilro. I don't even know how to pronounce this word. So now let me just run there, and here you can see it is now giving us this whatever this is. So it is now giving us the reverse of that. So now if I just provide like HuXn web dev, which is my own name, so now if I run there, it's gonna give us, I don't know, yeah, it's gonna give us the reverse of that. And if I just provide like just hello, and now if I save and run there, it's gonna give us ole. If I provide like hi, it's gonna give us, I guess, or something, and here you can see we are now getting like yeah, that was our stack Enqueues, and that was it about for this video, and I'm gonna see you guys in the next video. Take care, and if you enjoyed this video, so feel free to subscribe to this channel. Again, HuXn, and welcome to the data structures and algorithm masterclass. So in this video, we are going to be learning about the hash tables from scratch. Plus, we are going to be also solving a lead code challenges. So now let's get into it. So a hash table is a data structure used to store the key value pairs. And we already know what a key value pair is. So if you are coming from any of these languages, you already know what a key value pair is. So if you are coming from a JavaScript, which you should be if you are watching this video. So in JavaScript, we call it objects, and in Python, we call it dictionaries, and in Go, we call it maps. And there are a lot of languages which supports hash tables. Now the question is, if we already have all of that, so what's the point of discussing this hash table? Well, the point is we're not going to be using these built-in. We're going to be creating our own version of a hash table, like our own version of objects, dictionaries, and maps. Okay, so that's what we are going to be doing. But now how we are going to be doing that? And to do that, we are going to be using something called the hash function. Suppose if you want to store a phone number in a hash table, like we would have a John, we would have a lot of people and their phone numbers. So now let's suppose if you want to store them in the hash table, so how in the world we are going to be doing that? And to do that, we are going to be using something called the hash function. I know you will be probably thinking like, HuXn, we are now talking about the hash table. What in the world is a hash function? And by the way, you don't have to worry about what a hash function is, but I'm going to still explain that just for those people who care. And trust me, you will never use the hash functions in your day-to-day life. So now let's talk about the hash function. So hash function acts like a translator, taking an input of any size and converting it into a fixed value, which is called the hash code, which I'm going to be showing you there in a real diagrams, but I want you to just give me a few seconds. That can be used as an index within the hash table internal array, something which I'm going to be showing you. I'm not just talking about the theory, I'm going to be showing you there. And this process of mapping arbitrary keys to fixed length indices is called the hashing. Okay, so that was just a quick definition of what a hash function is, but how a hash function will even looks like, and this is how it's gonna look like. And if you want to read through that, so I want you to pause the video and read through that, but if you don't, well, you don't have to worry about that. So now let me show you in diagrams how our hash function will look like, and this is how our entire thing will look like. So this is going to be our hash table, which we are going to be creating in a few seconds. This is going to be our arbitrary data, and this is going to be our hash function. So now what in the world is this hash function will do? This hash function will do two things only. So if you take this data and we put that inside this hash table, so it's going to do two things. The first thing it will do is that it's going to give us a unique identifier, or you can say the index. Okay, so now let me just make that a bit bold. So it's going to give us some sort of a location where we are going to be storing our data inside that specific location. So now in this case it gives us 2, so we are going to be storing our data inside this 2 right here in this area. So that's the first thing. Next, it's gonna take our data and it's gonna wrap that in the bracket, or you can say array, whatever you want to call that. So it's gonna wrap that in the double array just like that. Now we are going to be taking this data and we are going to be storing that in that specific index, which is coming from this hash function right here. So let's suppose if it gives us like 4, so we're going to be taking that data and we're going to be storing that in this 4th index just like that. So that's what a hash function will do. First of all, it's going to give us a unique index, then it's going to convert our data into array, and then we're going to be storing that array data inside that specific index. So that was just a basic theory of a hash function and also a hash table. So now let's just first of all create our hash table, and then we're going to be also creating our own hash function, but you don't have to worry about how we are going to be creating our hash function. So now let's just do that. So the first thing that we have to do is that we have to write a class. You can use a function if you wanted to, but in my case I'm going to be using a class. Then we have to give it some sort of a name for our class. So I'm going to just give it the name of like hash table, because we are creating our hash table. So now inside there we're going to be passing our constructor, and then we're going to be providing some sort of a size. You can provide 10, you can provide 5, you can provide any of the size that you like. In my case I'm going to just stick with this 6, and then we are going to be using a property which will be this dot key map, and it's going to be now set to this new array, because we are going to be converting our data into this array, and now we are going to be passing this size, and we are also providing a default value of 6 to there. So now let me show you what in the world we are doing. First of all, we are creating some sort of a hash table, and then inside that hash table we are going to be storing 7 or 6 items inside there. So what are we doing? We are now creating our hash table, and it should be you know, I'm gonna just change that to 5, because that's what I show you in the diagram. So this is how we are going to be creating our hash table. So now it's time to create our own hash function. So the coding will be a bit weird, and as I said that you don't have to worry about how we are going to be creating our own hash function. Okay, so first of all, let me just go back. We're going to be using this hash function as a name, and you can give it like any name that you like. The name doesn't matter. And then we're going to be specifying some sort of a key, and it's going to take that key, it's going to hash that. So what do we have to do? The first thing that we have to do is that we have to write a sum, and it's going to be now set to 0, and this will be used to store the hash value. Later we are going to be seeing that in a few seconds. Next we have to take care of the prime number, so I'll just write like a prime, come on, prime, and then number, and now it's going to be equals to this 31 prime number. Underneath that we have to loop through our data less than mat.min, and we're going to be passing the key.length inside there, length length, there we go. And we are going to be also providing this 100 right here, and then finally we have to just increment our I by 1. So what in the world is all of that gibberish you and mean, which you can see right here? This means they loop through each character of the key, but only up to the maximum of 100 characters. This basically just ensures that the function don't take much longer, like much longer keys. Now inside there we have to convert that to a number, so we are going to be using like a char code. It's going to be equals to key dot char code at. So we have that function in JavaScript. If you want to learn more about that, I have a I already explained that in my complete JavaScript course. If you want to check that out, feel free to do that. And we are going to be also passing 96 inside there. And finally we have to change the value of sum, so I'll just use this formula which I copied from the ChatGPT, which will be sum and times and then the prime number, and then we are going to be also adding the character code, and then we are going to be using the modulo this dot key map, and then we have to grab our length inside there. Underneath there we have to just return our sum, and that's going to be it. So if I save this file, and this is how our hash function looks like right here. Once again, you don't have to worry about this hash function. And yeah, this is how we are going to be creating our constructor, and this is how we are going to be defining our hash function inside there. Time to create our own set method. So how that's going to look like? The first thing that we have to do is that we have to take our data and we have to hash that. Okay, so if we hash our data, so it's going to give us the index. Okay, so like in this case it's going to give us 2. We're going to be searching for that 2 index right here, so which we already have available inside our hash table. So now that we found that index, the next thing that we have to do is that we have to check if we already have array inside, like if you already have empty array, or if you have some sort of items inside this array, then we have to just take this data and we have to put that inside that array. But if that's not the case, so first of all we have to create our empty array, and then we're going to be, you know, let me just provide some sort of a spaces right here. We have to create our empty array, and then we have to take that data and we have to store that inside this empty array. And by the way, we are going to be also wrapping that in yet another array. Okay, just like that. Let me just show you get the idea. So let me just copy that and place that right here, and I'm gonna also copy that and place that right here, just like that. I know the drawing is not that much good, but you get the idea. Let me just say that once again. First of all, we are going to be taking our data, we are going to be putting that inside the hash function. It's going to give us some sort of an index. Then we have to check if you already have empty array or some array inside there. So then we have to just take our data and we have to put that inside that array. But if we don't have any array, we have to first of all create a new array, and then we have to store that data inside that specific array. You get the idea. So now let's just do that. Okay, so first of all, we have to just create our set method. It's going to be taking some sort of a key and also the value. And now inside there, first of all, we have to hash our key, which we are now taking as a parameter for this function. So we're going to be using this dot hash function right here, and we're going to be passing our key inside there. So as the result, it's going to give us some sort of an index, which we are going to be storing there inside this variable. Now we have to check if we already have an empty array or not inside that specific index. Okay, so now let's just do that. We're going to be using the if statement, not this dot key map, and we're going to be passing an index inside there. Come on, key map, and we're going to be passing an index inside there. So what do I mean by that? Let me just comment there for a few seconds so you guys can see that a bit better. And you know what, I also forgot to show you how our index will look like. So now let me just save there. So if we hash our value, we are going to be getting some sort of an index. So which kind of index we are going to be getting? Now let me just show you that. First of all, let me just create an instance of my hash table, and now we have to store that in the phone book, some sort of a variable. Okay, and then we have to use our phone book dot set method, and we have to provide our key, which will be John, and we're going to be also providing some sort of a value for there, like 555, 333, and also 444. And now let me just save my file. And now if I run my code, so what are we getting? We are now getting the 0 index right here. That is coming from this index. So if I provide a separator right here, let me just provide some sort of a separator. And now if I save my file and run that, and here you can see that 0 is now coming from this index right here. Now we also have to check this statement. So I'm going to copy there. And now let me just log that to the console. Just like that. I'm gonna save my file and run there, and it's gonna give us true. And why are we getting a true? Because in this case we don't have empty array already available inside that specific index. So that's the only reason we are now getting a true. So now let me just uncomment there. And if that's the case, like if we don't have any empty array, so we're going to be using like this dot key map, and we have to just set there to this empty array. So I'll just remove these curly braces from here, and I'm gonna save my file. I think this is looking better. But if we already have an empty array, so we have to take our data and we have to store that in that array. So we're going to be using like this dot key map, and we're going to be passing our index inside there, and then we're going to be using a push method, and finally we have to just push our key and also the value, which you can see right here. We have to push our key and also that value to this existing array. So I'll just return this so that we can see. Now let me save my file, and now if I run my code, so what are we getting? We are now creating our hash table, and now inside there we have our key map, and then here you can see what we have our outer array, and then we have our inner array inside there, and now inside that array we have our content like our key and also the values. And you cannot see there, that's because we did not create our get method, and we're going to be creating our get method in a few seconds. Okay, so time for the get method. So how that's gonna look like? First of all, we are going to be providing some sort of a property to our get method, and our get method will take that property and it will hash there. So once it hashed there, it's going to give us some sort of an index based on that property. So it's going to give us like, I don't know, maybe 2 or 3 or some sort of an index. Okay, then we are going to be going into that index, and first of all we have to do a bit of check. Do we have some sort of a data inside this index? If we have some sort of a data, then cool, then we're going to be iterating over through their data, something which I'm going to be showing you right now. And if we don't have any data, so we're going to be passing undefined. There we go. Okay, so let me just say that once again. First of all, we are going to be providing some sort of a property to our get method. Our get method will take that property and it's going to hash there. So once it hashed there, then it's going to give us some sort of an index based on that hash. Then we are going to be going into that specific index, and we have to check If we have some sort of a data inside that specific index, then cool, we have to iterate over through that data. But if we don't have any data, so we are going to be just showing undefined. So now let me just show you, like if we have some sort of a data inside our index. So first of all, we are going to be iterating over through this outer array, which you can see right here, this blue array. We are going to be iterating over through there, and we are going to be checking, like, are you that element, like the John which I'm searching for? So it's going to say no. And then we're going to be also asking this one, are you the John? And it's going to also say no. But if I change that to John, like let's suppose if we already have some sort of a property of a John, so it's going to give us the value of that. And that's the entire process of the get method. So if you want to do that by yourself, so give it your best shot. If you can't do that, then come back and watch the solution. And here is my solution. So what I'm going to do is that I'm going to be creating a get method, and I'm going to be also passing a key to there. Okay, so first of all, we have to hash our key. So we're going to be using like this dot hash function, hash function, and we have to pass our key inside there, and we're going to be storing there in the index variable, just like there. Underneath there, we are going to be checking if we already have some sort of a data or not. So I'm going to be passing like if this dot key map, and we're going to be passing that specific index. So if that's the case, then we're going to be iterating over through that data. Like first of all, we are going to be checking like, do we have some sort of a data in this area? If we have that data, so we are going to be iterating over through these arrays. But if we don't have any data, so we are going to be just returning undefined, just like that. So this is my check. But if we don't have any data, so we're going to be just returning undefined, just like that. But if we have some sort of a data instead of that undefined, we're going to be first of all iterating over through this array, and then finally we're going to be iterating over through this array, and we're going to be searching for that specific item inside that array. Okay, so how that's going to look like? First of all, we're going to be using like for let I equals to 0, and then I is less than this dot key map, key map, and we're going to be passing our index inside there, and we're going to be also getting the length of there. And finally, let's just provide our incrementation, and then we have to check if this dot key map and then that specific index, and we're going to be also providing an index right here, and we want to get the first element inside there. If that is equal to the key which we are now providing for this get method, which is now hashed right here, so if that's the case, so what do we have to do? We just have to return this dot key map, key map, and we're going to be passing our index and then I, and finally our data. Okay, so now let me just save my file, and I'm gonna just run there right here. So instead of that console.log, I'm gonna just remove that from here, and I'm gonna provide like phonebook.get, and we're going to be passing John in this case. Okay, so if I specify John, save my file and run there, it's gonna give us an error. I don't know why. It's gonna give us an error. Let me just see. Oh, that's because we are now passing a key. Instead of a key, we have to specify our key map. Okay, so now if I save my file and run there, it's not going to give us anything. But if I log that to the console, like console.log, and now let me just save my file and run there, it's going to give us that specific data, or you can say it's going to give us the John phone number. But if I specify my own name, which is not available inside our set, it's going to give us undefined, which you can see right here. So yeah, that was the get method in our hash table. Okay, time to create two final methods, which is called the get all keys and also the get all values. So how we're going to be doing that? First of all, we're going to be iterating over through each element inside our hash table, and we're going to be searching like, do you have any elements or items? It will say no. Then we're going to be asking this one like, do you have any items? It's going to say no. Then we're going to be checking this one, do you have any data or items or elements, whatever you want to call there? And it's going to say, yeah, I have some sort of a data. So we're going to be zooming into it. And first of all, we're going to be iterating over through this area, and then we are going to be getting all of the keys from there, and later we are going to be also getting the values from there. So we are going to be creating two different methods for that. Let me say that once again. First of all, we are going to be iterating over through each element inside our hash table, and then if we found some sort of a data, then we are going to be iterating over through this outer array, and then we are going to be getting our keys and also the values. So now let's just do that. First of all, we are going to be creating our get all keys method. So get all keys. Now inside there, we are going to be creating a container where we are going to be storing all of the keys. So that's going to be our container. And now it's time to iterate over through our entire hash table. So we're going to be using like for let I equals to 0, and then I is less than this dot key map. and then we're going to be taking the length of that, and then let's just use our I++, and now inside there we are going to be checking like, do you even have the data or not? So we are going to be using like this dot key map and we're going to be providing the index or the data inside there. So that's then. Now the next thing that we have to do is like, if we found that we have some sort of a data inside there, so what do we have to do in that case? We have to iterate over through that data. So we're going to be using like, let j equals to 0, and then j is less than this dot key map, and we have to specify our index inside there. And now let's just get the length of that, and finally we are going to be using a j++, and now inside there we are going to be using like keys.push, and we have to push that to our container like this dot key map, and we are going to be pushing like I and also the j, and we're going to be pushing that first element, which will be the 0. Okay, and finally we're going to be also returning our keys so that we can see what we have. So let's just return our keys, and I'm going to save my file, and now let me just collapse that, and here you can see I already pushed a John, Jordan, and also the Michael. And now let me just use console log of phone book dot get all keys, and I'm going to just execute this. So if I save my file and run there, and here you can see it's going to give us the key of a John, Jordan, and also the Michael. So now let me just push myself like HuXn, and now if I save my file, and here you can see I am now right here inside this linked list. Not a linked list, a hash table. There we go. I'm going to remove myself from there. We're going to be creating a method for get all values. So get all values. So now inside there we are going to be getting the values, so we have to create our container for the values. Okay, so I'm going to be using like for let I is equals to 0. That's exactly the same process, and then finally we have to iterate over through our entire hash table, and then we're going to be getting the length of that. So I'll just use like I++. So that's going to be the first iteration. We have to check like if you have some sort of a data, so we are going to be only interested in that specific area. Okay, so let's just get there, and if we have some data, so now let's just iterate over through that data. So I'm going to be using like j is equal to 0, and then j is less than this dot key map, and I'm going to be also passing the index inside there, and then the length. And if that's the case, so we have to just increment that. So finally we have to grab the values. So I'm going to be using like values dot push, not unshift but push, and we have to push over this dot key map, and let's just push over I and also push over j and the first element. And finally we are going to be just returning the values so that we can see what we have. Okay, so yeah, this is the entire code. I'm going to collapse this code, and finally let me just duplicate this line of code, and I'm going to be using like get all the values. So now if I save my file, I'm going to comment this line out, save my file once again, and if I run there, and here you can see I'm now getting all of that values right now. So this is how we are going to be getting all of the keys and the values, and the get method and the set method, and also the hash method. Alright, so that was it about for the custom hash table, and now it's time to perform a few lead code challenges. So the first challenge that we have to do is that we have to create the word counter. So what do I mean by that? Here you can see I have a text variable right here. I have a few English words, like I have hello, then I have my, and then I have name 3 times, and then I have is and HuXn. So I want you to create some sort of a function where we are going to be passing that text, and it's going to give us like how many times that specific word is appeared in our text. Like hello is 1 time, my is 1 time, name, just like this. As you can see right here, so we have hello 1 time, my 1 time, name 3 times, as you can see right here, and also we have a is 1 time and also HuXn 1 time. So give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution. And here is my solution. So the first thing that I'm going to be doing is that I'm going to be creating some sort of a function. I'll give it the name of like word counter, and now as a parameter I'm going to be passing a text inside there. And the first thing that we have to do is that we have to convert our text to the lowercase text. So how we are going to be doing that? Well, we already know how we can do this. We are going to be using like text to lowercase method, and it will make our text totally at the lower. So I'm going to be using like lower text, and it's going to be now equals to the result of this lower text. So that's the first thing. Now the next thing that we have to do is that we have to create a hash table to store our counts. So now let me just do that. We are not going to be creating a custom hash table, but we are going to be just creating the object. So I'll just write like word map, just like that, and it's going to be now set to this empty object. Underneath that we have to split our text into words. So how we are going to be doing that? Well, we have to use the split method on this. We are going to be using like lower text, which is our variable right here, and we have to convert that to each word. So we are going to be using the dot split method, and we are going to be passing this regex. and you don't have to worry about this regex. We can like totally do that in a lot of different ways, but this is just a one way to do that. So I'm gonna just store that in the words variable, and you know what, let me just show you that. So if I log that to the console like words, and now let me just save my file, I'm gonna go back, and now let me just create a text variable, and we're going to be storing the value of like, hello, my name is HuXn, just like that. And now if I use like word counter, and we're going to be passing our text inside there, so it's going to give us some sort of a result. And you know what, now let me just save my file and run there, and here you can see it's going to change our text to these words right here. So here you can see we have hello, then my name and is HuXn, which is amazing. So now let me just remove that. Now the next thing that we have to do is that we have to iterate over through these words. So how we are going to be doing that? Well, there are like 1,000 ways to do that, but in my case I'm going to be using const word of words. So I'm going to be using a for of loop, and now here we have to check if we have the word inside the word map. And what is the word map? Now let me just show you that. So here you can see this is going to be our word map. We're going to be pushing our content to this hash table or object, whatever you want to call there. So then we have to just write like word map, and then we have to pass our word inside there, and we have to just use the ++ symbol. And if that's not the case, so we have to just set that to that specific word. So I'm going to just write like word map. We're going to be also passing a word to there, and now we are going to be setting there to 1. And finally we have to just return what we did. So we have a word map just like this. So now I'm going to save my file. I'm going to also remove these empty spaces from here, and this is the entire code that you have to write. Okay, so yeah, now if I run my code here, you can see we are not getting anything. That's because we have to store this in some sort of a variable. So I'm going to just write like result, and now let me just log there to the console. So now if I save my file and run there, and here you can see we are now getting hello 1 time, my 1 time, name 3 times, is 1 time, HuXn 1 time, which is amazing. So now let me just zoom in a bit, and now let me try out something else like I don't know, walk the dog. And now let me just run there, and here you can see we are now getting walk 1 time, the 1 time, and dog 3 times. So yeah, that was our word counter. Alright, so now that we have to solve the two-sum problem, we already solved that throughout this course, and as I said that we are going to be refactoring that code once again. I'm going to be writing the code from scratch, but if you want to refactor that previous code, you are more than welcome to do that. So what do we have to do? First of all, we have to create some sort of a function which will take 2 parameters. It will take the nums array, and it will also take the target value. So here you can see I have a nums array right here. I mean, like, it shouldn't have to be a nums array. You can give it like any name that you like, but you have to create some sort of array with a lot of elements. So now here you can see we have 2, 7, 11, and 15. Now what we have to do is that we have to combine these 2 words with each other, and for the pair we are going to be getting their target value. So what do I mean by all of these gibberish which I am saying? Basically you have to add 2 numbers with each other, and you have to check whether the combination of those 2 words is equal to 9 or their target value or not. So we already know if you combine 11 plus 15, so it's going to give us some sort of a value which is higher than 9. But if you combine 2 and 7, so it's going to give us 9. Okay, so then we are not done yet. We have to find out the indexes. So we have to find, like, this is going to be the 0 element, and this is going to be the 1 element. So this is how we are now printing there right here. So I want you to give it your best shot. If you can do it, that's completely okay. Then come back and watch the solution, and here is my solution. The first thing that we have to do is that we have to create an object to store the numbers and their indices. So we have to just write like num map. Now we are going to be storing our indices inside this map, or you can say the object, whatever you want to call that. Now the next thing that we have to do is that we have to iterate over through that nums array. Okay, so how we are going to be doing that? Well, we have to just write a for let I equals to 0, and then I is less than nums.length, come on, length, and then I plus plus. Now inside there we have to get the complement. So how we are going to be getting there? We have to write the target minus the nums and each number inside our nums. Okay, so you know what, now let me just log that to the console like complement, and now we have to just log that to the console complement, and I guess the spelling is correct. But now if I save my file and if I run my code, so what are we getting? We are now getting like 7, 2, -2, and -6. Okay, so that's there. Now the next thing that we have to do is that we have to check. Now let me just write a check if complement in the num map and the num map have that complement is not equals to 1, just triple equals to, I mean, like, not 1 but each element inside this loop. Okay, so then we have to just return the num map, and also we have to provide a complement there and also our index inside there so we can see there. Now underneath this if statement we have to provide our num map, and also we have to get the nums. Let me just remove this empty space from here, and we also have to provide our index right there, and we have to set there to this index. And if that's not the case, so we have to just return an empty object, like empty array. So now if I save my file, now let me just go back, let me just run my code. So if I run my code, so here you can see it's going to give us the index of 0 and 1 as we expected. Okay, so here you can see the target value is now set to 9, and we are now combining both of these words, and we are now getting the indexes of each of these words or data, whatever you want to call that. So now let me just change this one to like, I don't know, maybe 10, and this one to 20, and the target I'm going to set there to 30. Okay, so now if I save my file and now if I run my code, so what are we getting? We are now getting 2 and also 3. And why is that? Because this one is 0, this one is 1, and this one is 2, and this one is 3. So that's why we are now getting the result of 30 right here. So yeah, that was the two sums. So the real question is, what is a tree and why you should even care about that? So here is the Wikipedia definition, and you don't have to worry about that. If you don't get it, you don't have to worry about that, because in this course I'm going to be teaching every single thing that there is to learn about the trees. So a data structure tree is the fundamental hierarchical data structure. It represents a collection of elements, data, called nodes, connected by edges, links, forming a tree-like structure. And I know it is a bit weird definition, so I know that you don't get it. So now let me just break this down for you, and now let me show you how the tree even looks like. And this is how the tree looks like right here. So if you haven't watched my previous video on linked list, you gotta watch that video first, then you will be able to follow along with this video. Anyways, so here you can see I have my node, and now my node is pointing to the left and also to the right here, as you can see, and this node will be the parent of these children. So you can either call them as a children, or you can also say that these are going to be the siblings of this parent. And by the way, if this is going to be the very first node in your entire tree, so you can call this one as the root node, and we are going to be also writing a code for that, so you don't have to worry about that for now. There are a few things that I want you to keep in mind about the trees. Okay, so if we don't have any other nodes, so these nodes are something called the leaf node, because they are not pointing to any other node, so you can call them as the leaf node. So that's the first thing. Next, we have a full tree. So what do I mean by a full tree? A full tree is a tree where each node either has no children, or you can say the leaf node, or exactly will have 2 children. So what do I mean by that? As you can see right here, so now this one is a full tree. So what do I mean by that? Here you can see it has 2 nodes right here, and I am saying that it will either have exactly 2 children, or it will have 0 children, like no children whatsoever. Okay, so this one is a full tree, and this one is also a full tree. As you can see right here, it has 2 nodes. And now you might be asking, like, well, is this a full tree? Yeah, of course it is, because it doesn't have any other nodes. So this one is also a full tree, and here you can see the definition. Each node either has no children, or you can say leaf, or exactly 2 children. Okay, so this is something called the full tree. Next, we have a perfect tree. So it will have all the functionality of the full tree, and also it will be a balance. What do I mean by a balance? Balance simply means that all the leaf nodes are at the same depth, like distance from the root. So here you can see I have these leaf nodes right here, and they will be exactly at the same distance. As you can see right here, they are now at the end of this parent node. What if I create a new node? So let me just bring this down right here. So is this a perfect tree? No, of course not, because here you can see I'm now mentioning that all the leaf node, and these are no longer a leaf node. Like this one is a leaf node, but this one isn't a leaf node because it is now pointing to yet another node. Okay, so all the leaf nodes are at the same depth, distance from the root. Okay, so here you can see they are not exactly at the same depth, like distance from the root. So this is no longer a perfect tree. Okay, so if I want to make it perfect, so I'm going to have to just delete this last node, and here you can see this is something called the perfect tree. The last one we have is a complete tree. So here is the diagram of that. But now first of all, let me just show you like what in the world is a complete tree one mean. All levels except possibly the last one are completely filled with nodes, as you can see right here. Like all of that last nodes, as you can see right here, are totally complete with these nodes. Okay, so here you can see them. This is something called the complete tree, where the last level is filled with the nodes from the left side as much as possible. So that was a few examples of a tree. So this one is a complete tree. We also saw the perfect tree. We also saw the full tree. And finally, we just discuss a few more topics like what is a leaf node, and also the parent and the children. And by the way, this is going to be the root. So now let me just show you that root, by the way. Okay, so if that's going to be the first node, so this node will be called as the root node. So now let's discuss something called the BST, or the binary search tree. So a BST is a special kind of a binary tree used to organize data in a sorted way, and here the keyword is a sorted way, and it works like a filing cabinet where you can efficiently search, add, or remove items from. So that was just a quick definition of what a BST is, and now let me show you in action how BST works. So there are a few things that you have to keep in mind when working with the binary search tree, or you can say the BST for short. Okay, so what are those things? If you want to add a new element to your existing tree, the first thing that you have to keep in mind is this statement. So what is this statement? This statement said that go to the left if the value is smaller than the current branch, or go to the right if the value is bigger than the current branch. So what in the world is all of that gibberish even means? Here we already would have some sort of a value right here, and this is going to be our root. You can say that this is going to be our root node. So now if you want to add a new node to this root node, the first thing that we have to keep in mind, we have to check if this current node is smaller than this existing one, as you can see right here, the root one. So what do we have to do in that case? We have to put that right here on this side. Otherwise, if this is bigger than 5, so we have to put that right here on this side. Okay, so you got to keep that in mind. Let me just say that once again. Go to the left if the value is smaller than the current branch. Go to the right if the value is bigger than the current branch. Okay, so now we are going to be placing there right here because add is greater than 5. So we're going to be putting this add to the right, just like that. Next, we have a 3. Okay, so here, once again, we have to ask ourselves this question like, is 3 greater than 5 or is 3 less than 5? Of course, 3 is less than 5. So we have to keep that right here, or we have to put that right here. Okay, so next we have a 1, and here is the problem. Next we have a 1. Okay, so we have to ask ourselves this question like, is 1 greater than 5 or is 1 less than 5? Of course 1 is less than 5. So we cannot put that right here because this area is already filled out. Okay, so next we already searched that right here. We also have to search this element with, or you can say this node with this node. So we have to check, is 1 greater than 3 or is 1 less than 3? 1 is less than 3. Okay, so what do we have to do? First of all, we have to take out this pointer and we have to move it right here. And now we are going to be taking this one and we are going to be putting that right in here. Okay, not to the right, not just like that. We are not going to be putting that right here. We are going to be putting that to the left. Why is that? Because 1 is less than 3. 1 is also less than 5, so we are going to be putting there right here. Next we have a 7. So we have to once again ask this question like, is 7 greater than 5 or is 7 less than 5? So of course 7 is greater than 5, so we have to put that right here. No, we cannot do that. And why is that? Because here we already have a new element, or you can say we already have a node, so we also have to compare both of these values as well. So we have to check, is 7 greater than 8 or is 7 less than 8? Of course it is less than 8, so we have to just put that right here. So now let me just take out this pointer and we have to point that to this newly created node. Okay, so I'm gonna just put that right here, and now this is looking better. Now the final one we have is a 9. So this is going to be the last comparison that we have to do. Is 9 less than 5 or is 9 greater than 5? Okay, so of course 9 is greater than 5, so then we have to also make a comparison between these two. Okay, so we have to check, is 9 greater than 8 or is 9 less than 8? Well, of course 9 is greater than this 8, so we have to take this 9 and we have to put that right here on the right side. Okay, so I'm gonna also just steal this marker or pointer, whatever you want to call that, and we have to just set that right here, just like that. And this is how we are going to be creating our what do we call it, BST or binary search tree. Okay, so that was a bit of theory about the BST, and now let's write some code. So the first thing that we have to do is that we have to create our node, as you can see right here. So we have to create this node, and then we are going to be pointing there to these other nodes. Okay, so what do we have to do? First of all, we have to write a class, and then we have to create our node. Inside this node, we are going to be passing our constructor and a value inside there. Then we are going to be setting this dot value, and it's going to be now pointing to that value which we are going to be providing for the constructor. Next, we have to create our markers or the pointers, whatever you want to call that. So we are going to be setting the left and also the right to totally null. Okay, so we have to write this dot left, and we are going to be setting that to null, and we also have to write this dot right, and we will also set that to null. And that's everything that we have to do for the node. Next, we have to create our class for the BST. Okay, so BST like a binary search tree, and now inside there we are going to be passing our constructor, but we're not going to be passing any value to that, unlike a linked list, the stack and the queues. And we are going to be first of all creating our root, as you can see right here. But now initially we are going to be setting this root to totally null, because at this point we did not create any node, so we cannot set that or we cannot point there to anything. So we have to write this dot root, and we have to point there to null. So now let me just save my file and go back. First of all, I'm going to be creating a tree, so I'll just write like a tree. It's going to be now pointing to that new BST, like new binary search tree. And now let me just log that to the console, like tree, save my file and run there. So what are we getting? We are now getting this BST. We only have a root property inside there, and it is now initially pointing to nothing, as you can see right here. So that was it about for our node and also for our BST constructor. Okay, so time to create our own insert method. I already showed you the entire process a few seconds ago, like I put this one right here and so on and so forth. So if you want to pause this video and do that by yourself, so you are more than welcome to do that. Otherwise, here is my solution. So what I'm going to do is that I'm going to be using my insert method. Okay, so it's going to take some sort of a value, and we are going to be providing, or we are going to be creating our node, or we are going to be inserting our node based on that value. So the first thing that we have to do is that we have to even create something, then we would be able to insert that to this existing tree. Okay, so how that's going to look like? First of all, we have to write like new and then node, and we are going to be passing that value to this node. Next, we have to write like a new node. You can give it any name that you like, and now we successfully created that node. Next, we have to check if the root is empty, like if we don't have anything inside this root, and it is now totally set to null. Okay, as it is, which you can see right here, we already set that to null. Okay, so we have to check for that. If that's the case, so first of all, we have to create that node, and we have to point our root to that newly created node. So now let me show you what do I mean by that. So first of all, we are going to be checking if this dot root is triple equals to null, like if our root is now set to null. So we are going to be taking this dot root, and we have to point that to this newly created node, and finally we have to just return that so that we can see what we did. Okay, so what are we doing? As you can see right here, like this dot root is now equals to null, which it is now in our case. So what do we have to do? First of all, we have to point this dot root to this newly created node, as you can see right here. So now in this case, we would have just a null value. Now let me just remove that from here. We would only have a null value. Now we are creating a new node, so we are going to be removing this null, and we have to just create a new node just like that, and we are going to be pointing this dot root to this newly created element. Now the next thing that we have to do, if our node is not empty, like in this case, so what do we have to do in that case? We have to first of all create our marker or our pointer. So we are going to be creating a temp variable, and it's going to be pointing to that root. So now what are we doing? We are now creating a new temp pointer, and we are now pointing that to this newly created node. Next, we are going to be using the while loop, and we're going to be passing true inside there. Now why are we using the while loop, and why in the world are we even providing a true inside there? Well, the only reason for that is because we don't know that how many times we are going to be using this insert method and how many nodes we are going to be inserting to our node. So that's the only reason we're now providing the while loop, and we're now passing a true inside there. Okay, so first of all we have to provide our check. If new node dot value is triple equals to temp dot value, so what do you have to do in that case? Well, we just have to return undefined. First of all, let me just explain what do I mean by this statement. If new node dot value is equals to the temp value, let's suppose if I already have this element, and now if I wanted to add yet another add right here, like let's suppose if I want to add yet another add, so we cannot do that. That's going to be a duplicate value. So what do you have to do in that case? We just have to return undefined. Underneath there, we're going to be providing yet another if statement, and we're going to be passing if new node dot value is less than temp dot value. So what do you have to do in that case? Like as you can see right here, now we successfully created our node. Now is the time of that comparison that I was talking about earlier. We have to compare this newly created node value with this old one or this root one right here. If new node dot value, which is now set to add, is less than temp dot value, temp dot value, so is this less than add or is this greater than add? Well, we already know that add is greater than 5, and we already know that we are going to be putting that right here. But first of all, we also have to make another check. Is this area where we are going to be placing this node empty or not empty? Okay, so that's what we have to do right now. So we have to check if temp dot left is triple equals to null, if that area where we are about to store this newly created node is empty or not. So if it is empty, so we have to take temp dot left and we have to assign this new node value to that, and finally we just have to return this. And now let me just save that. Okay, so which means like we are now successfully taking this newly created node and we are now pointing there right here in this right area, just like that. And now what if that's not the case? So what do we have to do in that situation? So we have to take like temp and we have to set that to temp dot left. If this value is less than 5, so we're going to be taking this node and we have to point that right here. Well, that's not the case, so we have to put that right here for this case. That was our entire first if statement. Now we have to also write an else statement for that. So we are going to be using an else statement, and we have to do a nested check, like if temp dot right is triple equals to null. So what do we have to do in that case? We have to write like temp dot right, and we have to set that to this newly created node, and we have to just return this. That's going to be it. And finally, if that's not the case, we have to write like temp, and it's going to be now equals to temp dot right. And now let me just save my file, and that was it. Okay, so now let me just make this a bit bigger so you guys can see everything a bit better. Let me just go back. So if you get confused by this code, don't you worry, because I'm going to give you a lot of exercises. So what I'm going to do is that I'm going to insert a few elements or nodes to my tree. So I'm going to be using like tree.insert, and first of all I'm going to be inserting 5, then 8, then 3, 1, 7, and then finally 9. Okay, so now if I save my file, and now let me just run my code, and what are we getting? We are now getting our binary search tree, and now inside this tree we have our node, we have our root, which is now pointing to the node, and initially we are going to be passing the value of 5, as you can see right here on this diagram. So we are going to be passing the value of 5, and then we have a left and right values. If the value is less than 5, so we are going to be putting there right here on the left side. If the value is greater than 5, so we are going to be putting there right here on the right side. Okay, so that was it about this insert method on our tree. Okay, so time to create our next method, which will be the includes method. Okay, so basically it's going to allow us to search for a specific node in our entire tree. So what do I mean by that? Let's suppose if I want to search for a 7, so it's going to give us true if it found out the 7. Otherwise, it's going to give us false if we don't have a 7 inside our tree. So that's what we are going to be doing. But now let me just give you the instruction of how we are going to be doing that. Suppose we are now searching for the 7 in our entire tree. Okay, so first of all, we are going to be asking, or we are going to be making a comparison between the root and also the 7. Okay, so we are going to be providing a value of 7, and then we are going to be comparing them with the root. Okay, so is 7 less than 5 or is 7 greater than 5? So if 7 is less than 5, so we're going to be checking in this area right here. Now let me just highlight this. We're going to be checking our item in this area only. But if our 7 is greater than 5, so we are going to be checking in this specific area right here. Okay, so now that we already know that 7 is greater than 5, so which means like we are going to be checking in this area. Okay, so 7 is greater than 5, so which means like, yeah, we have to go in this route. Then we have to check, is 7 greater than 8 or is 7 less than 8? We already know that 7 is less than 8, so we have to go a bit down, and here we have it. Okay, so here is our 7 value right here. Now let me just change that to like, I don't know, maybe 1. So we are going to be making a comparison like, is 1 greater than 5 or is 1 less than 5? Well, we already know that 1 is less than 5, so we're going to be checking in this area right here. Okay, so 1 is less than 5, so which means like we have to check out for this one. Are you the one? No, I'm not. I'm not the one. So we have to make a comparison one more time. So like, is 1 greater than 3 or is 1 less than 3? Well, 1 is less than 3, so we have to go a bit down, and here we have our 1 right here, and we are going to be creating an includes method, and it's going to be taking some sort of a value, and based on that value we are going to be searching for that specific item. Okay, so the first thing that we have to do is that we have to make a comparison, like if not this dot root, so what do we have to do in that case? We have to just return false. Like if we don't have anything inside our tree, so we cannot search for anything. Like let me just give you an example of that. If we don't have anything, so how in the world we are going to be searching for something inside this empty tree? So this is what this if statement means. Now underneath that, we have to create our temp variable. So we are going to be creating like temp variable, and we have to point there to this dot root. So we are going to be creating another variable or pointer, whatever you want to call that. I'm going to give it the name of like temp, and we are going to be pointing this temp variable to this first node right here, to this root. And what is a root? A root is this first node. Okay, so that's exactly what we are doing right now. Next we have to provide our while temp, and then we have to check out. So if we have the temp, so we are going to be searching for our items. But if you don't have the temp, so well, you get the idea. Okay, so now inside there, what do we have to do? We have to search if the value which we are now searching for, like that specific thing which we are searching for, is less than temp.value. Okay, so what do we have to do in that situation? Well, we have to just write like temp is equals to temp.left. Now the thing we are searching for is less than temp.value, so we have to set the temp to the temp.left. So what do I mean by all of this gibberish which I just said? We are now searching for this value right here. Like let's suppose if I'm searching for 7, I'm gonna just write like 7, and we have to make a comparison between both of them. Like, is 7 greater than 5 or is 7 less than 5? Well, 7 is greater than 5. Okay, so here you can see we are now writing a less than 5. You know, let me just change that to maybe 3. Okay, so 3 is now less than 5, so we have to make our comparison right here in this area. Okay, so now we have to take out this temp, and we have to put that right here at the bottom. And now this temp is pointing to this 3, so which means like we're now going to be getting this result right here. So we are now taking this temp variable which used to be pointing to the root, now it is pointing to this third node right here, just like that. And what if that's not the case? We are going to be providing like else if and value is greater than temp dot value. So what do we have to do in that situation? We have to take out the temp, and we have to assign that to the temp dot right value inside there. Okay, so now let me just save my file. So what in the world are we doing? Now the value which you are searching for is greater than temp.value. If that's the case, so we have to set out the temp to the temp.right. Let's suppose if I want to search for a 7, so what do you have to do? First of all, we are now making this comparison like, is 7 greater than 5 or is 7 less than 5? So we already know that 7 is greater than 5. So we are going to be taking this temp which used to be pointing to this root. So we are now taking that, and we are going to be searching for that specific element inside this area right here, like temp.right. Like now this temp is pointing to this root, so we are going to be checking our element inside to the right of this node, which means like we already compared 7 and 5, so we have to take out this temp and we have to point there to this 8. Then we are going to be comparing this 7 and 8. So is 7 greater than or less than 8? Well, 7 is less than 8, so we have to take out this temp and we have to put that right here, and there we go. Here we have our 7 node. So it's going to give us true value, and if that's not the case, like else if the value is triple equals to the temp dot value, so what do we have to do in that situation? We have to just return true. And if that's not the case, so underneath there, underneath this one, we are going to be just returning false. So now we'll just write like return false, and I'm gonna cut that from here, and now let me just put that right here. So now let me just save that. Let me go back, and this is the entire code that we have to write for the includes method. I'm gonna go to the bottom, and here I'm gonna just search for the tree dot includes method, and I'm gonna be providing, like, let's suppose if I want to search for this one, so I'll just pass like this one right here. And do I have to store it in the console log? Now let me just put that in the console log. Yeah, I guess that's gonna work. So I'm gonna comment this line out and save my file and run there. So what are we getting? We are now getting true right here, because it found out that this one is now inside our tree. But let's suppose if I search for like 100, so it's gonna give us like false. If I search for 100, and now let me just save my file and run there, so it's going to give us the value of false. Let's talk about recursion. So what is recursion and why should you even care about that? So recursion is when a function calls itself, but it doesn't call itself exactly the same way each time. So now you might be asking, like, HuXn, what in the world is this recursion even mean, and why should I even care about that? Well, you have to care about recursion because we are going to be learning about something called the tree traversal, and we are going to be also using a recursion in the upcoming algorithm, which we are going to be creating very soon. So yeah, that's just the actual definition of what a recursion is. And now let me just show you that in the actual diagrams. And here is the diagram. So I want you to imagine that you have some sort of a Russian nesting doll, or you can say this actual name which I can't pronounce. That's the only reason I provided this definition, like a Russian nesting doll. So I'm gonna just remove that from here. And basically this is some kind of a doll which will be initially wrapped with some kind of a box, and once we open that box we have a doll. Once we open that doll we have another doll. Once we open that one we have another one, and so on and so forth. As soon as we didn't reach to this point, we are going to be opening this doll again and again and again. So now you might be asking, like, HuXn, yeah, we know this kind of a doll, but now the question is, what is recursion in this entire process? And recursion play these roles right here. Now let me just bring that right here. Let's talk about the first one. The function makes the problem smaller by changing the input a bit, like opening a smaller doll inside the bigger one. Like once we open this doll and we found out another doll inside there, so that's going to be the first point in the recursion process. Now the next point we have is, like, there is a simple case which we call a base case, and that function can be solved without calling itself again, and this is something called the base case. You don't have to worry about what a base case is, but you can think about that is that we are going to be calling this function again and again as soon as we find out the last one, like the last element inside this doll, or the last doll inside these Russian nesting dolls. Okay, and as long as it's not the base case, the function will call itself with the smaller problem. So I don't know if that was a good or maybe the most horrible definition of a recursion, but now let me just write some code and then you will get to know what I'm talking about. Let me give you the example of a recursive function in JavaScript. So basically we're going to be creating a function. You can give it any name that you like, but in my case I'm going to call it as a countdown, because we are going to be creating a function which will do the countdown. So how that's going to look like, so basically if I just provide like 5, so it's going to decrement 1 each time this function calls. So it's going to give us first of all 4, then 3, then 2, and finally 1. And once it reaches to the 0, we are going to stop executing this function. So how that's going to look like, well, you can use the for loop, you can use the while loop. There are a lot of methods that you can do, but in my case I'm going to be using a recursion. So I'm going to just pass this function once again. So I'll just write like countdown, and I'm going to just decrement, or you can say -1 from that function. Okay, so now if I save my file, this will totally work, but it will give us something called the infinite loop, because this function will run again and again, and it's going to give us something called the stack overflow, which we don't want. So how we can prevent that from happening? We can prevent that from happening by providing a base case. So a base case is basically that point. Once our function reaches to that point, so we can stop the execution of our function. So we can just say like number triple equals to 0. So if we hit the 0 number, so we can just totally return. You can also provide some message if you wanted to. So I'll just write like, and finally the stopping point. There we go. and I'm going to also paste this emoji right here, and this is how we are going to be creating our first recursive function. So if I log that to the console like my number, so it's going to show me all of that number again and again. So now let me just call that right here, and I'm going to just pass 5 inside there. So if I save my file, let me just go back, and now if I run my code, so what are we getting? We are now getting 5 4 3 2 1 right here, and once we reach to the 0, so we are now getting and finally the stopping point. Okay, so this is how we are going to be creating our recursion function, and this is how we are going to be providing a base case. Like once you reach to that point, you gotta stop execution, like you have to provide there. If I don't provide there, let me just comment this line out, and now if I save my file, and now let me just run there, and here you can see this function will run again and again, and it's not going to give me anything in this case, but yeah, you get the idea. So that was example number 1. Now let me just remove that, and now let me give you example number 2, which is something called the factorial. So if you are coming from the mathematics background, so you already know what a factorial is, but if you don't, you don't have to worry about that. So basically, if you want to find out the factorial of like 4, and by the way, factorial looks something like this. Let's suppose if you want to find out the factorial of 5, and we have to provide the exclamation mark right here. Now let me just zoom in a bit. So this is something called the factorial of 5. So essentially it's going to give us 5 times 4 times 3 times 2, and then finally times 1 right here. So if you wanted to create a function for that, we can totally do that by using either a for loop and while loop, or you can also use a recursive method. So we are going to be using a recursive method because we don't want to use a for loops and while loops. We are now working with a DSA. So let's just write a factorial. The name doesn't matter. And first of all, I'm going to just return when the numbers time, and then we are going to be passing that same function once again, and we are going to be also decrementing there by 1, something which we just saw a few seconds ago. Okay, so we are now just multiplying there with that number which we are going to be specifying right here as a parameter. Okay, so now let me just save my file, and once again, we did not specify any base point for that, so this function will run again and again. So now to provide a base point for that, so we can totally do that by just writing like if number triple equals to 0, so we just want to return 1 right here, that situation. Okay, so now let me just log that to the console. I'm going to write like factorial, not favorite data, but factorial of 4, or I'm going to specify 5 right here. And now if I save my file and run my code, and here you can see it's going to give me the result of 120. So that's the factorial of 5. But if you want to check out the factorial of 4, so I'm going to just write 4, and now let me just run my code. So we are now getting 24 right here, and that's totally amazing. But we can also refactor this code to just a simpler version. So I'm going to remove that from here. I can totally write like that same formula in one line by just providing like number triple equals to 0. If that's the case, so we can use the ternary operator, so it just gives us 1. And if that's not the case, so then gives us like numbers and that same formula which we just used. So factorial, and then we have to decrement 1 from there. And now if I save my file, so this will totally work. If I run my code, and still here you can see we are now getting the result of 24 right here once again. And we can even more refactor there by just using like const and making an arrow function if you wanted to. So we can totally remove the return keyword and so on and so forth. And this is our factorial function, or a recursive factorial function looks like right now. So if I run my code, and still we are now getting 24 right here. So yeah, that was it about the recursion. And next we are going to be learning about the tree traversal. Alright guys, so now we are totally done with how we are going to be creating the tree and also the recursion part, and now it's time to learn about something called the tree traversal. So what do I mean by a tree traversal? Basically, a tree traversal just simply means that we are going to be accessing each item inside the tree, and we are going to be storing that in some sort of array. Okay, so how we are going to be doing that? There are a lot of ways we can do that. Like we are going to be also learning about the BFS, and also the in order and post order and something like that, which we are going to be learning very soon. They are coming. But first of all, let's talk about the first one, which is called the BFS, or you can say the breadth first search. So how that's going to look like? Well, we are going to be first of all starting from the root, and we are going to be providing that node to our queue. So we are going to be creating our own queue, not our own queue, but we are going to be working with array. Okay, so yeah, we are going to be taking our item from our tree, which will be the first item, or you can say the root, and we are going to be placing that in that queue. The next thing that we have to do is that we have to take this data from this queue, and we have to pass that right here inside our data array. So we are going to be providing the entire node to our queue, and we are going to be only taking the data from that node, and we are going to be passing that to this data array. Now the next thing that we have to do is that we have to search for the left and also for the right. And why is that? Because we are now providing this entire node, which you can see right here. So it has the pointer of the left and also to the right. So next we are going to be searching this third and fourth element. Okay, so now we successfully added this element right here, as you can see. So we can totally remove that from our queue. So now we successfully removed that. So the third thing that we have to do is that we have to take this third and also this add element, and we have to take that and we have to put that right here inside this queue. So once we do that, the next thing that we have to do is that we have to just take the data of that, like this 3. So I'm gonna just write that 3 right here. Oh, that's super big. So now let me provide a comma, and I'm gonna also provide this 3 right here, and I'm gonna also provide this 8 right here in this case. Okay, so now we are not totally done yet. We now successfully added this 5 and also this 3 and also this 8. But now it's time to check the left and also the right pointer of this third node. Okay, so we're going to be taking that, and now let me just highlight this area because now we're going to be working with this area. Okay, so we're going to be checking, like, is there something to the left of this node? Yeah, there is. So we're going to be taking this one and we are going to be putting there, but first of all we have to remove them from here. So we have to remove them, then we are going to be taking this one and we are going to be placing there right here. And then we are going to be taking this one value from there. I'm going to just remove that from here, and we are going to be passing that right here inside our data. So now this area is totally done. Now let me just highlight that. This area is now totally done. Now the next thing that we have to do is that we have to take care of this area. Now we have to go ahead and go to this add because we already added this add right here. Is there something to the left of this node, and also is there something to the right of this node? Yeah, there is. So we are going to be taking that, but first of all we have to remove that right here because we already added that inside our array. So we have to take this left value and also this right value, and we have to put that inside our queue. So now once we do that, the final thing that we have to do is that we have to just take the value from there. So we are going to be taking the value of 7, and we are going to be also providing this 9 right here. And now we are totally done with this first tree traversal, but we also have to remove these nodes from here. So this is how we are going to be iterating over through each node inside our tree, and this is how we are going to be getting a data from there, and this is how we are going to be storing that in our data array. And this is something called the breadth first search, or you can say the BFS, or the breadth first search. So now let's write a code for that. Time to create our own BFS, or you can say the breadth first search. Okay, so it's not going to take any parameter or anything like that. Now inside there, the first thing that we have to do is that we have to get the current value. So how that's going to look like, first of all we have to set that to the root. So we are going to be accessing our root right here by using this dot root, and we have to store that in the current variable just like that. So now that's done. The next thing that we have to do is that we have to create this queue and also this data right here. Okay, so we are going to be just writing like queue, and it's going to be now set to this empty array, and we are going to be also creating our data, and we are going to be also setting that to the empty array just like that. Now the first thing that we have to do is that we have to take this root value, and we have to take that and we have to put that right here inside this queue, this entire node I'm talking about, not just only the value. So we are going to be using like queue.push method, and we are going to be passing this current value inside there. The next thing that we have to do is that we have to iterate over through each element inside our node. So to do that, we can either use the for loop or we can also use the while loop. So in my case, I'm going to be using the while loop because in this case, I don't know how many elements I would have inside my tree. So I'm going to just write like queue.length. So as long as I have something inside this tree, so we are going to be iterating over through there. So once my tree length is set to either 0 or no, so then we're going to be stop iterating over through this tree. So now that's done. We now successfully added this element to our queue. So now we have to remove that. So how we are going to be doing that? Well, we just have to write current, and we have to use our queue.shift method. So it's going to remove the first element from our queue. Okay, so we are going to be using data.push, and then we're going to be adding this current node, and we're going to be passing the value of that. So what are we doing? We are now first of all taking this value, and we are now placing that inside our data, which you can see right here. current dot value, and we are now pushing there to this data right here, as you can see right here. So we are going to be taking this 5 and we are going to be pushing there to this data, and we are going to be removing this one from our queue, just like that. As you can see, we are now removing that from our list, or you can see the tree. Why am I saying the list? Now the next thing that we have to do is that we have to search for the left and also for the right pointers. So how that's going to look like, we're going to be using current.left. So if there is something to the left, so what do we have to do in that situation? Well, we have to write our queue.push method, and we're going to be pushing our current.left. Okay, so basically we are now searching, we are now iterating over through this entire tree. If there is something to the left of this node, we have to take that data and we have to push that to our queue. But if there is nothing there, so we have to also search for the right value, which we are going to be doing in a few seconds. Okay, so now this step is totally done. The next thing that we have to do is that we also have to search for the right value. So we are going to be using like current.right, and if there is something to the right, so we are going to be taking that value and we are going to be pushing that to, come on, current.right, and we are going to be pushing that to our queue. Okay, so if there is something to the left, we are going to be taking that and we are going to be pushing that to the queue. If there is something to the right, we are going to be also taking that and we are going to be pushing that to our queue. But if there is nothing there either to the left or to the right, so we can totally just ignore that. So yeah, now that's done. And the final thing that we have to do is that we have to return our data so that we can see what's happening right now. So if I just use like return data, and yeah, that's gonna be it for our entire BFS. So it's gonna iterate over through each element, and it's gonna just first of all remove the first element, which we already provided right here for the root. It's gonna take the value of that and it's gonna put that inside our data. Then it's gonna search for that specific node left value. If there is something to the left, so it's gonna add that to the queue, and if there is something to the right, so it's gonna add that to the right of our queue. I mean, like, it's gonna add that to the queue. And finally we are now just returning our data, and now let's use that right here. So I'm going to be using console.log of tree.bfs, and now let me just execute that. I'm going to save my file and run that, and here you can see, first of all, it's going to give us 5, then it's going to give us 3, 8, 1, 7 and 9, and here you can see 5, 3, 8, 1, 7 and 9. 5, you know, let me just copy that. Why am I reading that right now? So now let me just place that. So here you can see we have 5, 3, 8, 1, 7, 9, as I explained a few seconds ago. So yeah, that was our breadth first search. Let's talk about the DFS, and especially the pre-order DFS. We're going to be also learning about the in order and also the post order, but now let's talk about the pre-order DFS. And what do I mean by a DFS? Depth first search. We already learned about the breadth first search, and now it's time to learn about the depth first search. So how that's gonna look like, and it's gonna look something like this. First of all, initially we're going to be starting from the root, and we're going to be pushing this root to our array, and then we're going to be asking, is there something to the left or to the right of this node? Yeah, there is something to the left and also to the right. So we are only interested in this area right here. Okay, so we're going to be taking our marker and we're now going to be pointing there to the second node. Okay, so it's gonna take this data and it's gonna also store that in that array. So you know what, let me just highlight that for you. So first of all, we are going to be creating this array, and now inside this array, first of all, we are going to be providing this 5 because that's going to be the root node. So we are going to be attaching that right here inside our array. And next we have to search for the left area, and now inside this left area we have a 3 right here. So we are going to be taking that 3 and we are going to be adding that to our array. We also have to search for the left and right of this third node. Okay, so we have something to the left, but we don't have anything to the right. So we are going to be taking this one and we are going to be also storing that right here inside this array. And then we are going to be jumping back. So there is nothing right here to the right, and we already stored this one right here. So first of all, we are going to be jumping into this 3, and then we are going to be jumping into this 5, and then we are going to be checking the right area right here. Now this area is totally done. Now we are going to be asking the question like, is there something to the right of this node? Yeah, there is. So which is the 8. So we are going to be taking that 8 and we are going to be storing that inside our array. Okay, and then we are going to be also asking that same question like, is there something to the left and to the right? Yeah, there is also something to the left and also to the right. So we are going to be first of all taking the left value, which is the 7. So we are going to be adding that right here. So first of all, let's just add the 7, and then once we successfully added this 7, we are going to be jumping back to this 8 right here, and then we are going to be jumping down to this 9, or you can say to the right of this node. So then we are going to be just writing like 8, and yeah, this is what we call the DFS pre-order. And I realized that I made a mistake. Instead of providing a 9, I provided right here 8 once again. So now let me just change that to the 9, and this is how we are going to be working with the DFS pre-order. So now let me just write a code for that, and then you will get to know what I'm talking about. I'm going to create a new method. I will give it the name of like DFS pre-order. You can give it any name that you like. And first of all, we are going to be creating our node, and I will just provide a perimeter of node to them, and initial value will be set to this dot root, and also we are going to be setting the data to this empty array initially. And now first of all, we have to check if there is no node, like if the node value is set to null. So in that case, we are going to be only returning the data which is now initially set to empty object, I mean like empty array. So that's the first thing. Now the next thing that we have to do is that we have to take our data and we have to push the node value to there. So like we have to take this root data and we have to push the value of there right here inside our array. So that's the first thing. Now the next thing that we have to do is that we have to check for the left and for the right values. So we can check like if there is something to the left of this node. So what do we have to do? We have to do the recursion. Like we have to call this method inside itself. Like we are going to be calling this method right here once again. So now we have to write like this dot DFS and then pre-order right here. We have to call this function and we have to provide the left value to there, and we're going to be also passing the data inside there. So this is our base case. Like once our node is set to null, so we only have to return the data and nothing else than there. So here you can see we're now checking if there is something to the left. So we have to call this function or this method inside itself. We have to first of all pass the pointer, like what in the world is this node pointing to. So it used to be pointing to the 5, now it is pointing to the 3. So this is how we are going to be passing that pointer, and we are going to be also taking the data of there and we are going to be storing that inside our array, as you can see right here. So now the value will be 3. So we are now taking that data and we are now pushing that to this empty array. Okay, so that's going to be the first thing. And we also have to check for the right value. So if there is something to the node dot right, so what do we have to do in that case? We have to once again call this method, or you can say we have to recursively call this method. Okay, and we are going to be passing the pointer which will be now set to node dot right, and we also have to provide the data inside there. And finally we have to just return what we did. Okay, so I'm going to save my file, and that's all the thing that you have to do. Yeah, this is going to be our base case. This is how we are going to be pushing our new element every time this method is called. And also we are going to be checking if there is something to the left. So we are going to be providing the pointer and also that data to that specific array which you can see right here. And we are going to be also checking for the right if there is something to the right. So we are going to be calling this method recursively once again. We are going to be passing the pointer and also the data to there. So you know what, let me just run this code and then you will get to know what I'm talking about. So instead of writing this BFS, I'm gonna console.log this tree.bfs pre-order, and I'm gonna save my file and run there. And here you can see that result will be exactly the same like this one. So I'm gonna copy there, and now let me just place it right here. So we have 5, 3, 1, 8, 7, and 9. And now let me show you there in the debugger. You don't have to do that, but I want to do that. Okay, so if I log that to the console, so what I'm going to do is that I'm going to just write a separator right here, and I'll just write this data, and I'm going to save my file. And now let me show you how our data will look like. So if I run my code, you know what, let me just clear this out. And now let me run my code. So initially my array will be now set to empty array. Then we are going to be passing this 5th element, which is going to be the root element. Then we are going to be checking for the left value. You know what, let me just zoom in a bit. We're going to be checking for the left value. So if there is something to the left, so we are going to be adding there right here inside our array. And then we are going to be also checking it once again, like if there is something to the left or to the right. So now in this case we only have this one right here, we don't have nothing inside to the right, so that's why we are now only getting this one. Then it will jump to this 3, it will also jump to this 5, and then it's gonna start working or start searching for this right value. So is there something to the right of this 5? Yeah, there is, as you can see right here, which is the 8. So we're going to be taking there and we have to put that right here. Then it's going to check if there is something to the left. Yeah, there is, which is the 7. So we're going to be also storing that right here. Then we will go back to this array, and then we're going to be searching for the last element. Is there something to the right? Yeah, there is something to the right, which is 9, and we're now adding there right here. So that was the basic, but you don't have to do this step. And if you don't want to watch the rest of this DFS pre-order, you can totally skip that. But I'm going to show you that in the debugger. Okay, so I'm not going to show you this area, but I'm going to have to provide my pointer right here. And now let me just run the debugger. And this is how it will look like right here in the debugger. So you don't have to focus on anything. You only have to focus on this data right here. So first of all, once our code starts, so the initial value will be set to empty array, and we have the node of 5, and then for the left value we have a value of 3, and then we also have the left value once again of 1, as you can see right here. So we have 5, 3 and 1, and then also we have the right value, which will be now first of all set to the add, and you can see right here that is now set to the add. And for the left we have a 7. So as you can see right here, we have the value of 7 for the left, and for the right we have a 9 value, as you can see right here. And this is how it's going to look like initially. So now if I run through there once, it's going to push that 5 to this data array right here. So that's the first thing. Okay, then we have to just run through there. I'm going to just fast forward. So it's going to go to the second pointer, and then it's going to take the value of there, and it's going to put there right here inside this 5. Let me just run there once again. And it's going to take the value of 1, and it's going to also add there inside that array. And then let me just run there for a few more times. So it's going to take the value of 3. As I said, like it's going to go back. Once we added this one, then it's going to go back to the 3. Then it's going to also go back to the 5. It is now set to the 3. It's going to also go back to that 5 right here. And let me just run there one more time. So here you can see it's going to go back to the 5, and now this area is totally done. So it's going to go to the right of that value. So if I run through there, and let me just run there once again, here you can see the value is now set to 8, and now it's going to take that value and it's going to store the inside our data variable, just like that. And so on and so forth. You get the idea. I don't want to waste your time anymore. If you want to test that out, so you just have to hit F5, and it's going to start this debugger for you. And let me just stop executing. So I'm going to just click on there, and you get the idea of BFS pre-order. Now we just learned about the pre-order. Now it's time to learn about the post-order. So what do I mean by the post-order? It will look exactly the same like the pre-order, but the only change will be once we are inserting the data to the array. So what do I mean by all of that gibberish which I just said? So first of all, we are going to be starting our search from this initial value, which is 5, but we are not, let me just say that once again, we are not going to be adding the value of this 5 inside our array. So you know what, let me just build the array right here so you guys can see what I'm doing. So just like that, we are going to be starting our search from this 5, but we are not going to be storing the value of there. Then we are going to be taking that pointer, and we also have to search for the left area, and then we have to search for, like, is there something to the left or to the right? Yeah, there is something to the left, but there is nothing to the right. So we have to take that pointer, and once again we are not storing the value. We have to take that pointer and we have to point there to this last node, and then we're going to be asking that same question, like, is there something to the left or is there something to the right? There is nothing to the left and there is nothing to the right, so which means like this is a leaf node. Now we are going to be taking the value of this leaf node, and we are going to be storing there inside this one right here. I mean, like inside this array. What am I saying today? I don't know. So now that's totally done. The next thing that we have to do is that we have to go back and we have to take the value of this 3 and we have to store that right here inside our array, just like that. And once we go to the top one more time, like to this root one more time, we are not going to be storing the value of this one. Now this area is totally done. The next thing that we have to do is that we have to search for this area right here. Now this part is left. We are not going to be storing the value of 5, so we are not going to be storing the value of this add. Instead, we are going to be asking this question, like, is there something to the left or to the right? Yeah, there is something to the left and also to the right. So let's just go to the left area. And then finally, once we reach to this point, we're going to be asking this question, like, once again, is there something to the left or to the right? No, there is nothing to the left and nothing to the right. So which means like this is a leaf node or the final node. So we are going to be taking the value of this one, and then we are going to be storing the inside our array, just like that. And now once we edit the value of this 7, we are going to be jumping back to our add, and then we are going to be searching like this area is totally done. We have to search the right, like is there something to the right? Yeah, there is the 9th node right here. So we are going to be pointing to this 9th node. You know what, let me just highlight there for you. And now we totally done this area. Now we are going to be jumping into this 9th node, and then we are going to be asking that same question, is there something to the left or to the right of this 9th node? No, there is nothing to the left and nothing to the right of this 9th node, so which means like this is a leaf node. So we are going to be taking the value of that 9 and we have to store that in our array. Okay, and now we are going to be going back. Now this area is totally done. We are going to be going back and we are going to be taking the value of this add, and now we have to go back for the final time for this root, and we have to pass the value of this root. Okay, just like that. Let me just say that once again. The main difference between the pre-order and the post-order is that once we were working with the pre-order, we started to add every single element that we retrieve to our array, but in the post-order that's not going to be the case. So first of all, we're going to be searching for this item, but if we found the last element or the leaf node, we are going to be taking the value of that leaf node and we are going to be storing that into this array. Okay, so then we are going to be jumping back and we are going to be storing the value of this one. We are not going to be storing the value of that one. We are going to be searching for the right, and then we are going to be adding 7, then 9, then 8, and then 5. Ooh, that was a lot of explanation. So now let me just write some code and then you will get to know what I'm talking about. I lied. I'm not going to be writing any code. I'm going to be copying and placing that. So now let me just comment this line out and the code will be exactly the same, but we only have to change one line. Okay, just the order of one line. So I'm going to just rename that to like DFS post order. And now inside there, we're going to be taking this push method, and then I'm gonna cut that from here and we're going to be adding there right here at the end. And you know what, we don't need that from here, so now let's just remove that. Okay, so first of all, we're going to be providing our base case. You already get the idea of that as I explained a few seconds ago, so I'm not going to explain every single thing once again like for the second time, but yeah, you get the idea. So we're going to be taking that, pushing that item, and we're going to be placing that at the end. So which means like if we found the leaf node, then we're going to be taking the value of that and we're going to be pushing that to our array. So you know what, let me just run that. Keep this code in mind. So we're going to be only taking this line of code which used to be here. We're now taking that and we're now placing that right here. So I'm going to save this file and now let me just run that right here. So that was the pre-order, and you know what, I realized that I made a mistake. I have to also change this DFS pre-order to this post-order. So I'm gonna copy that and now let me just place it right here. I'm gonna also place this one right here, save my file, and now it's gonna give us the correct result. So I'm gonna run my code and here you can see we are now getting that exactly the same result. So I'm going to just place that right here. We're now getting 137985, which is exactly the correct result. And if you want to pause this video and if you want to hit the F5 and run this debugger by yourself, you can totally do that if you wanted to, but I'm not going to because I already explained this pre-order in a very great detail, so I think it's gonna just waste your time. Let's talk about the final one, which is called the depth first search in order. So how that's gonna look like, and it's gonna look something like this. First of all, we will start our traversal from the root. Okay, so we are not going to be adding the 5th one, but we are going to be jumping into this next one, which is the 3rd. We're not going to be adding this one. We will jump into this last one, and as you can see right here, there is nothing to the left and nothing to the right. So what we will do is that we will just first of all create our array, and we're going to be storing the value of 1. Then we will jump to this 3rd one. We will also store the value of 3rd one, but now in the in order we will jump to this one and we will also store the value of this root right here. Okay, so I'm gonna also store that right here. Now this area is totally done. The next thing that we have to do is that we have to search for this right area. So we are not going to be storing the value of this add. Let me just put my pointer right here. We're not going to be storing the value of this add. We will jump into the left of this add, and then we will take this value. As you can see right here, like there is nothing to the left and nothing to the right, so that's why we are now going to be taking the value of this 7. We will also add there, and then we will jump back to this add right here, and we will also take the value of this add. Now we will add there, and finally we will also search for the right, and for the right we only have the 9th element right here, so we will also take the value of that 9 and we have to put that right here. And this is how we are going to be working with the in order. So I'm not, like, once again, I'm not gonna write any code. I'm gonna duplicate this code right here. I'm gonna collapse that one, and now let me just show you what we have to do right now. So we have to change only a few things. First of all, we have to change the name of these three. So I'm gonna just change the name of that to like DFS in order. And now the next thing that we have to do is that we have to take this data.push, we have to cut that from here, and we have to put that right here in that area. Okay, so we only have to take this data and we have to put that at the middle of this left and also to this right. So now if I I'm gonna have to copy there, and now let me just comment this line out, and I'm going to be using console.log3.dfs in order, and now I'm going to execute that. And now let me just run my code, and here you can see we are now getting that exactly the same result. Let me just place that right here so we can see is everything okay or not. And yeah, that is okay. So we are now getting 1 3 5 7 and 8, I mean like 1 3 5 7 8 and 9, and yeah, this is what we are doing right now. So thank you so much for watching this long video, but I hope it was worth it. And if you enjoyed this video, feel free to go ahead and comment and like and share, subscribe, do whatever you want to do. Thank you so much. Again, Hussein, and welcome to the Data Structures and Algorithm Masterclass. So in this video, we are going to be learning about the graphs from scratch. So what is a graph and why you should care about that? So a graph is a non-linear data structure that models a relationship between the objects. So it consists of two components, which is called the vertices, or you can also call it like a nodes, and also the edges. So if you don't get this definition, you don't have to worry about that, because in this course I'm going to be teaching you every single thing that there is to learn about the graphs. So now let's talk about that vertices, or you can say the nodes, and also the edges. So vertices or nodes, these represent the individual component within a graph. On the other hand, we have edges. So these are just a connection between two vertices or more than two vertices. These connect vertices, signifying a relationship or connect between them. That's it. So there are a couple of ways where we can store our graph. The first one is called the adjacency matrix, and the second one is called the adjacency list. So throughout the course, we're going to be using this adjacency list, but I'm going to also show you how we are going to be working with the adjacency matrix. So now let's talk about the adjacency matrix right now. Okay, so if you want to store the data of this graph inside our adjacency matrix, the first thing that we have to ask ourselves is that what are the connection of each node with other nodes. So basically these stuff are called the vertices, or you can also call them the nodes, and this is something called the edges. Okay, so as I explained a few seconds ago, but I want to just make sure. So with who this A is connected with, this A is connected with this E, and A is also connected with this B, but A is not connected with the D. A is also not connected with the C. A is only connected with the E and also the B. So what do we have to do? So you can store like zeros and ones if you wanted to, but in my case I'm going to just use like cross and check just for this diagram purposes. So let's talk about the first one, which is the A. So A is not connected with the A, so that's going to be the cross. A is connected with the B, so we're going to be taking that check mark and we're going to be placing that right here. Next we have A is connected to C. No, A is only connected with the E and also with the B. A is not connected with the C, so we're going to be taking this cross and we will just put that right here. Next we have like A connected with the D. No, A is not connected with the D, so we're going to be grabbing there and we have to put this cross right here. Next we have like A is connected to the E. Yeah, this A is connected with this E, so we are going to be taking this check mark and now we have to place it right here. I don't want to waste a lot of your time on this graph, but now let me just show you this second one, and you can do the rest of them by yourself, and I'm going to also show you the complete graph. Okay, so now let's talk about this B. B is only connected with the A, and B is also connected with the C. B is not connected with the D. B is also not connected with the E. B is only connected with A and also the C. B is connected with A, so we're going to be taking this check mark and we have to put that right here. So B is not connected with itself, like B is not connected with B, so we're going to be taking this cross and we have to put that right here. And next we have like B is connected with C. yeah, B is connected with C, so we're going to be taking this check mark and we have to put that right here. And also B is not connected with anything else, so we can just take this class and we can just put that right in here. So yeah, I don't want to waste your time, so now let me just show you the complete diagram of that. And here is the complete diagram, so you can pause the video and see all of these connections by yourself. But if you don't want to do that, you don't have to do that. Okay, so that was the adjacency matrix, and now let's talk about the adjacency list. Okay, so it will look something like this. So we are going to be taking our connection and we are going to be storing the inside our object, and now inside this object we're going to be providing the property and then that connection. So these are something called the vertices or nodes, and these are called the connections, or you can say the edges, whatever you want to call that. Now let me explain the connections between there. So A is connected with E and also with B. So A, you know, let me just highlight there. A is connected with B and also with E. Okay, now the next one we have is a B is only connected with A and also the C. So here you can see we have B connected with A and also the C. Now the next one we have is a C. So C is connected with B and also with D. So here you can see we are now connecting this C with B and D. And now the next one we have is a D. D is only connected with C and also with E. So here you can see D is now connected with C and also with E. And the final one we have is a E, and E is now connected with D and also with A. So here you can see we're now placing this E and we're now connecting that with the A and D. So yeah, that was just a basic theory of the adjacency matrix, and that was the adjacency list. And now let's get into the coding part. Alright, so now let's get into the coding part. So how we are going to be creating our graph? Well, to do that we are going to be using a class and we have to write a graph. You can give it any name that you like. The name is totally on you. Now inside this graph we are going to be defining our constructor, and now inside this constructor we are going to be only using like this dot adjacency list, and it's going to be now pointing to this empty object. So this is how we are going to be defining our graph. And now let me just create an instance of this. So I'm going to go back. Now I'll just use like graph, or you know, I'm gonna just give it the name of like G. It's gonna be now equals to this new graph. So if I just execute that, if I log that to the console like this G, I'm gonna save my file and run there. And here you can see we have our graph, and now inside this graph we only have this adjacency list, which is now pointing to this empty object. Now that we successfully created our graph, the next thing that we have to do is that we have to define our vertex, or you can say that we have to define this property, and then we are going to be storing the connection for this property. And by the way, you are not just limited to provide one property, you can provide more than one, like A, B, or you can give it any name that you like. You can provide like 1, 2, you can provide like apple and mango and something like that. And initially we are not going to be storing any edges inside there. For that we are going to be creating a separate method, but for now let's just take care of this, creating the property and providing the empty object to there. So how we are going to be doing that? And to do that we are going to be defining a new method. I'm going to give it the name of like add vertex, and now inside there we are going to be providing the VTX like for our vertex. And based on that, first of all we have to check for the duplicate values. So if we don't have this dot adjacency list, and then we are going to be passing this vertex inside there, so it's going to check for the duplicate value. So if this is already defined, so we are going to be only returning the false. So now let me just return that false right here. But if that's not defined, so the next thing that we have to do is that we have to create that. So we are going to be just using like this dot adjacency list. We are going to be accessing there right here, which we have already defined up above, and we are going to be passing that perimeter right here. Okay, so I'll just write like VTX, and we will set there to this empty array just like that. And now underneath there we are going to be also returning the true. So this is how we are going to be defining, or this is how we are going to be adding our vertex right here for our graph. So I'll just remove that from here. I'm gonna write like g dot add vertex. So I'll just give it the name of like A. I'm gonna also create another one for the B and yet another one for the C. So now if I log that to the console like console.log, I'm gonna save this file, and now if I run my code, so what are we getting? We are now getting our graph, and now inside this graph we have our adjacency list. Now we are providing the value for the property of A, and it is now initially set to this empty object because these are something called the connections, which we are going to be doing in a few seconds. But first of all we wanted to take care of this vertex, or you can say the vertices. So now we take care of that. Now the next thing that we have to do is that we have to define our own edges, or you can say the connections. Let's talk about how we are going to be creating our own edges. So for that we are going to be defining yet another method, and it's gonna allows us to connect these two or more than two with each other. So edges are basically the connections, and now let me just show you there right here. So first of all, we would have some sort of a node, or you can also say the vertices, whatever name that you like, and then we are going to be creating this edge, or you can say that connections. Now we already take care of these nodes, or you can say the vertices, and now let's take care of this edge. So how we are going to be doing that? Now let me just show you how we can do that. Underneath this method, I'm going to just write a comment like this is going to be for the connection, and now let's just create our own edge. Okay, or yeah, just one edge would be fine. And it's going to be taking two parameters like vertex 1 and also the vertex 2. So now inside there, we are going to be first of all checking if there is already the vertex or not. So we are going to be using like this dot adjacency. Come on, what the hell did I just do? Adjacency list, and we're going to be passing the vertex 1 to there, and we are going to be also searching for another one. So if you also have the adjacency list of the vertex 2 as well, so you want to make sure like is there any vertex 1 and vertex 2? If there is, so we're going to be pushing our data, and we're going to be just returning true from there. And also if that's not the case, so we're going to be only returning the false value from there. So if there is the vertex 1 and also the vertex 2, so we're going to be taking that property, or you can say, yeah, we're going to be only taking that property, and we're going to be pushing the vertex 2 inside there. So we're going to be using like this dot adjacent list or adjacency list, and we're going to be passing the vertex 1. And now for this vertex 1, we're going to be pushing our vertex 2 value, and then I'm going to just duplicate this line of code, and then for the vertex 2, we're going to be pushing the vertex 1 value to that. So I'm going to save this file, and that's all the thing that you have to do. So first of all, we're going to be creating this method. It's going to take only the vertex 1 and vertex 2 perimeter. We're going to be checking for the vertex if they already existed. So we are going to be pushing for the value of vertex 1. We are going to be pushing the value of vertex 2, and for the vertex 2, we are going to be pushing the value of vertex 1. And if that's the case, we're going to be returning true, and if that's not the case, we're going to be returning false. And for the vertex 1, I'm going to define like A, and for the vertex B, we are going to be defining B. So if I just save my file and run there, and here you can see, now let me just make that a bit bigger. You can see for the vertex 1, we are now storing the value of B, and for the vertex B, we are now storing the value of vertex 1. So yeah, this is how we are going to be adding our own edges for our vertices. So now we learn about how we are going to be adding the edges, and now let's talk about how we are going to be removing those edges. So how we are going to be doing that? Now let me just show you that. I'm going to define another method which will be for removing the edge. So I'll just write like remove edge. It's going to be taking the vertex 1 and also the vertex 2. Now inside this method, first of all, we have to check like if we already have the vertex 1 and also the vertex 2, then we are going to be removing that. But if you don't have that, so we're going to be just returning false. Okay, so I'll just write like this dot adjacency list, and we're going to be checking for the vertex 1, and also for this dot adjacency list, we're going to be also checking for the vertex 2. So if we have both of them defined, so then we're going to be changing the value of that. So how we can do that? We can do that by using something called the filter method. So this is going to be a lot of fun. Now let me just show you that. First of all, we have to use like this dot adjacency list, and we have to take the value of vertex 1, which we are taking from this perimeter, and we just have to change the value of that. So how we are going to be changing the value of that? We are going to be using like this dot adjacency list, and we are going to be providing the vertex 2 value, and then we are going to be filtering, and I'm going to show you why am I filtering. Now we have to provide the value. That value is not equals to the vertex 2, so only return that. This line simply means that return everything in the array that is not equal to the vertex 2, so only return those items which are not equals to the vertex 2. So I'm going to duplicate that, and I'm going to also change the value of this one to 2, and I'm going to also change the value of the last one 1. So now what in the world is this line even means? Like return everything in the array that is not equals to the vertex 1 in this case. So return everything that is not equals to the vertex 2, and return everything that is not equals to the vertex 1. So if you do that, the final thing that we have to do is that we have to return true. And if that's not the case, so we only have to just return the false value. So now as soon as I save this file, and this is how the code will look like actually it looks a bit horrible, but trust me, it's not. And now let me just remove that from here. And to do that, I'm going to define another vertex which will be now set to C. And this line is cool, but I'm going to also duplicate that one more time. Then we're going to be defining the B, and it's going to be now equals to the C. And now let me just duplicate there. And now we're going to be taking the value of this C, and we will set there to this A. So now if I save my file and run there, and this is how our adjacency list will look like. Like we have A, which is now connected with the B and C. Then we have a B, which is now connected with the A and C. Then we have a C, which is now connected with the B and A. So that's the first thing. So now if you want to remove some specific edge from there, so I'm going to comment this line out, and I'm going to be using like g.remove edge, and we're going to be specifying like we want to remove the A and also the B from this list. So then finally we can just log that G to the console, save our file, and now it's going to totally remove this line of code right here. So if I run my code, and as you can see right here, so we have a and which is now pointing to A and C instead of that A and B, and then we have a B which is now pointing to the C, and then we have a C which is now pointing to the B and A, but we don't have any A and B. Or you can say this how we are going to be removing the edges. So I'm going to just collapse there. Okay, so welcome to the final part. So now that we learn about how we are going to be removing the edges, now let's talk about how we are going to be removing this entire vertex. So how we can do that? Well, we just have to remove that. No, we are not going to be only removing that, but instead we're going to be removing this entire connection with it. Okay, so if I want to remove this D, I also have to remove this connection, and also this connection, just like that. Okay, so then if I want to remove this A vertex, so I'm going to have to remove all of these connections. Now if I want to delete this C, so I'm going to also have to delete these two connections as well, and so on and so forth. So how we can do that? Well, now let me just show you that. And to do that, we are going to be defining yet another method which will be for remove vertex. And it's going to be taking only one parameter, which will be a vertex. First of all, we have to even check that vertex, like if this vertex is defined or not. So if there is nothing defined, well, we have to just return undefined. So let's just do that. So we are going to be using like if not this dot adjacency matrix. Why am I saying matrix? Adjacency list. So we are going to be providing our own vertex there. And if that's the case, so we have to only return undefined. And if that's not the case, so we have to iterate over through all of the adjacency vertices. So we're going to be using the for of loop for that. So I'll just write like let neighbor of this start adjacency list, and we're going to be providing that specific vertex to there. So we're going to be only taking that neighbor, and then we have to remove the edges from the neighbors list. So how we can do that? We have to write like this start adjacency list. We're going to be providing that specific neighbor which we are now getting from that specific vertex, which we are now providing as a parameter for this remove method. So we are going to be defining that, and it's going to be now equals to this dot adjacency list. And now we have to provide our neighbor right here, and then we have to filter that out. So we're going to be taking the value, and we have to check like if that value is not equals to that specific vertex, so only return that value. So it's going to just remove that element or that connection between that adjacency list. Now the final thing that we have to do is that we have to delete that vertex from the adjacency list. So how we can do that? We are going to be using delete, and then we are going to be using this dot adjacency list, and we have to provide our own vertex to there, and finally we have to just return this. Okay, so that we can see what we just removed. So there is the entire code. First of all, we have to check like the thing we want to remove already existed or not, and if that's not existed, so we are going to be returning undefined is existed. So what do we have to do? We have to iterate over through there, and we have to take the neighbors of there, and then we are going to be using a filter method on them, and we want to get only that value which is not equals to that vertex. So it's going to give us that value, and finally we have to just remove that entire vertex, and we have to return this so that we can see what is removed. So I'm going to just delete this entire thing from here, and I just realized that I made a mistake in the edge. It should be EDGA. So I'm going to copy that from here, and yeah, this is how we are going to be using that. So first of all, we have a vertex of A, B, C, and D, and then we have edges of first of all, A is now pointing to the B, A is still pointing to the C and also to the D, then B is now pointing to the D, C is now pointing to the D as well. And now if I save my file, and now if I run my, so this is what we are getting right now. We are now getting this A vertex which is now connected with B, C, and D. Then we are getting this B which is now connected with A and D. and C is also connected with A and D is also connected with A, B, and C. Now if I want to remove a specific vertex from there, so it's gonna also remove the edges or the connection between those vertices. So I'm gonna just comment this line out, and now let me just remove one of them, like g.remove vertex, and we're going to be removing only the D. And now let me just log to the console my G, and now if I now let me just console log my G, and now if I run my code, and here you can see it's not only going to be removing that specific vertex, like we only have A, B, and also the C, and now we successfully remove the D. It's gonna also remove the connections between them. So here you can see we only have like A, B, and C, and their D is totally gone, and also the connection between their D is also gone. So yeah, that was the graph. And if you like this video, so feel free to subscribe and follow me here and there, and I'm gonna see you in the next video. Bye bye. Let's talk about the most easiest sorting algorithm, which is called the bubble sort. So what is a bubble sort and how is it works? So the first thing that you have to do is that you have to take the first element, which is now set to the left, and you have to compare that with the next element, which is now set to the right. So in that comparison, you have to ask yourself, like, is this left value greater than or less than the right? So if it is greater than the right, you have to swap these values just like that. You have to swap that elements just like that. But if it isn't, so we have to go back and we have to put that as it is. But now in this situation, 4 is greater than 2, so we are going to be taking that 4 and we are going to be putting that right here for the right value, and we are going to be placing this 2 for the left. Now the next thing that we have to do is that we have to compare 4 with 6. Is 4 greater than 6 or is 4 less than 6? So 4 is less than 6, so which means like we don't have to swap anything. Now the next thing that we have to do is that we have to compare this 6 with this 5. So this 6 is greater than 5, so we are going to be swapping both of these values just like that. Okay, because 6 is greater than 5, so we have to swap those values. Now the next comparison that we have is 6 greater than 1 or is 6 less than 1. So we already know that 6 is greater than 1, so we are going to be swapping both of these values. And now the final comparison that we have is like, is 6 greater than 3 or is 6 less than 3? So 6 is greater than 3, so we are going to be also swapping these values as well. Now for the first iteration, so we are going to be getting this value. Now in the next iteration, we are going to be still asking that question like, is 2 greater than 4? Then we are going to be asking this question like, is 4 greater than 5? And then we are going to be asking this question like, is 5 greater than 1? So yeah, we already know this, so I'm not going to waste a lot of your time, but yeah, this is how the bubble sort works. So we are going to be comparing these values with each other, and we are going to be searching for the smallest value, and we will put that to the left, and we will search for the greatest value, and we will put that to the right. In the second iteration, as you can see right here, like, these two are totally sorted. Now we have to take care of this one. So yeah, this iteration will go on, and I'm going to fast forward the video right now. And here you can see this how we are going to be sorting our items, like we have 1 2 3 4 5 6, and they are now totally sorted. And that was the first sorting algorithm that we are going to be doing right now. First I will create a function. I'll give it the name of like bubble sort, and it's going to be taking an array as a parameter. And now underneath that, we're going to be creating some sort of an unsorted array, and we are going to be passing that unsorted array as an argument to this function. So now let's just take care of this function. The first thing that we have to do is that we have to iterate over through each element inside this array. So how we are going to be doing that? Well, you can do that by using a for loop, while loop, do while loop, and something like that. But in my case, I'm going to be only using a for loop. Okay, so I'll just use like let I equals to array dot length minus 1. So which means like if we have only 10 elements, we are going to be iterating over through 9. If we have 5 elements, so we are going to be iterating over through 4 elements. Okay, so that's why we wrote like array dot length minus 1. And then we have our condition like I is greater than 0, so then we have to decrement our I. Now this loop was for iterating over through each element inside our array. Now we are going to be providing yet another loop, which will be a nested loop, and that inner loop will allows us to swap those values. So how we are going to be doing that? Well, we can just write like let j is equals to 0, and then j is less than I, and finally we are going to be using j++ to increment the value of that. Okay, so how we are going to be swapping those values? As I said right here, like we're going to be starting from the first element and we're going to be comparing that with this second one. If the value of first element is greater than b, so we are going to be swapping those values. But if that's not the case, we are not going to be doing anything. So now in this case, let's just do that. We're going to be providing our if statement, and we are going to be first of all passing the array of j if that is greater than array j plus 1, which means like now this is going to be the 0 value and this is going to be j plus 1, like the second element inside our array. Now we are iterating over through there, so that's why this one will gives us the 0 and this one will gives us the 1. Okay, so now let's just do a swapping. So you can either use a shorthand, but I'm not going to do that right now, so I'll just use like let temp and I will point there to array and j. So basically it's going to give us a 0 value right here. And now the next thing that we have to do is that we have to take the value of that array and j, and which is now set to 0, and we have to set that to array and then j plus 1, like this next element. Anytime we iterate over through our element, we're going to be pointing that to our next element, just like that. And then finally we have to write our array j plus 1, and now it's going to be equals to this temp. And what is a temp? Temp is now equals to the first element or the current element inside this iteration. Now underneath there, we are going to be just returning our array so that we can see what's happening. Okay, so this is the entire code that we have to write for the bubble sort, and now let's test that. So I'm gonna just store the value of that to like in the result variable, and I'm gonna also log this rest to the console. So if I save my file and run there, and here you can see we are now getting 1 2 3 4 5 6 as a sorted array. So that was our bubble sort. Let's talk about the selection sort. So selection sort will also look exactly the same like the bubble sort, but there are just a few changes between the bubble sort and also the selection sort. So we are going to be still iterating over through each element inside our list, and we are going to be also comparing these two elements, but in this case we're going to be taking care of the minimum value. And how that's going to look like, first of all we are going to be comparing this left value with this right one, and we're going to be asking ourselves that question like, is this the minimum value or is this the minimum value? Well, obviously 2 is minimum or less than the 4. So what do we have to do in that situation? We have to provide a marker, or you can say we have to point there to this minimum value. You can even provide the label if you wanted to. So I'm gonna just provide some sort of a label like min, and now I'm gonna just put that right here up above. Now this value is temporarily a minimum value. Next we are going to be ignoring this value, so I'm going to just ignore that for a few seconds, like this one is already checked. Next we have to still compare this 4 with this 6. So we already know that 4 is less than 6, so we're not going to be doing anything inside there. We also have to compare 4 with 5. So 4 is less than 5, so we also have to don't worry about anything right now. We have to totally ignore both of them. And then now we have to compare this 4 with this 1. So now this 1 is less than 4 and 1 is also less than this pointer right here. So what do we have to do? We have to take there, we have to put that right here once again, and we have to take the pointer of there, and we have to now point there to the least value inside our list. And yeah, I'm gonna also take there, and I'm gonna just put that right here for the bottom. Now for the final check, we have to compare 4 with 3. Okay, so is 4 less than 3 or greater than 3? So 4 is greater than 3, so which means like we have to swap these values. No, we are not going to be swapping these values, but instead we have to also check the value of this minimum value with this one. So this one is less than this one, so we are not going to be taking this pointer and we're not going to be pointing there to the last one, but instead this one is the most least value or the most lowest value in this entire list, so this one wins. Now the final thing that we have to do is that we have to remove this marker, and we also have to remove this min, and we have to swap this 1 with this 4. Okay, so we are going to be taking the 4th value and we will change that to 1, and we are going to be taking this 1 value and we have to change that to 4. Now these two are totally swapped. Now the next thing that we have to do is that we have to start our comparison right here from the second element. So we are going to be comparing 2 with 6. So 2 is less than 6, 2 is less than 5, 2 is less than 4, 2 is less than 3, which means like we're not going to be providing any pointer and we're not going to be doing anything in that case. This is the least value. Next we're going to be comparing this 6 with this 5. So which means like 5 is less than 6, so we're going to be providing our pointer to this 5 right here just for a few seconds. Next we have to compare 6 with 4, so which means like 4 is less than 6 and 4 is also less than 5. Okay, so we have to put that right here on its own place, and we have to take this pointer and we have to point there to this 4. Okay, next we have to do the last comparison, which is 6, which means like 3 is less than 6 and 3 is also less than 4. So we are going to be taking this pointer and we have to point there to this element. So now finally this is the last element, so we have to do the swapping. Okay, so we have to change this 6 to 3 and we have to change this 3 to 6, just like that. Now these elements are totally swapped. Now the next thing that we have to do is that we have to compare these 3 values. So I'm going to just cut that from here. So now let's just compare 5 with 4. So 4 is less than 5. We're going to be providing our pointer to this 4 right here. Okay, now the next thing that we have to do is that we have to compare 5 with 6. So yeah, 5 is greater than 6, so we don't have to do anything in that situation. So now we are going to be just swapping the value of these two. Okay, which means like we're going to be changing the 5 value to 4 and we're going to be changing the 4 value to 5. Okay, 5, just like that. That being said, all of these values are now totally swapped. So we have 1, 2, 3, 4, 5 and 6, and they are totally swapped, and this is something called the selection sort. Let's get into the coding part. So I'm going to go ahead and create a function. I'll give it the name of like selection sort, and it's going to be taken as array. I'm going to save this file, and here is my unsorted array, and we're going to be passing that as a selection sort argument. Okay, so I'm going to pass my array just like that. So the first thing that we have to do is that we have to iterate over through each item inside our array. So how we are going to be doing that? Well, I'll just write for let I equals to 0 and I is less than array.length and I plus plus. So it's going to allow us to iterate over through each item inside our array. Next, we have to initialize variable. I'm going to give it the name of like minimum index, and it's going to be now equals to the I, the first element inside this array. This one like the first element inside this minimum index. Okay, so now that's done. Now the next thing that we have to do is that we have to create yet another nested loop, which will be the inner loop. So it's going to allow us to iterate over through the unsorted part of the array is equals to I plus 1. Remember, we are going to be now searching for this element. We are going to be totally skipping there. That's the only reason now we have like I plus 1. I plus 1. Now the next thing that we have to do is that we have to pass this condition like as long as j dot array dot length, then we have to increment over j. Next we have to provide our comparison like is this first value greater than or less than this second value. So now let's just do this. So I'm going to be providing my if statement right here, and we're going to be passing array of j is less than array of what do we call it, minimum index. So if that's the case, we are going to be changing the value of the minimum index, and we are going to be changing there to this j value. So I'm going to save this file. So now underneath this if statement and also this for loop, what do we have to do? We have to just swap our values. If I is not equals to the minimum index, let's just first of all take our element, and we're going to be storing there in the temp variable as we did in the previous challenge, and then we're going to be changing the first element inside our list to this array, and we're going to be also passing the minimum index to there. And finally we're going to be also changing the value of this array minimum index, and we're going to be pointing there to this temp. So I'm going to save this file, and now let me just go back, and that's going to be it. Okay, so now let me just run this code right here. So I'm going to just write like const res, and it's going to be now set to this selection sort, and I'm going to also pass that to the console like res. I'm going to save my file and run there, and we are getting undefined because we are not returning something from there. Okay, so I'll just return like underneath this one, we are going to be returning that array so that we can see something. And I don't know where in the world is this infinity came from, so I'll just change that to like the minimum index. I'm going to save my file, and now if I run my code, and here you can see we are now getting our sorted data right here. And that was our selection sort. Alright guys, time for the insertion sort, and this one is one of my favorite one. So now let's talk about it. So in this situation, in the insertion sort, we're not going to be taking the first element and we're not going to be comparing it with this second one, but instead we're going to be taking this second one and we're going to be comparing that with the previous one. So how that's going to look like? So we're going to be first of all taking the next element and we're going to be comparing that with the first one. So we will ask this question like, is 2 greater than 4 or is 2 less than 4? 2 is less than 4, so we are going to be swapping this value just like that. Next we have to compare 4 with 6, so we are going to be saying like, is 4 less than 6 or is 4 greater than 6? So 4 is less than 6, so we're not going to be doing anything in that situation. Next, we have to compare 6 with 5. So is 6 less than 5 or is 6 greater than 5? So 6 is less than, 6 is greater than 5. So we have to also swap this value. But here we also have to ask the question from this one, like, is 4 greater than 5 or is 4 less than 5? So 4 is less than 5. So which means like we're now going to be putting this item right here at the middle. Okay, so that's done. Next, we're going to be comparing 6 with 1. So is 6 greater than 1 or is 6 less than 1? So 6 is greater than 1, so we're going to be just taking that and put that right here. We're going to be also comparing 1 with 4, so 1 is less than 4, and also 1 is less than 2, so which means like we don't have any elements right here. We're going to be putting that right here as the first element. Okay, and now the final one we have is like 6 and the 5 comparisons. We're going to be comparing our 6 and also the 5. So is 6 greater than or less than 3? So 6 is greater than 3, so we are going to be also comparing it with 5. Is 5 greater than or less than 3? So 5 is greater than 3, and then we are going to be also comparing it with this one. Is 3 greater than or less than 4? 3 is less than 4, so we are going to be putting that right here. So finally we have to compare it with this 2. So is 2 greater than or less than 3? So 2 is less than 3, so which means like we're now going to be putting this 3 right here at the middle in this area, and this is how we are going to be sorting our elements by using the insertion sort. So we have 1 2 3 4 5 and 6 element, and they are now totally sorted. So yeah, that was the theory, and now let's get into the coding part. All right, so first of all, let's just create our function. I'm going to give it the name of like insertion sort, and it's going to be taking one parameter of array, and now we have to pass our unsorted array right here, and we have to pass that as the argument for this function, just like unsorted array. And now let's take care of the insertion sort. So the first thing that we have to do is that we have to iterate over through each element inside this array, but we are going to be totally ignoring this first element inside our array. So we are going to be starting our iteration from the second, fourth, sixth, and so on and so forth. So how we are going to be doing that? Well, we have to just write like for let I is equals to 1, not 0 but 1, and then I is less than array dot length, and then I plus plus. So this is how we are going to be iterating over through each element inside our array. And next we have to get the current element. So how we are going to be getting there? We just have to write like array and I, and it's going to give us the current element. Okay, so I'm going to just remove that from here, and I'm going to store that in the key, and you can store that in either the current variable. You can give it any name that you like, but in my case I'm going to give it the name of like key. And next we have to remove one element from the length of this array. So how we are going to be doing that? Well, we have to just write like I minus 1. So if you have 1000 elements, so it's going to only gives us 999. If you have 100 elements, so it's going to give us like 99, and so on and so forth. And now let's just store that in the j variable, just like that. Now we are going to be comparing each element in the sorted part, like the left side. So we just have to write like the while loop, and as long as j is less than or equals to 0 and array dot j is greater than the key. So in that situation, what do we have to do? We have to take the second element from the array, just like this one. Okay, so we have to take this element from the array, and we have to set there to the first element. Okay, so we are going to be taking like array and then j plus 1, and now it's going to be equals to array, and we are going to be only passing this j right here. So that's done, and finally we have to just decrement over j, and now underneath that we have to just insert that to its correct position. So I'll just write like array and j plus 1, and now it's going to be equals to the key which we've created up above, and finally we have to just return what we did. So I'm going to save this file, and now let's go back, and this is how we are going to be implementing the insertion sort. So this is how I am providing the unsorted data, and now if I store that in the variable like const res, and now let me just log that to the console like res, save my file and run that, and here you can see we are now getting the sorted array right here. So yeah, that was it about for the insertion sort. Welcome to the final part of this course. So in this section we are going to be learning about the merge sort. So what is a merge sort and how is it even works? So let's talk about it. So we would have some kind of a unsorted array, and now if you want to sort this array, first of all we are going to be using something called the divide and conquer. So how that's going to look like? We will take that array and we will divide there, or we will split there again and again until we have a single item array just like this. So as you can see right here, I have only 8 items inside there. We will split this array out into 2 multiple components. Then we will split it out into 4 components, and we will do this process again and again until we have a single item array just like this. Okay, so that's going to be the first process that we have to do. Once we split out our entire array, so we will take 2 arrays and we will sort them, and then we will combine them. So how that's going to look like, we will take these two and we will compare them with each other, and we will say like, is the left array greater than or less than the right array? So if it is greater than the left array, so we will swap this out just like this, and then we will check these two out and we will swap these two out, and these one are totally okay, so we will totally skip them out. And finally we will also check this one, and as you can see right here, we are going to be doing this process again and again until we have our sorted array just like this. Okay, so you only have to keep these two in mind. First of all, we are going to be breaking our array down into multiple arrays. Next, we are going to be sorting our array, and then we are going to be combining them back into one array just like this. Alright guys, so now let's talk about the first function that we are going to be creating. So the first function is called the merge function, and then we are going to be also creating the sort function as well, like the merge sort function as well. So now let's talk about this first function. We will also code this out, and then we are going to be jumping into that next one. So how that's going to look like, suppose we would have 2 arrays just like these. As I said, that we are going to be splitting out our one array into multiple arrays. So as you can see right here, I have 2 arrays right here which are totally sorted. So what we have to do is that we have to provide a pointer for the first element of the first array, and then we also have to provide a pointer for the first element of the second array as well. So we are going to be now comparing this item or this element with this element right here. So we are going to be comparing the first element from the first array with the first element of the second array. So we are going to be checking, is 3 greater than or less than 9? So 3 is less than 9. So we are now going to be taking this item and we are going to be putting that right here inside another array. Next, we are going to be taking this pointer and we have to point there to the next element. Now we have to check these two out. So is 27 greater than or less than 9? So 27 is greater than 9. So we are going to be taking this value and we have to put that right here because this is the minimum value, and now we are searching for the minimum value. Next, we have to take this temp and we have to point there to this 10 right here, and we're going to be comparing 27 with, and 10 is the minimum, so we're going to be taking that and we have to put that right here. We have to take our temp, we have to point there to 17, and as you can see, we are going to be comparing 27 with 17, so 17 is the minimum. We will take the value of that and we will put that right here. And by the way, this is going to be one array. I'm providing a spacing, I don't know why, but this is going to be one array. Okay, so we have to take our pointer and we have to point there to this one. So is 27 greater than or less than 82? Well, the minimum value is 27, so we will take that and we will put that right here. Then we will take our temp and we will compare with this value. This one is less than 82, and then this one is also less than 82, so we're going to be taking this value and we have to put that right here. Now we don't have any elements inside the temp1 array, and we do have element inside the temp2, so well, we don't have to compare them with anything. We have to just grab that and we have to put that at the bottom of this array just like this. Okay, so this is what we are going to be doing right now. Okay, so time to create our first function. Okay, so we are going to be creating a function, and I'm going to give it the name of like merge, and it's going to be taking 2 parameters like array 1 and array 2. So I'm going to give it the name of like left array and also the right array just like this. So we are going to be also creating a container where we're going to be storing the result of the sorted array. So I'll just write like result would be fine. And next we have to create our pointers like temp1 and also temp2. So I'm not going to give it the name of like temp1 and temp2, and I'm going to give it the name of like I, and it's going to be equals to 0, and I'm going to also create one for the j, and it's going to be now still equals to 0. So as you can see right here, I changed this one to I and I changed this one to j just like this. Now we have to use our while loop to iterate over through each element inside our array. Okay, so we are going to be using the while loop, and as long as I is less than the left dot length, okay, and come on, and j is less than the right dot length, we're going to be running this while loop as long as we have something in the left array and as long as we have something in the right array. So we are going to be running this loop. Okay, so I'll just write like if the left array and we're going to be passing our I inside there is less than the right array and we're going to be passing our j inside there. So as long as that's the case, we're going to be taking our result and we're going to be pushing our left and I to there, and finally we have to take, let me just undo all of these steps right here. So now we are comparing. So if the left value is less than, now let me just provide a less than symbol right here. So if the left value is less than the right value, so we are going to be taking the value of this left one and we will put that inside our results array. So I'll just give it the label of results, as you can see right here, and that's the first thing. We also have to take this pointer and we have to point there to this 27 as well. So we're going to be using like I plus plus. So now we are taking that pointer and we are now pointing there to this 27 right here. Okay, next we have to provide for the else clause. So for the else clause, we are going to be taking our results and we're going to be also pushing the right and also that j value for that right. If that's not the case, like if the value from the left array is not less than the right one, so we are going to be taking the value from this right and we have to also put that to this array. Okay, so we are going to be using this method for that, and finally we have to take this pointer and we have to point that to the next element. So for that we are going to be using j plus plus right here. And once we totally do that, like once we totally sort this array out just like this, let me just provide all of them right in here, and I'm going to also remove that from here. And as you can see right here, we only have one element right here inside this array and we don't have nothing inside the temp variable. So how we can solve that? Now our while loop is totally done, like we don't have any elements inside the left array. So what do we have to do in that situation? We have to use the result.push and we're going to be using the spread operator and we're going to be slicing out the I right here. Okay, so now that was for the left array, like if there is something in the left array and we don't have nothing in the right array, so this is the code for that. On the other hand, we don't have anything on the left array and we do have something on the right array, so for that situation we have to still use that same function. Let me just duplicate there and I'm going to change that to the right. Instead of providing a I, I'll provide a j right here, and finally we have to return our results so that we can see everything right here. Okay, and this is the entire code that you have to write for this merge function, and I call this function by providing these two arrays right here. And now let me just log that to the console and see what's going to be the result. So I'll just log that to the console like res. I'm going to save this file and run there, and here you can see we are now getting 3, 9, 10, 17, 27, 38, 43 and 82, which is completely sorted. So now we are taking these two arrays and we are combining them with each other and we are also sorting them out, and that was the first step in our merge sort. Welcome to the second part of our merge sort. So in this section we are going to be taking our entire array and we will split this out into two or multiple arrays just like this. So how we are going to be doing that? Now let me show you how we can do that. We already created our merge function. Now it's time to create our merge sort function. So I'll just write like merge sort function, and it's going to be taking some sort of array. And now inside there, the first thing that we have to do is that we have to provide our base case, because in this situation we are going to be using our recursion function. So for that we have to provide our base case. So we are going to be providing our base case like if the array.length, okay, if the array.length is less than or equals to 1, so in that situation we are going to be returning that entire array. Okay, so if that's not the case, so we have to divide that array into two halves. Okay, so first of all we are going to be taking the middle, so I'll just write like middle, and now it's going to be equals to array.length and divided by 2, so it's going to give us the half. But in some situation it's going to give us the floating point number, so we don't want this, so we will just use like math.floor on there, and now it's going to give us the whole number. Next we have to take out the left array, so we're going to be using like left, and it's going to be equals to array.slice, and we're going to be providing 0 and also that middle as well. And now we are going to be also getting the right, so we are going to be using array.slice once again, and we will just provide our middle value inside there. And finally we have to use our callback function and also the recursive functions as well. So for the callback function we are going to be providing a merge function which we just created, and it will recursively sort the left and the right halves. Okay, so how we can do that? We can just provide our merge sort once again like this function which we just created right here inside this merge function. So it will just recursively sort the left and also the right halves. Okay, so now we are going to be providing the left value and also for the right we have to provide that merge sort once again, and we have to provide the right value to there. And that was it about for our entire merge sort function. Okay, so first of all we created the merge function, which will allow us to combine two arrays, and first of all it will sort this out. And then we have the merge sort function, which will allow us to split out our one array into multiple arrays. Okay, so now let's just test this out. So I'm going to remove that from here, and I will just provide an unsorted array which looks something like this. And I'm going to be using like merge sort function in this situation, and I will just provide that unsorted array in this case, and I'm going to be also storing that in the sorted array, and now it's going to be equals to this function. And now let me just log to the console my sorted array, and now if I save my file and run my code, and as you can see right here, we are now getting the result of this sorted array, and it is now only one array right here. Okay, so yeah, that was it about for this entire course, and thank you so much for watching this entire course. That was a long journey, and I hope you enjoyed this video. If you do, so please don't forget to subscribe to this channel. And I'm also thinking about making an Instagram page, so if you want to follow me there, I will highly appreciate that. Otherwise, I'm gonna see you in the next course. Bye bye and love you all.